All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. In the today's session, we are going to talk about that is a rotational motion. Okay. So, I'll be smashing the rotational motion in the today's session from the scratch. If you have not studied its basics, doesn't matter. I will be start from the scratch. You'll be able to understand each and every single thing. All the problem patterns will be discussed for the NEET 2026. Every single thing I'll be discussing over here. Make sure you smash the like button and mark your attendance. So let's dive into this particular session. Okay. So when it comes to the rotational motion, the very first topic that you have, that is moment of inertia. That is moment of inertia. This is the very first topic that you have. That is moment of inertia. Okay. Just a second, guys. Just a second, guys. Let me export these files over here. Let me export these files over here. So I'll be starting from the scratch. Make sure you make the notebook along with me. Okay. Every single thing will be discussed. Okay. In detail. Every single thing will be discussed in detail. Keep that thing in your mind. Okay. Yes. Now, guys, moment of inertia. Let's take a look exactly over here. When we talk about moment of inertia, when we talk about moment of inertia, what does it actually mean? Before this moment of inertia, let's understand what inertia is. Let's understand what inertia is. What inertia is. See, guys. Let's suppose I'll keep a box over here. This is a box. This is a box. Okay. This is another box. Tell me, which of the two boxes is difficult to rotate, difficult to move? If I say you have to move these two boxes, which one is difficult to move? First or second? Sir, obviously first one is difficult to move. Second one is less difficult to move. Why? Because first one has got large mass. Second one has got less mass. Now see, we define it like this also. If its mass is large, so it will have large tendency to stay at rest. If it is at rest, it will have large tendency to stay at rest. Okay. 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 Yes. So my dear NEET aspirants, we simply say this object will have large tendency to stay at rest. This will have less tendency to stay at rest. Okay. Why? Because its mass is large, its mass is less. Now, this tendency of staying at rest is called inertia. Sir, this has more tendency. Why? Because the mass is large, inertia is large. Tendency of staying in rest is large. Like, let's suppose I'm saying the same two masses. These are moving with the velocity v. This is also moving with the velocity v. Which one is difficult to stop? Sir, obviously first one. Why not second one? Because first one has got large mass. So it is difficult to stop this object. So it has got more tendency to stay in motion. So tendency of an object to stay in a state of rest or state of uniform motion. It wants to stay in the state of uniform motion only because of inertia. So inertia is the property due to which a body wants to continue its state of rest or continue its state of uniform motion. So here tendency of staying in motion is large. Tendency of staying in motion is less. So because of inertia, inertia is large, inertia is less. Okay. Yes, that is how we define inertia. Now its rotational version is what we call moment of inertia. Its rotational version is what we call moment of inertia. Now, my dear NEET aspirants, I want you to understand one thing. Let's suppose if I say in this particular case, you have got a rod over here. Let's suppose you have a rod. This is a rod. And this is one more rod. This is one more rod. This is one more rod. This one. Now tell me in this particular case, which one is difficult to rotate? First or second? Which one is difficult to rotate? First or second? Sir, obviously, if you want to rotate this rod, which one is difficult to rotate? We say this is difficult to rotate. Difficult to rotate. This one is difficult to rotate as compared to this one, Okay. So it is difficult to rotate as compared to the first one. Now, my dear NEET aspirants, if this is difficult to rotate, so I would say this has large moment of inertia. Sir, it is same as in linear motion. Absolutely. Here, which one is difficult to rotate? Or if the rod is already rotating with constant angular velocity. Sir, which one is difficult to stop? Obviously, second one is difficult to stop. Why? Because this has more tendency to stay in a state of rest because of moment of inertia. This has more tendency to stay in a state of uniform motion because of moment of inertia. Okay. This has got large tendency. This has less tendency. Why? Because its moment of inertia is less. Less moment of inertia. Okay. I hope this is crystal and clear. So I'll write the definition over here. It is the property. It is the property due to which or it is the property, or if I'll write it like this, it is the tendency. It is the tendency of a body. It is the tendency of a body. It is the tendency of a body to continue its state of rest or state of rotational motion. Okay. What is the tendency of this object to stay in a state of a rotational motion so that it moves with a constant angular velocity? Okay. Now, guys, listen to me very carefully. Let's suppose this is the mass M. It is rotating about this line. Line means axis. We call it axis. Let's suppose this mass M. It is rotating about this axis. So this will be considered as axis of rotation. This will be considered as axis of rotation. Okay. Now, my dear NEET aspirants, we can say in this particular case, we say this is the mass and this is the distance r. This is the distance r. If I say what is the moment of inertia in this particular case, moment of inertia will be m into r square. So moment of inertia in this particular case will be I is equal to mr square. Moment of inertia will be I is equal to mr square. Okay. So mass multiplied by perpendicular distance. Let's suppose you have these moment of inertia of n objects. This is here, this object, I would say this object, this object, this object. And all are rotating about this axis. This is the axis of rotation. If I say what is the moment of inertia here, in this particular case, you can say moment of inertia in this will be moment of inertia of first mass m1 into r1 square plus moment of inertia of second mass m2 into r2 square, then m3 into r3 square, then plus m4 into r4 square. This is the moment of inertia of the collection of objects. This is the moment of inertia of collection of objects. I hope you got the feel of moment of inertia. Okay. So moment of inertia opposes the cause of change in rotational state. If you want to change the rotational state of this object, if it is at rest, it wants to stay in the rest because of moment of inertia. It is the tendency of the body to continue its state of rest or state of rotational motion. Moment of inertia of two bodies. Moment of inertia of two bodies. Understand this very carefully, my dear NEET aspirants. See, guys. Let's suppose you have a mass m over here. This is a mass m1. And you have mass m2 over here. This is mass m2. This is mass m2. Okay. And distance between the two is this. This is the distance between the two, that is r. Distance between the two is r. Distance between the two is r. Now, my dear NEET aspirants, this is center of mass. Let's suppose this is the center of mass of two objects. Okay? Absolutely, sir. Now, could you please tell me, if you consider, what is the distance of center of mass from M1? Sir, you have told us this previously. If you have to find the distance of center of mass from M1, you'll be considering this at origin, 0, 0. And this will be at 0, r, 0. These will be the coordinates. And you can find this distance. Okay. Previously, I have explained this in the center of mass. Right now, you can remember it directly, my dear NEET aspirants. You'll say, sir, this R1. This is the position of center of mass from M1. This R1 will be M2 into R upon M1 plus M2. Sir, how can we find it? You can find it M1 into R1 plus M2 into R2 upon M1 plus M2. And M1 you will be considering at origin. So for M1, we say R1 will come out to be 0. Its x coordinate is 0. M1 x1 plus M2 x2 upon M1 plus M2. Okay. Then, my dear NEET aspirants, if I say this distance R2, that is position of center of mass from M2. This distance, it will be simply, I have told you this also previously. This will be, that is M1 into R upon M1 plus M2. M1 plus M2. Now, my dear NEET aspirants, you have to find the moment of inertia. We say R1 and R2 is the distance of center of mass from M1 and M2. R1 and R2 is the distance of center of mass from M1 and M2. From M1 and M2. Now, if you ask me what is the moment of inertia about center of mass, means there is an axis which is crossing through the center of mass. So, if these two bodies, mass M1 and M2, are rotating around center of mass, what will be the moment of inertia? So, moment of inertia will be simply M1 R1 square plus M2 R2 square. This is how do we find the moment of inertia. Now, my dear NEET aspirants, this will be M1. M1 is as it is M1, then R1 square. R1 square will be M2 into R upon M1 plus M2 whole square plus. Then we say M2. We say into R2 square. What is the value of R2? That is M1 into R upon M1 plus M2, its whole square. Now, my dear NEET aspirants, I will come out to be, see, after solving this and this, so directly you remember M1, we say M2 divided by M1 plus M2. M1 into M2 upon M1 plus M2 multiplied by, I would say, R square. Multiplied by, I would say, R square. This is the most important expression. This is the most important expression which, and this was asked in, I would say, NEET 2016 and 2019. This is the most important expression which you guys need to keep in your mind. Everybody out there. Okay. Okay. Yes. Now, guys, next one, moment of inertia of an object with coordinates x comma y. See, guys, moment of inertia of an object with coordinates x comma y. Let's suppose this is x-axis, this is y-axis, and this is z-axis. There is a point over here. Its coordinates are x and y. This distance from here to here, it is x. This distance from here to here, it is y. Because its y coordinate is y. Y coordinate means how far it is from the origin in y-axis. If, let's suppose, I say this mass rotates about x-axis, around x-axis. What is the moment of inertia of this mass around x-axis? You say moment of inertia is simply m into r square. R is the perpendicular distance. You'll say, sir, m is the mass. And what is the perpendicular distance from x-axis? That is y. So this is moment of inertia about x-axis. So m into y square. If I say about x-axis, moment of inertia of this mass about x-axis. Okay. So this about y-axis, it will be m into, I would say, guys, what is the perpendicular distance from here to here? That is x. So m into x square, Okay. Absolutely. Just a second. Okay. Yes. So this is the moment of inertia about x-axis. Okay. And this is the moment of inertia about y-axis. Moment of inertia about x and moment of inertia about y. Now, my dear NEET aspirants, what I want you guys to understand, moment of inertia of an object, moment of inertia of an object, moment of inertia of an object about x, y, and z. Moment of inertia of an object about x, y, and z. Okay, yes. See guys, let's suppose you have x-axis, you have y-axis, and you have z-axis. Understand this very carefully. You have a mass over here. Its x coordinate is x, y, and z. It is in 3D. It's in 3D. This is x, this is y, this is z. Object is somewhere around over here. Okay. So it has x, y, as well as z coordinate. Now, in this particular case, you directly remember this. We say perpendicular distance of this object from x-axis. That is what we call r perpendicular. This will be under root of y square plus z square. Okay. This mass has a perpendicular distance from x-axis. How much? Under root of y square plus z square. Similarly, perpendicular distance from y-axis, that is under root of x square plus z square. See guys, I'll write moment of inertia about x-axis. About x-axis. Ix. That will be mass into r perpendicular. What is the perpendicular distance of this mass from x-axis? You will be directly remembering under root of y square plus z square. M into, and its square, under root of y square plus z square and its whole square. Square and root will cancel, so it will be m into y square plus z square. And then if I say moment of inertia of this about y-axis, guys, you'll say moment of inertia about y-axis is m into r perpendicular. M into r perpendicular. So r perpendicular will be under root of x square plus z square. Its whole square. Square and root will cancel. So y will come out to be m into x square plus z square. Okay. Then about z axis, I would say iz will be mass into under root of x square plus y square, its whole square. About z, then you have to take which coordinate? X and y. Square and root will cancel. Moment of inertia about this is m into x square plus y square. Something like this. Okay. See the question. Question is 2 kg object. 2 kg object is placed at 2, 3, 3, minus 3. Okay. Find the moment of inertia about y-axis. Find the moment of inertia about y-axis. Okay. You have to tell me the moment of inertia about y-axis. You have to tell me the moment of inertia about y-axis. Okay. Now guys, see. When it comes to the moment of inertia about y-axis, listen carefully. Iy. That is going to be m into. Guys, what is the moment of inertia about y-axis? M into x square plus z square. M into x square plus z square. So what is mass? That is 2. X square plus z square. Guys, what is the x coordinate over here? X coordinate in this case is 2. Z is minus 3. So that is 2 square plus minus 3 square. So it will be 2 into 2 square is 4. 3 square is 9. 9 plus 4 is 13. 13 into 2 is, that is 26. Okay. And if you ask me what is SI unit? Guys, moment of inertia means mass into perpendicular distance square. Mass is kg and distance is meter, kg per meter, and it's square, kg meter square. So kg meter square. Absolutely. Okay, let's talk about this one. Let's talk about this one. Find the moment of inertia about the axis of rotation. This is the mass. These are basically the three masses. This one, and this one. Okay. You have to tell me what is the moment of inertia in this particular case. Guys, if the mass is present at the axis of rotation itself, in that particular case, we say moment of inertia of that mass will be zero. In that case, moment of inertia of that mass will be zero. Okay. Absolutely. So, what I'm trying to say in this particular case, boys and girls, what I'm trying to say in this particular case, boys and girls, is that, listen carefully, we say moment of inertia of this mass will be zero. What is the moment of inertia of this mass? Mass into perpendicular distance, that is a, m into a square. So I'll be writing net moment of inertia will be, for first mass it is 0, plus for second mass m into a square, plus for this mass, guys, if this is a, this is also a, this is also a, and this is an equilateral triangle, this is 60. Listen carefully, my dear NEET aspirants, I'll make you understand. If this is a, this component is going to be a sine 60, this is going to be a cos 60. This is a cos 60. This is going to be a sine 60. Absolutely, sir. Now, if this is a cos 60, so you need to make this over here also. So, if you extend this, so what I can say, this will be also how much? That is, this is r perpendicular. So, what is the value of r perpendicular? A cos 60. So, m into a cos of 60 whole square. So, net moment of inertia will come out to be, that is m into a square plus m into a cos 60 is root 3 by 2. So, that is a square. Root 3 by 2 whole square will be how much, guys? No, sorry, cos 60 is 1 by 2. 1 by 2, that is 1 by 4. So, this is going to be ma square by 4, that is ma square plus ma square by 4, that is 4ma square plus ma square is 5ma square divided by 4. This is net moment of inertia. Okay, let's talk about this one. Find the moment of inertia about the axis of rotation. Take a look, guys. This is mass m, this is mass m, this is mass m. Okay. You are supposed to tell me the moment of inertia about this axis. About this axis. Okay. Listen, guys, very, very, very carefully. If this is total A, this will be A by 2. This is also A by 2. So if I say what is the net moment of inertia? What is the moment of inertia due to this mass? 0. Plus, what is the moment of inertia due to this mass? Mass into A by 2 ka whole square. Mass into A divided by 2 ka whole square plus. What is the moment of inertia due to this mass? Mass into A by 2 ka whole square. That is m a square by 4 plus m a square by 4. Ma square by 4 plus ma square by 4. That will be ma square by 2. As simple as that. Ma square by 2. Net moment of inertia. And for this, it will be 0. Okay. Why? Because it is passing through the center of mass. It is passing through the axis of rotation. What is the moment of inertia about this we done? What is the moment of inertia about this axis? For this mass, it will be 0. For this mass, it will be 0. Why? Because they are placed on the axis of rotation. Then you have to see for this mass. Guys, if this is A, this is 60. This component is going to be how much? A sine 60. Because this component is how much? A cos 60. So I can say moment of inertia is mass into perpendicular distance square. So this mass into perpendicular distance square, that is A sine of 60 its whole square. M into A sine 60 is root 3 by 2 its whole square. This will be M A square into 3 divided by 4. That is 3 by 4 M A square. I hope this is clear. I hope this is crystal clear. Okay, absolutely, sir. Okay, before this question, let me show you more on the triangle. Now see guys, let's suppose the question is something like this. There's a triangle, okay? There's a triangle. And in this particular case, what I'm trying to say is that, let's suppose there is mass here, there is mass here, there is mass here. And you have this point, okay? This is the axis of rotation which is passing through this point. There's a very good question. Okay, let me show you this. This one. Something like this. Something like this. So it is passing through the center actually. It is passing through the center actually. Now you have to tell me in this particular case what is, so this is a triangle. It is crossing the center of the triangle. You have to tell me what is the moment of inertia about this axis. Moment of inertia about this axis. Okay, just a second, guys. Okay, now guys, if this is A, I have told you previously, if this is side A, from this side till here, this is going to be A divided by root 3. A divided by root 3. Okay, it is going to be A divided by root 3. And my dear NEET aspirants, this will be how much? This will be how much? This will be also A divided by root 3. Even this distance will be also how much? A divided by root 3. And this is a perpendicular distance. Okay, this is a perpendicular distance from this point to this point. Okay. Now, if I say what is the net moment of inertia in this particular case, you say m into perpendicular distance square, A divided by root 3, its whole square. Then plus, due to another mass, m into A divided by root 3 whole square plus m into A divided by root 3 whole square. So this will be 3 times, I would say, m A square by root 3, that is A square divided by 3. 3 and 3 will be cancelled. So it will be m into A square. M into A square. I hope you are getting me what I'm trying to say. I hope you are getting me what I'm trying to say. Okay. This was the question. Okay. Let's suppose the question is something like this. See, guys, let's suppose the question is something like this. The question is something like this. This is M, this is M, and this is M. And in this particular case, my dear NEET aspirants, what I want you to understand is, let's suppose the axis is passing through this mass. The axis is passing through this mass. Okay, something like this. You have to tell me in this particular case, what is the moment of inertia? What is the moment of inertia? Okay, this is the question. First and the foremost thing, moment of inertia about this mass will be zero. Moment of inertia of this mass will be zero. Why? Because axis is passing through this mass. Moment of inertia will have this mass, that is A, this A. Sir, is this the perpendicular distance? Absolutely, because it is in 3D. This also, yes. Don't say, sir, it is not making 90. This is not the angle. It's in 3D, bro. It's in 3D, bro. It is something like this. It is 90 degrees. Okay. So in this particular case, when I say net moment of inertia, that will be m into a square plus due to another mass m into a square, and due to third mass it will be 0. That is 2ma square. 2ma square is the moment of inertia. Okay, absolutely. Let's suppose you have this question. You have this question. You have mass m, you have mass m, you have mass m, you have mass m. And I am saying that the axis of rotation is passing something like this. This is the axis of rotation. This is the axis of rotation. So this is the axis of rotation. This is A, this is A. Don't you think that in this particular case, moment of inertia of this is 0, moment of inertia of this is 0. So what I can say, net moment of inertia will be due to first mass m into a square plus due to second mass m into a square. Due to this mass it will be 0, due to this mass it will be 0. So it is going to be 2m into a square. 2m into a square. Okay. Yes. Yes, absolutely. Okay, let's suppose you have this question. Take a look at this question first. If this square is rotating something like this, what is the moment of inertia of this mass? 0. What is the moment of inertia of this mass? 0. And if I say, how much is this distance and how much is this distance? Sir, entire diagonal is, if this is a root 2a, this will be a divided by root 2, half of the diagonal. This is also a divided by root 2, half of the diagonal. When I say net moment of inertia, it will be simply like, sir, moment of inertia due to this will be m into a by root 2 whole square. M into a divided by root 2 whole square plus m into a divided by root 2 whole square. That is a square by 2. So this is m a square by 2 plus m a square by 2. It is going to be 2 times ma square by 2 plus ma square by 2. That is m into a square. Okay. Let's suppose I give you the question something like this. Take a look. Okay. This is mass m. This is mass m. This is mass m. And this is mass m. And it is crossing the center actually. Okay. This is passing through the center actually. It is passing through the center actually. Something like this. It is passing through the center actually. Okay. Something like this. This is A. Could you please tell me how much will be this distance? A divided by root 2. So what is the moment of inertia? Listen carefully, guys. What is the moment of inertia due to this mass? M into A by root 2 ka whole square. What is the moment of inertia of this mass? M into A by root 2 ka whole square. Moment of inertia of this mass. M into A by root 2 ka whole square. Moment of inertia of this mass. M into A by root 2 ka whole square. So we can say net moment of inertia is M into A divided by root 2 ka whole square. And I would say multiplied by 4. Multiplied by 4. So what I can say, net moment of inertia is, okay, because it is 4 times, na? 4 times of ma square divided by 2. Because if you do the squaring of root 2, it will become 2. Now 2 ones are, 2 twos are 4. Net moment of inertia is going to be 2 ma square. I believe this is clear. This question is also clear. There was a question which was asked in JEE 2024. See the question. See the question that was asked. Find the moment of inertia. Find the moment of inertia about the axis of rotation. There's a question from JEE 2024. See guys, this is a square. This is a square. And its mass is m, its mass is m, its mass is m, and its mass is m. And the axis is passing through this. Let me show you. Something like this. Axis is passing through this mass. Something like this. Okay. And this is side A. This is also A. When I say net moment of inertia due to this mass will be 0. Moment of inertia due to this is ma square. Okay. Due to this will be how much? M into a root 2 square. Let's write first m into a square plus, what is the moment of inertia due to next one? M into root 2a whole square, because this distance is root 2a and this distance is a. So plus I would say m into a square. Ma square plus ma square is 2ma square plus root 2a whole square, that is 2m a square. So total is 4m a square. Okay. And in this particular case, mass of each mass is given as 1 kg and value of A is given as 2 meters. So put it over here. So 4 into mass is given as 1 and this is given as 2 square. 2 square is 4, 4s are 16 kg meter square is the moment of inertia. 16 kg meter square is the moment of inertia. Okay. Absolutely. See guys, let's suppose you have a plate over here. Listen guys carefully. Let's suppose you have a plate over here. This is the plate. Okay. Yes. Yes. Now, this is the axis of rotation. I'm making this axis. I'm making this axis. These are the two axes of rotation in this particular case. These are the two axes of rotation that I'm making over here. Okay. Okay. This is, let's suppose, A, this is B, this is C, and this is D. In this particular case, you guys are supposed to tell me along which axis, okay, moment of inertia will be more, moment of inertia will be less. Along which axis moment of inertia is less. See guys, when it comes to this AB, when it comes to this AB, okay, we say moment of inertia along this AB will be less. Why? Because how do we define moment of inertia? I is equal to m into r square. M is the mass, r is the distance. If I say mass is very much away from the axis of rotation, so r is large, so moment of inertia will be large. More is the mass away from axis of rotation, more is going to be the moment of inertia. Okay. More mass is away from the axis of rotation, more is going to be the moment of inertia. Now, if you check over here, in this particular case, mass is basically displaced. Mass is basically present till here. Let's suppose this is 2 meters. But when you take this axis, in this case, mass is present till here. This can be 4 meters. So here distance is large. So in this particular case, mass is distributed over large distance. Okay. So I would say moment of inertia about AB is less, because mass is near to the axis AB. In this case, mass is distributed over large distance. So that's why moment of inertia will be more. Okay. This question is also an important question. You guys need to keep this in your mind. Okay. Let's suppose if I give you this question, guys, take a look. Let's suppose you have a disk. There's a disk. Okay. Now I'll take different points on the disk. I'll take different points on the disk. Okay. This is point B. This is point C. This is point C. This is point A. And this is point D. You have to tell me the moment of inertia of uniform circular disk is maximum about which axis? The moment of inertia of a uniform disk is maximum about which axis? So these are basically the axes B, A, D, C. Okay. About which axis? You have to consider that axis. See. If you consider this A, sir, mass is distributed here. If you consider this B, you can see mass is distributed over a large distance. Array, sir, yes. So I can say its answer is B. I would say axis B. Because mass from B is distributed over a large distance. Is distributed over a large distance. Okay. I hope this is crystal clear to each and every single student. Let's move on to the parallel axis theorem. Okay. Then you have perpendicular axis theorem. You have parallel axis theorem, you have perpendicular axis theorem. And parallel axis theorem, when we define it, is the most important concept in your entire physics. Okay. In your entire rotation. Very important. You can expect the question from this particular topic. For sure. Okay. Absolutely, sir. Without a shadow of doubt, sir. Just a second, guys. Just a second, guys. Hold on a second. Okay, let's take a look at this particular question, guys. Parallel axis theorem. What does parallel axis theorem say? See, I'll make you understand. Let's suppose we have a body over here. We have a body over here. And this body is having, this is the center of mass. Let's suppose there is an axis passing through the center of mass. There is a line passing through the center of mass. Yes. So this will be the moment of inertia about this axis, center of mass. Yes. Now from this center of mass, you move at a distance of d. Make sure you are moving parallelly. Not like this, not like this, but like this, like this. Okay. Then, my dear friends, this is the point, let's suppose P. Now, one more axis is passing through this point. Axis passing through this point. Consider a line passing through this point. Now, I am asking you, what is the moment of inertia about this point? About this axis? This is the question. Now, when it comes to the parallel axis theorem, guys, I'll write over here. If we have to find the moment of inertia about an axis, okay, passing through any point, listen to me very carefully. I'll just write a statement over here. I would say, if you know the moment of inertia about the center of mass, you can find the moment of inertia about this point, about this axis, which is passing through point P. Guys, if we know the moment of inertia about center of mass, if you know the moment of inertia about center of mass, then we can find moment of inertia MOI about point P, about an axis which is passing through point P. Sir, how? By parallel axis theorem. By parallel axis theorem. So parallel axis theorem says moment of inertia about that point. It will be moment of inertia about center of mass, if you know it, plus mass of the body multiplied by d square. D is the perpendicular distance, or this distance between the two axes. This is what we call the parallel axis theorem. So what does parallel axis theorem say? If you know the moment of inertia about an axis, passing through the center of mass, okay, then you can find the moment of inertia about an axis which is passing through point P. That is IP is equal to ICOM plus MD square. Okay. So I'll just write over here, two axes must be parallel. Two axes must be parallel. Okay. Two axes must be parallel. And then, my dear NEET aspirants, we say second point is this axis and this axis must be parallel. Okay, this is a condition. This is a condition. Okay. Next point is one axis must pass through center of mass. One axis must pass through center of mass. Next, D must be the perpendicular distance between them. D must be the perpendicular distance between them. D must be the perpendicular distance between them. Okay. D must be the perpendicular distance between them. Then, my dear NEET aspirants, okay, before this, let's move on to the perpendicular axis theorem. What does perpendicular axis theorem say? Guys, see, we say according to this theorem. I hope you got the parallel axis theorem. So parallel axis theorem says, if you know the moment of inertia about center of mass, then you can find the moment of inertia about that point, which is parallel to the previous axis, center of mass axis. Okay. Now, according to this theorem, what does this theorem actually say? It says moment of inertia about x-axis. Okay. Moment of inertia about x-axis. Then moment of inertia about x-axis plus moment of inertia about y-axis. It will be equals to moment of inertia about z-axis. Moment of inertia is about x plus moment of inertia about y will be equals to the moment of inertia about z-axis. Okay. 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 X-axis plus y-axis is equal to z-axis. Now, guys, see. If let's suppose you are taking a disk over here. This is the z-axis. So moment of inertia about z-axis is iz. This is x-axis. Moment of inertia about x-axis is ix. This is y-axis. Moment of inertia about y-axis is iy. Ix, iy, iz. So this is ix, this is iy, and this is iz. Now, my dear NEET aspirants, what I'm trying to say in this particular case, is that, listen to me very carefully. This is the perpendicular axis theorem. This is the perpendicular axis theorem. But there is a condition over here. There is a condition over here. It is valid for 2D objects only. It is valid for 2D objects like disk, you have plate, 2D objects only. Okay. And in this particular case, all the three axes must be mutually perpendicular to each other. All the three axes must be mutually perpendicular to each other. All the three axes must be mutually perpendicular to each other. Yes. All the three axes must be mutually perpendicular to each other. Okay. Next, x and y axes must be in the same plane. X and y must be in the same plane. What does that mean? What does that mean? See, this is on this plane. Must be in the same plane. If this is the plane of the disk, if this is x, this should be y. In the same plane. It is not, y cannot be like this. Okay. And z-axis must be perpendicular to x and y axis. Z-axis must be perpendicular to x and y axis. Crystal clear? So this is ix, this is iy. They are making 90 with each other. And this is iz. This is iz. Okay, so this is the perpendicular axis theorem. These are the conditions. So perpendicular axis theorem says Iz is equal to Ix plus Iy. Parallel axis theorem says, sir, I perpendicular moment of inertia about point P is equal to moment of inertia about center of mass plus I would say md square plus I would say md square. Okay. I believe this is clear. This is perpendicular axis theorem and this is parallel axis theorem. Okay. So this I'm shifting here. Okay. So guys, let's take a break of 10 minutes. Let's take a break of 10 minutes. Now guys, let's take a look over here. Let's take a look on this. Now guys, take a look. Moment of inertia of a ring. This is a ring. Okay. This is an axis which is passing through its center of mass. If I say what is the moment of inertia of this ring about its center of mass? Sir, moment of inertia of the ring about the center of mass, it will be simply m into r square, where m is the mass of the ring and r is the radius of the ring. You'll be simply saying, sir, moment of inertia of the ring about its axis which is passing through the center of mass is m into r square. Okay, I'll mention over here. This is the moment of inertia of a ring. This is the moment of inertia of a ring about an axis passing through the center of mass. This is the moment of inertia of an axis passing through the center of mass. Okay, yes. Now, my dear NEET aspirants, let's suppose if somebody asks you, what is the moment of inertia of this ring about the diameter? If this is the ring, so this is the moment of inertia about the center of mass. This will be the moment of inertia about diameter. This is, you can say x, this is, you can say y. So about diameter we have to calculate. I'll use I would say perpendicular. I'll use perpendicular axis theorem. I'll use perpendicular axis theorem. What does perpendicular axis theorem say? Moment of inertia about z-axis will be equals to moment of inertia about x-axis plus moment of inertia about y-axis. Now guys, this is the moment of inertia of the ring about an axis passing through the center of mass. You can consider this as Iz. You can consider this as Iz. You can consider this as Iz. Okay. You can consider this as Iz. Okay. This one. Because it is actually perpendicular to this ring. Yes. So this is ICOM. In this particular case, this Iz, you can say this is ICOM is equal to moment of inertia about x-axis. Sir, x-axis means this is the diameter. Yes. Even sir, don't you think that I can consider this also as diameter? Why? Oh, diameter is this also, whatever you want to say. So this is plus, I would say ID. Plus ID. Now tell me how much is this? This is m into r square is equal to 2 times of ID. So moment of inertia about diameter will be m into r square divided by 2. This is the moment of inertia about the diameter, and this will be moment of inertia about x-axis. This will be the moment of inertia about y-axis. Because diameter is x also, diameter is y also. Okay. Now guys, find the moment of inertia of a ring about an edge parallel to the plane. About an edge parallel to the plane. Okay. Now guys, see, listen to me very carefully. This is the ring. If I say this is the axis which is passing through the diameter. See guys, this is the axis which is passing through the diameter. Now my dear NEET aspirants, listen to me very carefully. If I say, sir, Is this axis the x-axis or y-axis? You can consider this x, diameter axis, x-axis. And my dear NEET aspirants, is it passing through the center of mass? Yes, absolutely. An axis can pass through the center of mass like this also, like this also. This is also passing through the center of mass. Sir, is this passing through center of mass? No, no, no. Sir, is this passing? Yes, yes. It is also passing through the center of mass. This is also passing through center of mass. Okay. So you can consider this as I diameter right now. You can consider this as ICOM right now. Absolutely, sir. You can consider this as, we can say IX right now. Sir, but this is also moment of inertia of center of mass. Guys, see, this is the moment of inertia of a ring about an axis passing through the center of mass. I'll add one more point, perpendicular to the ring, perpendicular to the plane. Okay, this axis is perpendicular to the plane. This point is very important because this you can also consider as ICOM. But this is parallel to the plane. This is parallel to the plane. Keep that thing in your mind. And this is I edge. This is the axis passing through the edge. You have to find moment of inertia about this. And this is the radius of the ring. That is R. That is R. So I would say use parallel axis theorem. Okay. So parallel axis theorem says that moment of inertia about the edge will be moment of inertia about center of mass plus I would say md square. Okay. So moment of inertia about an edge, it is moment of inertia about the center of mass. So what is the moment of inertia about this diameter? That is mr square divided by 2 plus m into d square. D is the perpendicular distance, that is r square. Now guys, tell me, 2mr square plus mr square is 3mr square by 2. So I edge is going to be 3mr square divided by 2. This is the moment of inertia about an axis which is passing through the edge of the ring, which is passing through the edge of the ring, which is passing through the edge of the ring. Okay. Let's suppose the question is something like this. Let's suppose the question is something like this. Take a look, guys, in this particular case. Let's suppose the question is something like this. Let's suppose I'm creating a ring over here. Okay. This is a ring. This is a ring. Okay. This is a ring. And in this ring, what I am doing is that I'm taking two axes. This axis. Okay. So the question here I am saying, find the moment of inertia of a ring about an axis. Question is, see guys, question is, find the moment of inertia, find the moment of inertia of a ring about an axis, okay, find the moment of inertia of a ring about an axis passing through its edge, passing through its edge, okay, perpendicular to the plane of the ring, perpendicular to the plane of the ring, perpendicular to the plane of the ring. Okay, now guys, see, this is, you can consider as IZ, you can consider this as ICOM. And how much it is? It is mr square. M is the mass and R is the radius. Okay. Now you have to find about this axis. about this axis. Okay. Now guys, see, in this particular case, the question is moment of inertia of a ring about an axis passing through its edge, but perpendicular to the plane. But here, moment of inertia of a ring about an edge parallel to the plane. This here also it is touching the edge, but it is parallel to the plane. Guys, see. It is like this. It is touching the edge, but parallel to the plane. This is the plane. This is the plane, parallel to the plane. When I say passing through the edge, but perpendicular to the plane, this one. Okay. I believe this is clear. Now tell me, how do we find this actually? Guys, how much is this? This is R. Use the perpendicular axis theorem. So that is moment of inertia about the edge is equal to moment of inertia about center of mass plus, I would say, md square. Okay. IE is equal to moment of inertia of center of mass. Okay. Moment of inertia about center of mass, that is mr square, plus moment of inertia about this edge. So this is moment of inertia about the center of mass, that is mr square. Okay. Then plus md square. So I can write over here m into r square. So I edge will be 2mr square. So this is the answer to this particular question. I hope this is crystalline clear. Okay. Okay. Yes, absolutely. Now guys, take a look. The question over here is, okay, let's first take a look at this. Moment of inertia of a disk. This is a disk. Okay, this is a disk. It's not ring. Its mass is m and radius is r. This is the axis of rotation. Okay. About this axis, it is rotating. Okay. Now, my dear NEET aspirants, moment of inertia of a disk. If I say, when it comes to the moment of inertia about the center of mass, okay, but moment of inertia about the center of mass, which is perpendicular to the plane, okay. So I'll write over here, that is moment of inertia about center of mass perpendicular to the plane, that is ICOM. This ICOM, my dear friends, in this particular case will be m r square divided by 2. You'll be remembering this for the disk. This is a moment of inertia about an axis passing through the center of mass and perpendicular to the plane in case of a disk. Now guys, take a look. Let's suppose if I say the similar question, find the moment of inertia of a disk about its diameter. Means you have to tell me moment of inertia about x-axis, about y-axis. Again, I can use the same, I can use the Which one? Parallel axis theorem. Perpendicular axis theorem. Use perpendicular axis theorem. What does that say? Moment of inertia about z-axis is equal to moment of inertia about x-axis plus moment of inertia about y-axis. Okay? Plus moment of inertia about y-axis. Now, my dear NEET aspirants, what I want you guys to do in this particular case, what is the moment of inertia about z? That is m r square divided by 2 is equal to, what is the moment of inertia about x-axis? Sir, moment of inertia about x you can consider diameter, about y you can consider diameter, both are diameter. This is also id. So you'll be like, sir, this is id plus, I would say, id. So this is 2 times of id. So this will be mr square divided by 2 is equal to 2 times of id. Take this 2 over here. So moment of inertia about diameter will be mr square by 4. 2 into 2 is 4. And this is id means moment of inertia about x, moment of inertia about y. I hope this is clear. Similar question once again in case of a disk. In case of a disk. Take a look, my dear NEET aspirants. You have a disk over here. This is I diameter. Okay, this is I diameter. And this is IE. I want you guys to do one thing in this particular case. That is, you have to tell me what is the moment of inertia about the edge. Now see, find the moment of inertia of a disk along its edge parallel to the plane of the disk. So it is parallel to the plane of the disk. Okay, yes. Now guys, see. What I'll do in this particular case is, we say use parallel axis theorem. So what does parallel axis theorem say? Moment of inertia about edge will be moment of inertia about center of mass plus m into d square. Okay, this one. Now guys, radius of this is r. This radius is r. This you can consider as ICOM. Why? Because it is crossing through center of mass. So I edge you need to calculate. So this will be I edge is equal to ICOM, moment of inertia about center of mass. That is m r square divided by 2. mr square divided by 2. That is mr square divided by 2 plus m into d square. So that is m into r square. M into r square. So I edge will come out to be mr square by 2 plus mr square by 2. 2mr square plus 3mr square. That is going to be 3mr square divided by 2. Okay. I hope this is crystal and clear. This is 3mr square divided by 2. 3mr square divided by 2. Okay. Yes, absolutely, sir. Now, guys, take a look in this particular case. There is a question over here. This was the question which was asked in JEE Mains 2022. Now, see, what is the question which was asked? What is the question which was asked? Moment of inertia of a disk of mass m and radius r. About its diameter is mr square by 4. Moment of inertia about its diameter is mr square by 4. Okay. Absolutely. The moment of inertia of this disk about an axis normal to the disk, about an axis normal to the disk, passing through a point on its edge. Passing through a point on its edge. Okay. Passing through a point on its edge will be x square upon x square by 2 into mr square. Find x. You have to tell me x. Guys. In nutshell, the questioner is asking what is the moment of inertia about this axis. What is the moment of inertia about this axis? Okay. I edge it is asking. But what is given in this particular case, this is not the correct diagram for this. Moment of inertia of a disk is m. About its diameter, it is mr square by 4. Okay, cool. You have to tell me. Okay, normal to the disk. Oh, diagram is correct. The moment of inertia of this disk about an axis normal to the disk. Passing through one point. Okay, guys. In this particular case, they are given you moment of inertia about diameter. That is mr square by 4. If about diameter it is mr square by 4, we know about z-axis or about an axis which is passing through the center of mass and perpendicular to the disk, it is mr square by 2. It is mr square by 2. So they are asking what is the moment of inertia about this edge. Okay. Now guys, wait. I'll make you understand this particular concept. I'll make you understand this particular concept. See. Listen carefully. Everybody out there. Everybody out there. See guys. See. In this particular case, what I want you guys to do is, you have to find moment of inertia about this edge. Okay. You know moment of inertia about center of mass plus md square. Perpendicular axis theorem. So this distance is r na radius. So this is ICOM. So if you know the moment of inertia about center of mass, you can find the moment of inertia about an axis which is parallel to that. So I edge in this particular case will be, this is mr square divided by 2 plus m into r square. So this will be 2 mr square by ICOM. Here I have made a mistake. What is the moment of inertia about the diameter? That is mr square by 4. So here I need to mention mr square by 4, not 2. Mr square by 4, then plus mr square. Because this is the moment of inertia about that edge which is passing through its one edge, and parallel to the plane. So here it will be mr square by 4 because this will be mr square by 4. So here it is going to be 4 mr square plus mr square is 5 mr square by 4. Now this is the question. So this is 2 mr square plus mr square. That is 3 mr square divided by 2. This is the answer to this question. Here. Sir, what is the difference between this question and previous question? Here also it is passing through the edge, but it is perpendicular to the plane. Here also it is passing through the edge, but it is parallel to the plane. That is the difference. Now, it is given in the question from there only. X square by 2 mr square. So what is the value of x? 3. So value of x is 3. This was the question. I hope you got the feel of this particular question in this particular case. Okay. There is a question over here which I would like to ask you in this particular case, in case of this disk. See guys, I'll just write over here this question. This is a previous year question. See the question. Take a look at the question. Take a look at the question. We said 2 iron solid discs of negligible mass. Okay. Of negligible thickness, sorry. Having radius R1 and R2 and moment of inertia I1 and I2 respectively. For R2 is 2 times of R1. The ratio of I1 and I2 would be 1 by x. Find the value of x. I'll directly make the diagram. See, I'll make the diagram. See guys, you have got a disk over here. This is a disk. Okay, this is a disk. Okay. Now, this is the axis of rotation. This is the axis of rotation. This is the axis of rotation. Okay. Yes. This is the axis of rotation. Yes. These are the 2 disks. In this particular case, it says a radius of this disk is R1 and radius of this disk is R2. And the questioner says that, that this R2 is 2 times of R1. This is given. 2 disks. 2 disks. And the question This is two discs. And it says moment of inertia here, it is I1, moment of inertia of this is I2. Okay. Okay. Absolutely, sir. Absolutely, sir. Okay. Now, in this particular case, they are asking us to find I1 divided by I2. It is given as 1 by x. So, find the value of x. This is the question. Okay. Now, my dear NEET aspirants, in this case, is the mass of the disk given? No, mass of the disk is not given. Let's find the mass of two disks. How do we find the mass of two disks? Guys, understand this very, very, very carefully. We say density is equal to mass upon area. Okay. Mass per unit area. And we write, when it comes to the density, we write sigma, mass per unit area. Okay. Okay. Now, my dear NEET aspirants, this I have told you previously, sigma means mass per unit area. When the mass is present on the length, in that case, we say mass divided by length, that is lambda. If I say mass is present on the area, here it is a disk, mass is present on the area. So it is mass by area. If the mass is present in the volume like sphere, over there we say rho is mass by volume. So mass will be is equal to sigma into area. Now this is sigma. If I say M1 will be sigma into, what is the area? 4 pi r square. Area of disk 4 pi r square. So 4 pi r1 square. What is the mass M2? Disk M2. That is sigma 4 pi r2 square. Sir, why are you taking the sigma constant? These are two iron disks. So if the material is same, so density will be same. Material is same, so density is going to remain the same. This is M1, M2. Absolutely, sir. Now, my dear NEET aspirants, what I can write over here in this particular case, if you clearly see over here, sir, M2 is rho 4 pi r square. Sorry, sigma 4 pi r square. So, sigma 4 pi into r2 square. Okay, so this you can write as sigma 4 pi, and r2 is 2 times of r1 because it is given whole square. So it will be 2 square is 4. So 4 times of 4 sigma pi r1 square. It is something like this. So can I not write, sir, this M2 will come out to be 4 times of M1? Absolutely, sir, without a shadow of doubt, sir. Yes. Now, guys, if I say in this particular case, could you please tell me what is the value of I1 divided by I2? What is the value of I1 divided by, I would say, I2? I1 by I2 means simply mass per unit. I1 by I2 is M. What is the value of moment of inertia of disk? Sir, that is M R1 square divided by 2 upon M R2 square divided by 2. Because moment of inertia of first disk is mr square by 2, mr square by 2. So I can write it like this. Now tell me, guys, this 2 and this 2 will be cancelled. So this is M1, this is M2. So what I can write over here, this will be M1 R1 square divided by M2. What is the value of M2? 4 times of M1. What is the value of R2? This is 2 times of R1, its square. Absolutely, sir. So this will be M1 R1 square upon 2 square is 4. 4 into 4 is 16 M1 R1 square. Now what I can cancel in this particular case, M1 R1 square R1 square. So it is 1 by 16. So I1 divided by I2 came out to be 1 divided by 16. So this is 1 by x, because in the question it is given as it is 1 by x. So what is the value of x in this particular case? So x is 16. This is the question. Value of x is 16. Value of x is 16. Value of x is 16. I hope this is crystal clear to each and every single student. I hope this is crystal clear to each and every side. Now, guys, let's take a look at this particular question. Moment of inertia of a half disk. Moment of inertia of a half disk. Moment of inertia of a half disk. In this particular case, my dear NEET aspirants, you have a disk over here. You have a disk over here. And when I say half disk, it is not complete disk. Half disk means half of the disk. This is called half disk. Now, my dear NEET aspirants, I want you to understand one thing over here. I want you to understand one thing over here. This is a half disk. Now, imagine this was a complete disk. Imagine this was a complete disk. Yes. Then this would have been the axis which is passing through the diameter. Absolutely, sir. And what is the moment of inertia about the diameter? mr square by 4. Yes, sir. Already calculated. Now, since this is not a complete disk, this is a half disk. So half disk will have center of mass somewhere around over here. Complete disk will have here. Center of mass of half disk is here. Now, if I say axis passing through the center of mass and parallel to the half disk. Okay, listen, I'll just write over here. Moment of inertia about an axis passing through center of mass. Moment of inertia about an axis passing through center of mass. Okay. Parallel to the plane of the disk. Plane of the disk. Parallel to the plane of the disk. Now, my dear NEET aspirants, that is this one. And always remember, in case of half of the disk, this distance is 4r by 3 pi. Now, don't you think I can use parallel axis theorem? Absolutely, sir. Use parallel axis. What does that say? Moment of inertia. Okay. You have to find moment of inertia. You have to find about this axis in this particular case. Okay. Moment of inertia about this axis you have to find. Okay. This axis. So you can say, what does parallel axis theorem say? Parallel axis theorem say moment of inertia about any axis. Let's suppose here I am taking D will be equals to moment of inertia about center of mass plus I would say md square. Sir, this theorem we can only use if one axis is passing through center of mass. Yes, passing. Another axis is passing. Another axis is parallel to that disk. Yes, condition satisfied. And distance d is the perpendicular distance. Yes, all the conditions are satisfied. Now here id is given. That is mr square by 4 is equal to ICOM you have to calculate plus md square. Value of d is 4r by 3 pi. 4r divided by 3 pi, its whole square. So this is mr square divided by 4 is equal to ICOM plus 4 square is 16. 16m r square. Because it is 4 square as well as r square. Divided by 3 square is 9 pi square. Now take it over here. So it is going to be mr square divided by 4 minus 16 mr square divided by 9 pi square is equal to ICOM. I can say ICOM in this particular case. I can say ICOM in this particular case. What can you take common? You can take common m into r square. So what remains inside? 1 by 4 minus 16 upon 9 pi square. Okay, this is the answer to the question. This is the answer to the question. Okay, let's suppose you have the similar question but like this. You have a similar question but like this. Okay, this is a similar question. And in this particular case, now guys see, the axis is perpendicular to this. You have to find this ICOM. Okay, so I'll say moment of inertia about center of mass, or moment of inertia about an axis passing through center of mass, okay, moment of inertia about an axis passing through the center of mass perpendicular to the plane, of the disk, okay. Now guys, this you can consider as in this particular case, it is passing through this is not the diameter, it is passing through this. Now guys, it is a half disk, you can consider over here. One axis is passing through this point. Consider disk till here only. Okay. One axis is passing through this, means this point. Okay. Let's suppose if it was a complete disk. In case of a complete disk, the axis passing through the center of mass and perpendicular to the disk, it is mr square by 2. Okay. And moment of inertia about this center of mass of the disk, but about an axis which is perpendicular to the plane of the disk. Here also you can use perpendicular axis. Yes, absolutely you can use it. What does perpendicular axis theorem say? My dear NEET aspirants, when it comes to the perpendicular axis theorem, okay, what does perpendicular axis theorem say? Okay, that is moment of inertia about any point, about let's suppose point P, about an axis passing through point P will be equals to moment of inertia about center of mass plus I would say md square. Now here moment of inertia, see, sir, are the conditions satisfied? Yes, this is passing through center of mass and this axis is parallel. Doesn't matter where from it is passing, it must be parallel. Another one should pass through center of mass. This is the perpendicular distance, absolutely. So you can say this in this particular case is mr square by 2 is equal to, this is ICOM plus m into, again, d square. D is how much? 4r by 3 pi, that is 16r square, 9 pi square. Now take it over here. mr square by 2 minus mr square into 16 divided by 9 pi square is equal to ICOM. Now you can say ICOM will come out to be, take this mr square common. So what remains? 1 by 2 minus, I would say 16 divided by 9 pi square. So here it is 1 by 4 minus 16 by 9 pi square. Here it is 1 by 2. I hope you got the difference between the two. You got the feel of this particular question. Okay. I believe this is crystal clear. Now guys, let's move on to the moment of inertia of a rod. Let's move on to the moment of inertia of a rod. Okay, let's move on to the moment of inertia of a rod. Okay, let's suppose you have a rod over here. Its length is L and mass is M. It is rotating about an axis which is passing through its edge. It is not passing through the center. Okay, whenever a rod is there, okay, and if it is rotating about its edge, okay, then moment of inertia about this axis will be simply, you guys will be remembering, I is equal to m L square. L is the distance from the axis of rotation, L square divided by, I would say 3. If the axis is passing through the edge, then ml square by 3. If the axis is passing through the center of mass, in that particular case, I can say ml square by 12. So here, this is I. In this particular case, I will be ml square divided by 12. ml square by 12. I is equal to ml square by 3. Okay. Now, guys, take a look. In this particular case, moment of inertia of a hollow sphere. Okay, before this, okay, let me show you some more questions on the rods. See, guys, let's suppose the question is something like this. Let's suppose this is the rod, something like this. Okay. And in this particular case, this angle is given as alpha. This is the axis of rotation. You have to tell me mass of the rod is m and length is l. You have to tell me in this particular case what will be the moment of inertia. Guys, if this is L, this component is going to be L cos of alpha. This component is going to be L sine of alpha. L sine of alpha. Now, which component you guys are supposed to take in this particular case? If this is the angle, then this will be cos, this will be sine. It depends upon the angle. Which component are you supposed to take? Sir, I am supposed to take that component which is perpendicular to the axis of rotation. Sir, if I take this, this is on the axis of rotation. Na? So moment of inertia due to this will be 0. Okay. Consider perpendicular component. Like in this particular case, we considered perpendicular component. Perpendicular component was what? Sine alpha, because here alpha was this. That's why this is cos, this is sine. So you'll be saying in this particular case, moment of inertia will be, okay, and it is passing through the axis of rotation. So it is m L square by 3, and instead of L, I'll be preferring over here, that is L cos of alpha divided by 3. So moment of inertia will be, and its whole square, m L square cos square of alpha divided by 3. You can write it like this. Okay. Let's suppose the question is like this. This is a rod and this is the axis of rotation. This is the axis of rotation. This is the axis of rotation. And in this particular case, this angle is given as alpha. Mass of the rod is m, length is L. This angle is given as alpha. Now guys, tell me one thing. In this particular case, you can say, sir, if this is L, this will be L by 2. Okay. This component in this particular case, okay, let me make one more diagram. This will give you the proper crystal clear feel. Let me take this over here. Okay. Now guys, if you say, if this is alpha, in this particular case, this is also going to be alpha. And if this is L by 2, guys, so don't you think this component is going to be L by 2 sine of alpha? L by 2 cos of alpha. Cos of alpha. And One more important thing, if this is also L by 2 and this angle is alpha, this is going to be L by 2 cos alpha, this will be L by 2 sin alpha. So L by 2 sin alpha. Now, what is the perpendicular length of the rod? Guys, so we say R perpendicular, or you can write over here L perpendicular. That is going to be L by 2 sin alpha. Arey yaar, why am I mentioning sin? This will be also cos, na? Cos alpha. L by 2, L by 2 cos alpha plus L by 2 cos alpha. So L perpendicular is going to be L cos alpha. L by 2 plus L by 2 is L cos alpha. Now tell me, what is the moment of inertia? Moment of inertia will be m L square divided by 12 because it is passing through the center of mass, and instead of L, what will you write over here? Sir, I'll write L cos alpha. So L cos of alpha whole square. So I will be m L square cos square of alpha divided by 2. I hope this question is also clear. I hope this question is also clear. Okay. Guys, let's take a break of 5 minutes. Now guys, let's move on to the moment of inertia of a hollow sphere. Okay, we have got hollow sphere over here. Let's find the moment of inertia of hollow sphere. I want you to understand this very carefully. Hollow sphere means actually football, because football is hollow, okay, which is hollow from inner side. Mass is present on the surface only. Okay, and in this particular case, you are supposed to tell me what is the moment of inertia. Now guys, if this is the hollow sphere, moment of inertia about an axis which is passing through the center of mass. Okay, it can be like this, it can be like this, it can be like this. In any direction, it will be similar. So what I can write in this particular case is, I can say moment of inertia due to a hollow sphere. Okay, it is going to be I is equal to, that is 2 divided by 3, then we say mr square. This is the moment of inertia due to a hollow sphere. Okay, okay, and this is about center of mass. I'll just mention over here about center of mass. Okay, this is going to be the moment of inertia. Now my dear NEET aspirants, about its edge, like if an axis is passing through its edge, if an axis is touching its edge, so what I would say, moment of inertia about the edge, it is going to be, that is moment of inertia about center of mass plus I would say md square. Sir, can I use this? Yes, absolutely. Why? Because one axis must pass through the center of mass and another axis must be parallel, and this distance must be perpendicular distance, and this is r. So this will be moment of inertia about edge. This is 2 divided by 3 mr square plus m into r square. So moment of inertia about this will be 3 mr square plus 2 mr square, that is 5 mr square divided by 3. 5 mr square divided by 3. Okay, 5 mr square divided by 3. Okay, yes, absolutely. Now boys and girls, let's talk about moment of inertia of solid sphere. Moment of inertia of solid sphere. Okay, this is a solid sphere. We have to find its moment of inertia. You'll say, sir, about its center of mass, I would say moment of inertia is simply going to be 2 divided by 5 mr square. This is the moment of inertia of solid sphere. Solid sphere means cricket ball, which is actually filled from inside. Okay, I is equal to 2 by 5 mr square. Now if I say about its edge, so moment of inertia about an axis which is passing through its edge. So this will be, I edge will be ICOM plus I would say MD square, So moment of inertia about edge will be ICOM. Moment of inertia about center of mass, that is 2 divided by 5 mr square plus md square. So m and d is also how much? That is r square. So I edge will be 5 mr square plus 2 mr square, that is 7 divided by 5 mr square. 7 by 5 mr square. 7 by 5 mr square. Okay, 7 by 5 mr square. Now my dear NEET aspirants, in this particular case, we say find the moment of inertia of 3 spherical shells. This is a spherical shell. This is a spherical shell. And this is a spherical shell. Find the moment of inertia of 3 spherical shells about an axis passing through the center of mass. Okay, passing through the center of mass of one sphere and touching the edges of other two. So this is passing through the center of mass of one sphere and touching the surface of other. Okay, and this is the question which was asked in NEET 2015. Now guys, see, in this particular case, These are spherical shells. Spherical shells means hollow spheres. These are hollow spheres. These are hollow spheres. Okay. If I say what is the moment of inertia, if I say what is the moment of inertia of this sphere, about the center of mass. Sir, we know moment of inertia of hollow sphere about center of mass is 2 by 3 mr square. So I can say moment of inertia net. So for this, it will be through center of mass. That is 2 divided by 3 mr square. Then plus. For this, it will be through edge. Okay. This will be through edge. Through edge, how much? I can say 5 divided by 3 mr square. And it is, I would say it is touching the edge of this sphere. It is touching the edge of this sphere. So I would multiply with 2. So I net in this particular case will be 2 by 3 mr square plus 2 5s are 10. 10 by 3 mr square. Okay. Yes. Now in this particular case, it is 2 by 3 mr square, 10 by 3 mr square. Okay. So you can find the net value of moment of inertia over here. Okay. You can take this common, mr square common, and then you can write 2 divided by 3 plus 10 divided by 3. Okay. So this will come out to be 4 mr square. 4 mr square in this particular case. I believe this is crystal and clear. Let's talk about, my dear NEET aspirants, that is moment of inertia of a hollow cylinder. Moment of inertia of hollow cylinder. This is a hollow cylinder. Hollow cylinder means pipe. You can consider pipe as hollow cylinder. Hollow cylinder means which is hollow from inner side, which is not filled. Mass is present on the surface only. Mass is present on the surface only. Okay. Now guys, when it comes to the moment of inertia about an axis which is passing through the center, okay, this moment of inertia will be mr square. Okay. About center of mass. About center of mass. About an axis which is passing through the center of mass. So I will be equals to mr square. Whatever is the moment of inertia of hollow sphere. Sorry. Of ring. Say will be the moment of inertia of hollow cylinder. Because hollow cylinder is made up of n number of rings. N number of rings. Okay. Hollow cylinder is made up of n number of rings. Okay. Yes. Now guys, take a look. Take a look. Let's suppose if somebody says, what is the moment of inertia of this hollow cylinder about this edge? About this edge. You'll be simply saying about an axis touching the edge. About an axis touching the edge. So it is going to be IE is equal to ICOM plus I would say MD square. Because this we can use when one axis is passing through the center of mass and another axis is touching the edge. So I can say IE will come out to be ICOM, moment of inertia about center of mass. Okay. That is mr square plus m into, what is the perpendicular distance between the two axes? This is also radius r. So this will be mr square. So to edge mr square plus mr square, it will be 2 mr square. 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 Okay. Now, my dear NEET aspirants, when we talk about moment of inertia of a solid cylinder, understand this very carefully. Solid cylinder means that cylinder which is filled from inner side. Which is filled from inner side. This is the radius r. This is the radius r. This is the radius r. Now, when it comes to the solid cylinder, this is a solid cylinder. Guys, whatever is the moment of inertia of disk, same will be due to a solid cylinder. Why? Because we say solid cylinder is made up of large number of disks. Okay. So I would say about an axis passing through center of mass, about an axis passing through center of mass, we say this is going to be mr square divided by 2. Mr square divided by 2. Okay, absolutely, sir. Now, my dear NEET aspirants, this is the moment of inertia. We say about an axis passing through the edge. What will be the moment of inertia about this axis? I'll write over here about an axis passing through the edge. So that is going to be IE is equal to ICOM plus MD square. Plus MD square. So IE will come out to be, now boys and girls, what is ICOM? That is mr square divided by 2, then plus mr square. So that is 2 mr square plus mr square, that is 3 divided by 2 mr square. This is moment of inertia about an edge. 3 by 2 mr square. 3 by 2 mr square. Let's talk about this question. Find the moment of inertia of a solid cylinder about A and B as shown in the figure. Now guys, see, this is a solid cylinder over here. Okay. You have to tell me the moment of inertia about A. Okay, that is IA. And you have to tell me the moment of inertia about B. That is IB. Okay. Moment of inertia about A and moment of inertia about B. Listen to me very carefully. To find the moment of inertia about A and B, my dear NEET aspirants, I want you guys to understand this very carefully. Guys, see, in order to find the moment of inertia about A, listen guys, I would say, you will be considering this as a rod as well as you will be considering this as disk. Okay. Now, what I'm trying to say is that, guys, mass is present along the length also. Mass is present on the area also. Okay. Now, my dear NEET aspirants, what I'm trying to say is that if you try to look at this cylinder from a large distance, it will look like as a rod. From a large distance, it appears to as a rod. It appears to you as a rod from a large distance. Okay, absolutely, sir. From a large distance, it appears to you as a rod. Yes. So what I can say, sir, moment of inertia about point B, moment of inertia about this axis which is passing through B. So first, due to the rod, it will be m and height is h, mh square divided by 12. So it will be IB is equal to mh square divided by 12 because it is passing through the center. Then plus. Now guys, see, this is also disk. This is also disk. So this is the axis which is passing through the center of mass of disk and is parallel to the plane of the disk. So I would say it is going to be mr square divided by 4. mr square divided by 4. mr square divided by 4. Okay, absolutely, sir. Okay, mr square divided by 4. So my dear NEET aspirants, you have got a cylinder over here. Okay, you have got a cylinder over here. Okay. And in this particular case, you have to tell me moment of inertia about B. What if I say what is the moment of inertia about A? Guys, see, you will be considering this as a rod from a large distance. So then it will be mh square divided by 3 about an axis which is passing through the edge of the rod. Then it is also disk. Okay. When it comes to the disk, that will be mr square divided by 4. mr square divided by 4. Let me add one question over here. Okay. Now guys, see, let's suppose you have a question over here. This is a cylinder. It's a hollow cylinder. Okay. Now in this particular case, there is an axis which is passing through the like this. There is an axis which is passing through like this. Moment of inertia about this is IA. Moment of inertia along this is IB. Okay. Okay. Now in this particular case, my dear NEET aspirants, if you take a look over here, you have to tell me, and let's suppose this length is H, radius is R. You have to tell me moment of inertia about A and B. This is a hollow cylinder. Hollow. So I'll say, sir, moment of inertia about point A. From a large distance, it will appear to you as a rod. So from a large distance, we say it has, due to the rod, mh square by 12, because from the large distance we'll be considering the rod. So about this point A, it will be mh square by 12 plus. Due to the ring, okay, this axis is passing through the ring. This axis is passing through the ring. Okay, it is passing through the center of mass and is parallel to the ring. It is going to be mr square divided by 2. mr square by 2. Then my dear NEET aspirants, when I say IB, it will be mh square divided by 3 plus mr square divided by 2. mr square divided by 2. Okay. Okay. mr square divided by 2. Okay. Okay. Yes, absolutely, sir. Absolutely, sir. So I hope you got the feel of this particular question also. I hope you got the feel of this particular question also. Let's move on to the this one. Moment of inertia of the plate. This is a plate. Okay. You have to tell me the moment of inertia of the plate. Okay. Now, my dear NEET aspirants, when it comes to the plate, we say when the axis is parallel to the plane of the plate and along the breadth. I'll write over here. When the axes are parallel to the plane and along the breadth, along the breadth, along the breadth. Okay. Now, my dear friends, this axis, it is parallel to the plane, means it is in the plane. This is also in the plane, and it is along the breadth. This is the breadth. This is the breadth. It is along the breadth. It is along the breadth. Now, my dear NEET aspirants, in this particular case, what I'm trying to say is that when the axes are parallel to the plane and along the breadth, listen to me very carefully. When the axes are parallel to the plane and along the breadth, we say in that particular case, moment of inertia about this A, moment of inertia about this A, it will be simply m a square divided by 3. Okay. Sir, why are you mentioning this m a square divided by 3? Because moment of inertia is same as the moment of inertia of rod. Because same mass is distributed over here. You can consider, let's suppose if I say instead of this I am considering rod. So whatever is the mass of the rod distributed, same mass is distributed over here. Okay. Yes. And length, which one I am taking? I am taking length A. Length is A. Length is A. And then if I say what is the moment of inertia about center of mass? So you mentioned this logic over here also. Because same mass is distributed over length A. Same mass is distributed over length A. Okay, same mass is distributed over length A. Now, my dear NEET aspirants, if I say what is the moment of inertia about center of mass, sir, that is going to be ma square by 12. About center of mass, it is going to be ma square by 12. Okay, because it is passing through the center. Okay, in this particular case, when it comes to the rod, you say ma square by 12. Here ma square by 3. Now, guys, if I say along this is the axis. Okay, in this particular case, this it is cutting the breadth and it is along the length. See, guys, here I'll write when the axes are along the length, when the axes are along the length and parallel to the plane, when axes are along the length and parallel to the plane okay, just a second. Okay, yes, when the axes are along the length and parallel to the plane. Absolutely, sir. Absolutely, sir. Then, my dear friends, in this particular case, what I'm trying to say is that when the axes are along the length and parallel to the plane, when the axes are along the length and parallel to the plane, in that particular case, what I'm going to do is, in that particular case, what I'm going to do is, when the axes are along the length and parallel to the plane. So I'll write over here moment of inertia about center of mass. It is going to be simply mb square by 12. Why? Because right now, it is this length of the rod will be considered as b. Length of the rod will be considered as b because this is the axis of rotation. And when I say moment of inertia about the edge, it will be mb square divided by 3. Moment of inertia about the edge is mb square divided by 3. I hope this is crystal clear to each and every single student. I hope this is crystal clear to each and every single student. Okay. Absolutely, sir. Okay. Yes. Yes. Let's move on to this question. Now, guys, see, the question is, this is a very good question actually. This is the question. Now, guys, take a look. Moment of inertia of a plate about an axis perpendicular to the plate. Perpendicular to the plate. There's a plate over here. There's a plate over here. And in this particular case, my dear NEET aspirants, you have to tell me what is going to be the moment of inertia in this particular case. Guys, see. We say it is perpendicular to the plane, It'll be simply, guys, whenever you have something like this, it'll be simply mb square divided by 12 plus ma square divided by 12. Okay, guys, this axis is perpendicular to this plane. In this particular case, mb square by 12 plus ma square by 12. Sir, when the axis is, listen to me very carefully, along the length, in that case, mb square by 12, mb square by 3 along the edge. When I say it is along the breadth, ma square by 3, ma square by 12. Okay. Now, my dear NEET aspirants, for a square plate, can I say value of A will be equals to value of B? Absolutely. So I can say this moment of inertia, okay, will come out to be, that is m a square divided by 12 plus m a square divided by 12. So this is going to be m a square divided by 6. M a square divided by 6. This is m a square divided by 6. Okay. So whenever you have perpendicular to the plane, you'll be writing it like this. Okay. Absolutely, sir. We understood each and every single concept over here. Okay. I believe everything is crystal clear to each and every single student. Okay. Now, guys, there is a question over here. This is a very beautiful question. I would want you guys to understand this very carefully. I would want you guys to understand this very carefully. See, guys. Moment of inertia of a remaining system, remaining section. Let's suppose, okay, let's take a question. Let's take a look at the question directly. Let's take a look at the question directly. Let's take a look at the question directly. So what I would write over here, from a disk of radius r, there is a disk, it has radius r and mass m. From a disk of radius r and mass m, a circular hole of diameter, r, its diameter is r, whose rim passes through the center is cut. What is the moment of inertia of the remaining part of the disk about its axis passing through its center? About its perpendicular axis passing through its center. See, guys. What does the question say in this particular case? I want you to understand this very carefully. What does the question say? See, you have got over here this disk. This is the another disk. Okay. So this is basically the disk. This is the disk. Now from this disk, you are cutting a hole. When you are cutting the hole, you have to tell me what is the moment of inertia of this remaining disk. So this was the complete disk. When you cut the hole from this disk, what is the moment of inertia of the remaining disk? That is what we are supposed to calculate. Now, guys, see. When I say moment of inertia of the remaining disk, or moment of inertia of the remaining, what I want you guys to do is, you find moment of inertia of complete disk minus moment of inertia of removed. Complete minus removed. So what you do in this particular case is, my dear NEET aspirants, what is the moment of inertia of complete disk? Disk complete. You'll say, sir, moment of inertia of complete disk is simply mr square divided by 2. Okay. And when I say, my dear NEET aspirants, moment of inertia of removed disk, it will be how much? Moment of inertia of removed disk. Guys, moment of inertia of this removed disk, but about an axis which is passing through its edge. Sir, that is going to be 3 divided by 2 m dash into r dash square. Now, guys, in this particular case, what I want you to understand is, its diameter in the question is given as r. In this question, if you see, the diameter of the removed portion is r. What is the half of the diameter? R by 2. So what I can say, this is 3 divided by 2 m dash r divided by 2 whole square. Okay. Now, my dear NEET aspirants, listen to me very carefully. Sir, we don't know the mass of this removed portion. Let me tell you, how do we find the mass of the removed portion? We say disk has got the area. We say when it comes to the area, it is proportional to r square. Area of disk is pi r square. Okay. Then, my dear friends, if whole of radius r by 2 is removed, okay, if whole of radius r by 2 is removed, if whole of radius r by 2 is removed, then mass of the removed portion is m by 4. Why, sir? Because area is proportional to r square. So if you are removing r by 2 radius disk, so mass of that will be m divided by 4. Okay. Mass of that will be m by 4. So you can write over here 3 divided by 2, m divided by 4, r square divided by 4. So this will come out to be 3 divided by 32 mr square. Okay. Now when you say moment of inertia of remaining, it will be moment of inertia of complete, that is mr square divided by 2, which you recently got, minus 3 divided by 32 mr square. 3 divided by 32 mr square. Okay. Now, my dear NEET aspirants, what you can do is you can take mr square common. So it is 1 by 2 minus 3 divided by 32. So that is going to be 13 divided by 32 mr square. This is I remaining. This is I remaining. This is I remaining. Okay. I hope you got the feel of this question. So there is only one concept which we can apply over here. Moment of inertia of a remaining disk. It is going to be moment of inertia of complete minus moment of inertia of removed. That's it. That's it. That's it. Now, my dear NEET aspirants, you have got radius of gyration. You have got the concept that is what we call radius of gyration. Okay, let's understand the concept radius of gyration. I want you to understand this very, very, very carefully. What does radius of gyration actually mean? See, guys, what does radius of gyration actually mean? We say concept of center of mass is not valid for the calculation of moment of inertia. I'll write over here. Concept of center of mass is not valid for the calculation of moment of inertia. Calculation of center of mass is not valid for the calculation of moment of inertia. Okay? Calculation of center of mass is not valid for the concept of center of mass is not valid for the calculation of moment of inertia. See, guys, let's suppose if I say I have got a rod over here. Okay, I have got a rod over here. Okay, absolutely. Now, my dear friends, if center of mass is at the center, okay, listen carefully, guys. Let's suppose I am asking you what is the moment of inertia of this mass about this. If center of mass is at the center, if COM is at the center, Okay. What does COM at center mean? COM means center of mass, means that point where we assume mass of the whole body. We say then moment of inertia must be zero about center. Moment of inertia must be zero about center. Absolutely, sir. Then it must be zero about center. So if center of mass is at center, then moment of inertia is equal to zero about its center. Then moment of inertia is equal to zero about its center. Yes, sir. Absolutely, sir. 100%, sir. Okay. Then moment of inertia is zero about its center. Why? Because you are assuming the entire mass at center. But we know when it comes to the moment of inertia about the center of mass, it is ml square divided by 12. That's what I was saying. Concept of center of mass is not valid for the calculation of moment of inertia. So you cannot assume the mass of the entire rod at the center. If you assume, then moment of inertia must be zero, but it is not zero. Okay, like this. My dear NEET aspirants, we say center of mass is at L by 2. Okay, center of mass is at L by 2. What does that mean? That means mass of the whole rod is assumed to be at this point, at L by 2 distance from the axis of rotation. So when we find moment of inertia according to this, it is m, and then we say L by 2 whole square. So it will be m L square divided by 2 square is 4. ml square by 4. Which is wrong. Why? What is the moment of inertia about an axis passing through the edge? We know, sir, it is m L square divided by 3. So basically, when you are applying the concept of center of mass for the calculation of moment of inertia, answer is incorrect. Okay. So in order to find the center of moment of inertia, we cannot assume the mass of the rod to be at center of mass. So center of mass concept is failed over here. Okay. Now, my dear NEET aspirants, I would want you guys to understand this very carefully. I would want you guys to understand this very carefully. Let's suppose this is the axis of rotation. This is the rod that you have. This is the axis of rotation, and this is the rod you have. Let's do one thing. Let's assume the mass of the object. Let's assume mass of the object to be at a radius of gyration. Let's assume mass of the object to be at a radius of gyration. This is m. Okay. So radius of gyration is that point where we assume the mass of the body to calculate moment of inertia. Okay, so this is at k distance. K means the radius of gyration. Okay. Now, my dear NEET aspirants, if we assume the mass to be at radius of gyration, then what is the moment of inertia about this axis for this rod? You'll say, sir, it is I will be equals to, that is mass you are assuming at this point, multiplied by k square. Absolutely, sir. And as we know, sir, I is equal to ml square divided by 3. Now balance the two. So you will say, sir, mk square will be equals to ml square divided by 3. M and M will cancel. So K will be equals to L divided by root 3. So this is the radius of gyration of the rod. This is the radius of gyration of the rod. So this is the radius of gyration of the rod. So radius of gyration concept is introduced. Radius of gyration concept is introduced so that we get the correct answer for the calculation of moment of inertia. Let's take a look at this particular question. Let's take a look. The ratio of the radius of gyration of thin uniform disk about an axis passing through its center and normal to the plane to the radius of gyration of the disk about its diameter is. Take a look, my dear NEET aspirants. You have got a disk over here. Okay. You have to tell me the radius of gyration of this K1, radius of gyration of this K2. So means K1 divided by K2 you have to find out. You have to find out the value of K2. Okay. Okay. Now, my dear NEET aspirants, in this particular case, what will you do? You will be assuming the mass of the entire disk at a radius of gyration. So its moment of inertia will be mk1 square. mk1 square. It will be equals to, what is the moment of inertia of this disk? Will be, sir, it is mr square divided by 2. As simple as that. This will be moment of inertia. So m and m will cancel. So K1 will come out to be r divided by root 2. This is the radius of gyration here. Now, what is the moment of inertia of this disk? Sir, moment of inertia of this disk is mr square by 4. And you will be assuming its radius of gyration at K2. So m into K2 square. So both are equal. M and m will cancel. So K2 will come out to be r divided by 2. Now you have to find the value of K1 by K2. You have to find the value of K1 divided by K2. This is r divided by root 2 upon r divided by 2. This and this will cancel. So this will come out to be 2 divided by root 2. So now multiply with root 2 and divide with root 2. So that is going to be root 2 divided by 2. Root 2 is to 1. Sorry. Root 2 is to 1. Okay. This is going to be the radius of gyration ratio. This is going to be the radius of gyration ratio. Okay. Just a second. Okay. That's cool. Let's move on to this one. The ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis to the radius of gyration of a thin hollow sphere of same mass and radius about its axis is. Okay, this is the question that we have. This is the question that we have. The ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis to the radius of gyration of a thin hollow sphere of same mass and radius about its axis is. Okay, you are given a hollow sphere and solid sphere. Guys, see, in case of a solid sphere, what I'm going to write over here is moment of inertia will be 2 divided by 5 mr square. And consider its radius of gyration at k1. So moment of inertia will be mk1 square. Balance the two. Because we say radius of gyration is that distance at which you assume the mass of a body to calculate the moment of inertia. Now m and m will cancel, so k1 will come out to be r. Okay, and then we say a root 2 divided by 5. Root 2 divided by 5. Then, my dear NEET aspirants, if I say in case of a hollow sphere, so moment of inertia will be 2 divided by 3 mr square, and make this equal to m into k2 square. Let's assume its mass to be at k2. This and this will cancel. So k2 will come out to be, that is r under root of 2 divided by 3. Absolutely. Now we have to find the value of k1 by k2. Value of k1 by k2 is, that is r under root of 2 by 5 upon r under root of 2 by 3. This and this will cancel. Even root 2 and root 2 will cancel. So this will be 1 divided by root 5 upon 1 divided by root 3. Take this in the numerator. So this will be a root 3 divided by root 5. This is the answer to the question. NEET 2023 question is this. This is the answer to the question. Okay. This is the answer to the question. Okay. This is the answer to the question. Now guys, let's move on to the next question. Let me show you. Just a second. Let me copy a slide over here. Let's suppose you have a question something like this. Take a look. You have a question something like this. The question is ratio of radius of gyration of hollow sphere to that of solid sphere of equal mass for moment of inertia. Ratio of radius of gyration. Let me just make the diagram over here. You have got a hollow sphere over here. This is a hollow sphere. And you have got a cylinder over here. Okay. You have got a cylinder over here. Okay. And in this particular case, I want you to understand this is given as 4r. And this is the axis. This is the diagram. This is the axis. Let's suppose this is A and this is B. And in this particular case, I would say this is the axis. This is the axis. This is A and this is B. Now, my dear NEET aspirants, what I'm trying to say is that this is the question of JEE 2025. Ratio of radius of gyration, okay, of the hollow sphere to that of the solid cylinder is equal to the of equal mass for moment of inertia and about their diameter axis AB as shown is root 8 divided by x. See what is given in the question. It says a radius of gyration of this divided by radius of gyration of this. That is K1 divided by K2 is root 8 divided by x. We are supposed to find the value of x. Okay. This is a solid cylinder. And this is a question of JEE 2025. JEE 2025. This is a question. You have hollow sphere, you have solid cylinder. The radius of gyration ratios root 8 divided by x. So we are supposed to find this. What is the value of x? Guys, first of all, you tell me what is the moment of inertia of this solid cylinder about this axis. Okay, if you remember, I have told you we will be considering this as a rod also. We will be considering this as a disc also. So when you consider this as a rod, then moment of inertia about AB, it is going to be m into h square divided by 3. Then plus, due to the disc, it will be m into radius is r square divided by 4. Okay, yes. Now, my dear NEET aspirants, what is the height of this or what is the length of this? That is 4r. So here I am going to write m into, instead of h, I am writing 4r square. That is going to be 16. So that is going to be 16r square divided by 3 plus m into r square divided by 4. So this, my dear NEET aspirants, will come out to be, you can take this mr square out, m into r square out. So it will be 16 divided by 3 plus 1 divided by 4, something like this. Okay. And then, my dear NEET aspirants, you can solve it. It will be mr square into, solve this, 16 into 4, that is 64 plus 3 divided by 12. So this will come out to be mr square. And then you have got over here 67 divided by 12. This is the moment of inertia about AB. This is the moment of inertia about AB. Okay, 67 divided by 12. And then, my dear NEET aspirants, you will be putting this equal to m into K1 square. Because you are assuming the mass of this solid cylinder at radius of gyration. And what is the radius of gyration of this? That is K1 at K1. So that's why we are writing mass into K1 square. Now from here, m and m will be cancelled. Okay. So K1 will come out to be, that is under root of 67. Okay. Divided by 12 into r. Divided by 12 into r. This is the value of K1. This is the value of K1. Then, my dear NEET aspirants, if I talk about, listen to me very carefully. If I talk about this one, sphere. In case of a solid sphere, my dear NEET aspirants, in case of a solid sphere, we know moment of inertia. What is the moment of inertia of a solid sphere? I'll just write over here. We say as for solid sphere, moment of inertia will be simply that is 2 divided by 3. Sorry, this is hollow sphere. 2 divided by 3 mr square. Now we are assuming its mass at radius of gyration. So if it's mass at radius of gyration, you can say over here in this particular case, what did you take over here? This is K1. Consider this K2 because this is the second one. So K2. And take this over here, m into K1 square will be equals to 2 by 3 m into r square. M and m will be cancelled. So K1 will come out to be a root of 2 by 3 into, I would say, r square. Okay. Okay. Absolutely. Now, my dear NEET aspirants, what you can do in this particular case is, so you have to find the value of k1 by k2. Do one thing, take the square over here only. So this will be k1 square will be 2 divided by 3, 2 divided by 3, okay, 2 divided by 3 r square. And take this square over here, k2 will be, k2 square will be 67 divided by 12 into r square. You can write it like this. Now, k1 divided by k2 whole square. You can write it like this. That is 2 divided by 3 into r. This is r, not r2. 2 divided by 3 into r. Then whole divided by 67 divided by 12 r square. Okay, this is r square actually. Okay, 2 divided by 3 into r square upon 67 divided by 12 into r square. Now what you can do in this particular case, this and this will be cancelled. So you can write k1 divided by k2 whole square. It will be 2 divided by 3 into 12 divided by 67. 3 ones are 3 fours are 12. Now 2 into 4 is 8 divided by 67. Okay, 8 divided by 67. So k1 divided by k2 will come out to be under root of 8 divided by 67. Now what was given in the question? K1 by k2 is a root 8 divided by x. So what is the value of x? That is 67. This is the value of x. I believe this question is also crystalline clear. This question is also crystalline clear. Okay. And there is one more question which I would like to give you in this particular case. I want you to understand this very carefully. I want you to understand this very carefully. See guys, take a look. Solid sphere A is rotating about an axis, I would say PQ. If the radius of the sphere, if the radius of the sphere is 5 centimeters, if the radius of the sphere is 5 centimeters, then its radius of gyration, about PQ will be root x centimeter. Find x. Read the question very carefully. What does the question say? Solid sphere A is rotating about an axis PQ. If the radius of the sphere is 5 centimeters, then its radius of gyration about PQ will be x centimeters. Then its radius of gyration about PQ will be x centimeters. Find x. Find x. Okay. Now, my dear NEET aspirants, in this particular case, what does it say? You have got, this is the axis of rotation and it is PQ. Okay. And there is a sphere over here. Okay. There is a sphere over here. This is the sphere. This is the sphere. And radius of this sphere is given as 5 centimeters. Okay. 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 And this D is given as 10 centimeters. Understand this very carefully. Sphere A is rotating about an axis PQ. If the radius of the sphere is 5 centimeters, then its radius of gyration PQ will be root x. We have to find the value of radius of gyration. Now, my dear NEET aspirants, what I want you to understand in this particular case is, okay, what I want you to understand in this particular case is, first and the foremost thing, you tell me one thing. What is the moment of inertia of this sphere about center of mass? This is a solid sphere, 2 by 5 mr square. Absolutely, sir. Without a shadow of doubt. Yes. Now, my dear NEET aspirants, you first find moment of inertia about this axis. Then only you can find the radius of gyration about this axis with respect to this axis. Now, in order to find moment of inertia about this axis, you use which one? Parallel axis theorem. I would say use parallel axis. What does that say? Moment of inertia about PQ. It will be moment of inertia about center of mass plus md square. Guys, you have to find radius of gyration with respect to this. You would be able to find radius of gyration with respect to this axis only if you know moment of inertia about center of mass, if you know the perpendicular distance d. Okay. So you will be writing over here IPQ in this particular case will be moment of inertia about center of mass 2 by 5 mr square. What is the value of mr? That is 5 square, because this is given as 5. Okay. Okay. Plus m into d square. M into what is the value of d? That is 10 square, because from here to here this d is given as 10 in the diagram. Okay. So IPQ will come out to be, okay, that is 5 square is 25. 25 into this will be 10 m plus 100 m, 110 m. This is the value of this m, 110 m. This is the moment of inertia about PQ. Now, my dear NEET aspirants, if you got the moment of inertia about PQ, now you can say, sir, let's assume the mass of this sphere at radius of gyration. So then what will be its moment of inertia? M into k square. But how much is its moment of inertia? 110 m. So I would say m into k square will be equals to 110 m. M and m will cancel. K will be under root of 110. So what is the value of x? 110. This is the value of x. I believe this is also crystalline clear. I believe this is also crystalline clear. Okay. Okay. Let's suppose you have this question, boys and girls. Listen to me very carefully. Let's suppose you have this question. Question is, given two rings such that their planes are perpendicular to each other, such that their planes are perpendicular to each other. Okay, as shown. Find the radius of gyration of the system. Find the radius of gyration. Gyration of the system. You guys are supposed to tell me what is the radius of gyration of this system. Take a look. It looks like this. Something like this. Like this. Wait. Now, boys and girls, I want you to understand this particular point over here. See, guys, this is B, this is over here A. Okay, this is the axis. These are the two rings. Mass is M and radius is R. You have to tell me what is the radius of gyration in this particular case. You have to tell me what is the radius of gyration in this particular case. Now, guys, first and the foremost thing is you have to tell me what is the net moment of inertia. Then only you can equate to the radius of gyration. We say net moment of inertia of the system. That is moment of inertia of AB along AB. Now, guys, what is the moment of inertia of this disk? This one. It is passing. It is basically, it is the diameter. Moment of inertia of this disk along the diameter, because it is placed like that only. That will be m r squared by 2 plus. What is the moment of inertia of this disk? It is perpendicular to the disk. In this particular case, it will be mr square. Okay. Okay. Now, guys, this is the net moment of inertia over here. Now, what is the mass of this disk? M. What is the mass of this disk? M. So, if I say their mass is M, M and M, that is 2M. And we are assuming there, okay, let's assume their mass at K, radius of gyration. So what will be the moment of inertia? Sir, 2m into K square. Now, this is the actual moment of inertia. This is the moment of inertia according to radius of gyration. So call this first, call this second. So I'll write from first and second. This is 2 mr square plus mr square, 3 by 2 mr square. So 3 divided by 2 mr square will be equals to 2m and then we say k square. 2m and then we say k square. This m and m will be cancelled. So k will be under root of 3 divided by 2 r. Okay. Oh, there was this 2 also. This 2 into 2 becomes 4. So this is going to be root 3 divided by 2 into r, because root 4 is 2. Root 4 is 2. This is k. Now, guys, let's move on to a new concept, that is what we call torque. I hope this is crystal clear to over here. This is the torque that we need to study right now. Okay. This is a new concept. Radius of gyration is over. Moment of inertia is over. Now we have to talk about torque. Okay. Absolutely, sir. Absolutely, sir. I'll make you understand this torque just a second. Now guys, let me make you understand this torque. Let me make you understand this torque. Understand this very carefully. When it comes to this torque, you have this over here. Let's suppose this is that bolt. This is that nut which this is that nut opener. We call it nut opener, which opens the nut. Okay. Before this, let me make you understand with the example of the door. See guys, very carefully. I'll make you understand. This is the door. I want you guys to basically open this door. How is it possible that you can open the door? If you apply the force something like this, do you think that it is going to open the door? No, sir. Guys, this is the door. You need to open this door. Is it possible that if you push the door, okay, if you're pushing the door something like this, you're pushing the door something like this? No, sir, absolutely not. Okay, what if I tell you, you pull the door something like this? Is it possible that you can open the door? No, sir, absolutely not. It is not possible. So you are pulling the door. Let's suppose this is the door, this door, this is the door. You are pulling this door can rotate something like this. You are pulling the door, you are pushing the door. It cannot rotate the door. Okay. So means you are applying force, but still the door is not rotating. Now, we can say it is not the force which is actually creating the rotation, which is rotating the door. No, it is not the force. Why? Because force I am applying over here, but still door is not rotating. There is no rotational effect. Now, my dear NEET aspirants, what if I tell you in this particular case, you apply a force something like this, perpendicularly. This is the door, this is the door, this is the door. You apply a force something like this, perpendicularly, it will rotate. If you pull it, okay, let me show you guys over here. Wait. Okay, this is a rod. Imagine this is a door. If I say you have to rotate this door. If you pull it, will it rotate? No. If you push it, will it rotate? No. If you give the force perpendicularly, tangentially, something like this, it will rotate. It will rotate. So means it is not the force only which is rotating the door. It is something else. And what is that? That is what we call torque. So we say if there is a body, sir, this body is moving. You are applying force on it due to which it moves. So who is responsible for creating the translational motion over here? Force. Who is responsible for creating the rotational motion? It is torque, which obviously is being produced by force. So when you push the door perpendicularly, we say a torque is being created over there. A torque is being created over there. Okay, a torque is being created over there. So my dear NEET aspirants, what I can say, I'll write the same statement over here. I'll write the same statement over here. See, if we have to open the door, if we have to rotate the door, then it is due to torque. So when you apply force perpendicularly, a rotating effect is being produced in the door. Due to that rotating effect, the door rotates. That rotating effect is what we call the torque. That rotating effect is what we call torque. That is what we call torque. Okay. It is due to the rotating effect. I'll write it is due to the rotating effect called torque. We call that rotating effect what? Torque. We call that rotating effect torque. We call that rotating effect torque. Okay. Yes. Now, my dear NEET aspirants, let's suppose we have this one. We have this nut opener over here. If you want to open this nut, if you apply the force something like this, will it rotate? No, sir. No rotating effect means no torque. If you push this opener something like this, will it rotate? No, sir. No rotating effect, no torque. So, my dear NEET aspirants, in this particular case, I would say, you have to apply the force at some angle, or we can say tangentially also. You have to apply force okay. So this is force F. This will be F cos theta and this will be F sin theta. Okay. This will be F cos theta and this will be F sin theta. So you are applying the force at some angle. So due to this force, yes, torque will be created. Why? Because it will have two components. This F sin theta, this will be F cos theta. Now tell me which of the two forces is which of the two components is responsible for creating the torque? F cos theta or F sin theta? Obviously it is F sin theta. So I'll say due to F sin theta rotating effect slash torque is produced. Torque is produced. Okay. Yes. Due to F sin theta rotating effect, torque is produced. Okay. Now, my dear NEET aspirants, if somebody asks you, how much is that torque in this particular case? How much is that torque in this particular case? Okay, and if you write the definition, it is, we say it is the rotational version of force. We say it is defined as a rotational version of force. Okay. 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 So means a rotating effect due to which component rotating effect will be produced, sir? F sin theta. So that's why we say this will create the torque. Okay. And my dear NEET aspirants, we can say that torque is going to be I'll write over here. What is the distance? This is the axis of rotation. Means here this bolt will rotate. So this will be considering as axis of rotation. From here to here, distance is r. So you'll be saying torque is r, and then we say F sine theta. So why are you mentioning F sine theta? Because F sine theta is responsible for creating torque over here. So I can write this torque is actually R cross F vector. Okay, torque is actually what? R cross F vector. Torque is actually what? R cross F vector. So we say where theta is the angle between R and F. Where theta is the angle between R and F. Okay, so tau is equal to RF sine theta and torque is equal to R cross F. We can write it like this. Okay. Okay. And if you ask me what is the direction of torque, we say direction of torque is perpendicular to R vector and F vector. Direction of torque is perpendicular to R vector and F vector. So if this is R and this is F, so direction of it will be like this, upwards or downwards, depends. Okay. Yes. This is the direction of torque. And when it comes to the unit will be, okay, I'll write over here when it comes to the unit, SI unit. So for this radius, it will be RF. Radius, it is meter. For force, it is Newton. So it is Newton meter. Okay. I believe this is crystal and clear. So torque is nothing but the rotational version of force, or we say moment of force, or we say whenever the body rotates, it is due to the torque. Now, let's take a look. Maximum torque. Let's understand maximum torque. See guys, when I write over here maximum torque, you say tau is equal to RF sine theta. When is the value of torque as maximum? See, torque depends upon sine theta. When the value of sine is maximum, torque will be maximum. So I can say tau will be, tau will be, now guys, listen to me very carefully. Maximum torque will be simply at theta is equal to 90 degrees. At theta is equal to 90 degrees, torque will be maximum. So this will be RF sine of 90. Because what is the maximum value of sine? That is 1. So that is only possible at theta is equal to 90. So torque will be R into F sine 90 is 1. This is called maximum torque. Okay. And in this particular case, my dear NEET aspirants, this is the rod. This is the radius R you can extend over here. This is in reality the radius. If you extend, this will be R. And if you apply force tangentially, what is the angle between the two? Here theta is 90. In this case, torque is going to be maximum. If I say minimum torque will be, there will be no torque. Its body should not rotate. If this is the rod, you are pulling this rod with a force F. And this is R. Angle between the two, theta is equal to 0 degrees. And torque here is 0 degrees. In this particular case, torque will be RF sine of 0. So torque will be, sine 0 is 0, so torque will be 0. It will not rotate. The body will not rotate at all. The body will not rotate at all. The body will not rotate at all. Okay, absolutely, absolutely. I believe torque concept is crystal clear to each and every single student. Okay, so maximum torque and minimum torque in this particular case. Now, guys, one more important thing I just want to say over here. Listen, guys, very carefully. What is that? See. See, guys, this was basically torque of a purely rotating body. Torque of a purely rotating body. I'll write over here. This is a for purely a rotating body. This is the torque. Now, guys, understand this very carefully. Understand this very carefully. We say torque about a point. Torque about a point. Torque about a point. What I want you guys to do in this particular case is understand this very carefully. Let's suppose there is a body over here. Okay, its mass is m. There is an object and force is acting F on this object. Understand this very carefully. And this is the point over here. This is the point and this is the reference point. And you are standing on this reference point over here. You are standing on this reference point over here. Okay. You are standing on this reference point over here. Now, my dear NEET aspirants, in this particular case, let's suppose from here to here, this is from here to here, this is the radius, let's suppose R. This is the radius, let's suppose R. Now, my dear NEET aspirants, if you are standing at this particular point and somebody is applying the force on this, so it will move something like this. It will move something like this. Now, with respect, let's suppose initially you were standing at this point. Now, if I say, if somebody applies force on this, it will move straight. So with respect to you, it is moving straight. It is moving straight. Now, when you are standing over here, then somebody applies when you are standing here, then somebody applies the force on it. Now it is moving angularly. Why? When the body reaches here, so this is the angle which is created. Okay, this is the angle which is created. So when the body was here, this was the angle which was created. When the body reaches here, we say this is the angle which is created. So with respect to you right now, the body is moving angularly. This is simple. If there is a person over here, he is standing, he's looking at this body is moving linearly. But with respect to this, it is moving angularly. Kind of rotation, I would say. I would say with respect to the reference point, body is moving angularly. With respect to the reference point, body is moving angularly. Okay. With respect to the reference point, body is moving angularly. Now, my dear NEET aspirants, with respect to the reference point, body is moving angularly. Okay. Okay. Absolutely. With respect to the reference point, body is moving angularly. With respect to this point, this body is moving angularly. Now, my dear NEET aspirant, in this particular case, with respect to the reference point, body is moving angularly. Okay. What I want you guys to do in this particular case is, so torque is produced in the body. Here also torque is going to produce in the body. And that torque will be simply R vector cross F vector. R vector cross F vector. Similarly here also, R vector cross F vector. As simple as that. As simple as that. R vector cross F vector. Now, my dear NEET aspirants, you can understand it like this also. You can understand it like this also. You can directly remember this R vector cross F vector. Okay. Okay. Like. If I do one thing, if I say this is the force acting on the body and this is the R vector. This is the R vector. Okay. Now here, this angle, let's suppose theta. So this is F. This F will have two components. Okay. This F will have two components. First one is along this and second one is along this. So this will be F cos theta and this will be F sin theta. You can tell me clearly, my dear NEET aspirants, guys, see, in this particular case, due to F sin theta, due to F cos theta, body will move straight. With respect to this point, body is going to go straight. So no torque is created. But due to F sin theta, in this particular case, body will move angularly. Body will move angularly with respect to this point. So F sin theta will create torque here. So we say here also, F sin theta creates torque. So I can say, you can write value of torque will be R into F sin theta. Absolutely, sir. I got it 100%. I believe so. So due to F sin theta, it is moving angularly. Due to F cos theta, it is moving linearly with respect to the reference point. 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 Okay. Now guys, let's suppose a body is moving in a circle. This is the object which is moving in a circle. It has velocity v, it has mass m. So with respect to the center, if I say what is the torque in this particular case, how much torque is being created. Okay, let's discuss this case later. Okay, then we have to define force F. Let's suppose force is acting F. This is R. So what will be the torque? R F sine of 90. Because angle is 90. So R into F in this particular case. Okay, I hope this is crystal and clear to each and every single student. This is crystal and clear. Okay, absolutely, sir. Now let's discuss some questions. Take a look. Find the moment of force. Moment of force means torque. The moment of force F at the moment of force due to F force at 2, 2, 2 about a point will be. Now see, this is a question. Let's suppose there is an object over here. Understand this very carefully. On this object, force is acting. Sir, this is the force which is acting. And what are the coordinates of this point? 2, 0, minus 3. 2, 0, minus 3. Okay. About a point. This is the point. About a point. This is the point. This is the origin. This is the reference. And reference point has got coordinates 2, minus 2, minus 2. Okay. Now you have to find the torque. You'll be simply saying, sir, this torque is R vector cross F vector. You can use this. Force is given. But sir, this R is not given. R is not given. Very simple. I have told you previously, this will be the R. This will be R. And how do you find R? Guys. Position vector of this will be, understand this very carefully. This will be R2 minus R1. R2 minus R1 means position vector of this. This is the point. What is the position vector of this with respect to the reference line? Or you can directly solve it. Don't go into the position vector. Directly solve it. Guys, if you have to find this R, so you'll be saying final x coordinate minus initial x coordinate. So 2 minus 2, that is 0 I cap. Then final y coordinate minus initial y coordinate. So 0, 0 minus of minus 2. It is going to be plus 2. So it is plus 2 j cap. Plus 2 j cap. Okay. Then final z coordinate minus initial z coordinate. So minus 3. Minus into minus is plus. Plus 2. It is going to be minus 1. So it is going to be minus I cap. It is going to be minus I cap. This is R vector. So this will be 2 j cap minus I cap. 2 j cap minus I cap. 2 j cap minus I cap. So you got R vector. Now you have R cross F. So you'll be now finding R vector cross F vector. Now guys, see, this is the cross product of two vectors. Remember, from now onwards, how do we do the cross product? Remember, from now onwards, how do we do the cross product? Okay, if you have to basically do R cross F, so first you'll be mentioning the coefficients of R. So first you'll be writing over here I, J and K. Then you will be mentioning the coefficients of R. So what are the coefficients of R? What is the I? Sorry, it is K cap. Oh, what did I write? Oh, guys. This is minus 3 minus 2. So this will be plus K cap. Plus K cap. So this will be 0, 2, minus 1. These are the coefficients of R. What are the coefficients of F? F vector, it is given 4, 5, minus 6. This is how do we find the cross product. You write the R vector coefficients, you write the F vector coefficients. Now solve it for I first. Sir, what does it mean solving it for I first? Just a second, I will tell you. I'll make you understand this. Oh, just a second, guys. Just a second. Okay. Now guys, do one thing. Solve this for I cap. What does that mean? You write over here I. Then you hide that column in which I is present. That is first. Then you hide that row in which I is present. That is first. First column and first row. Now what is remaining? 2 cross with minus 6. 5 cross with minus 1. So I'll write 2 into minus 6 is minus 12. Then minus 5 into minus 1 is minus 5. You can write it like this. Okay. Then minus j cap. In front of j you need to put minus. Solve it for minus. Now hide that column in which j is present and hide that row in which j is present. First row and second column. Now 0 with 6, 4 with -1. So you need to do the cross. So this will be 0 into -6 is 0. 4 into -1 is, okay, then minus. 4 into -1 is -4. Okay, absolutely. Then my dear friends, plus, solve it for k cap. Solve it for k. Hide that column in which k is present, hide that row in which k is present. Now, this with this with this. 0 into 5 is 0. 4 into 2 is 8. This is 0 minus 8. So now this R cross F, that is torque. Torque will come out to be minus into minus is plus. I would say minus 12 plus 7. That is minus 7 I cap. So this minus into minus is plus. Plus into minus is again minus. So minus 4 J cap. Then we say minus 8 K cap. This is going to be the torque. Even you can find the magnitude of this torque also. That is under root of this minus 7 whole square plus minus 4 whole square plus minus 8 whole square. This is how we find the magnitude of a vector. Okay, so this is going to be minus 7 whole square is 49 plus 16 plus 64. Okay, this is how we find the torque in this case. I believe everything is crystal clear. Okay. Now, my dear NEET aspirants, let's take a look at this point. Let's take a look at this point. See, guys, the coordinates of a particle with respect to the origin are this. There is a particle. This is the particle. Okay, this is the particle. With respect to the origin, these are the coordinates. If these are the coordinates with respect to the origin, how can you write the radius vector of this? Guys, what are the coordinates of origin? 0, 0, 0. How do you write the position vector or this radius vector? You say, sir, final coordinate minus initial coordinate, 1 minus 0. This is 1 minus 0. This is 1 minus 0. So that is I cap, J cap, K cap. And then it says, if a force of this acts on it, then magnitude of torque will be J 2025. Then the magnitude of torque will be. Guys, force is given, R is given. So F is given as I minus J plus K. R is given as I plus J plus K. You have to tell me what is the torque. Torque is simply R vector cross F vector, and that is going to be the determinant. That is going to be the determinant. Okay, so we'll be mentioning over here I, J, and then K. I, J, and K. Now first you will be mentioning the coefficients of what? Coefficients of what? R. Then you will be mentioning the coefficients of what? F. So it is 1, 1, and 1. It is 1, minus 1, and 1. Now guys, you will write over here I cap. Now hide this column and hide this row. Hide this column and hide this row. So 1 into 1 minus 1 into 1. 1 into 1 is 1. Then minus 1 into 1 is, we say minus 1. Then minus j cap. Okay. Hide this column, hide this row. 1 into 1 is 1. 1 into 1 is 1. So it will be 1 minus 1. It will become 0. Then plus k cap. Now hide this column and hide this row. 1 into minus 1 is minus 1. Then minus this 1 into 1 is 1. So this is 1 plus 1 is 2. 2i cap. 1 minus 1 is 0. This is 0. Minus 1 is minus 2 k cap. This will be the torque. This will be the torque. Now, if you ask, bus, that's it. This is the answer to the question. Okay. Let's take a look at this question, guys. Find the torque due to mg about O and center of mass. This is a body over here. This is the center of mass of the body and it's fixed over here. It's fixed over here. So means it can rotate about this point, this fixed point. You have to tell me, find the torque due to mg. You have to tell me, you have to find the torque. This is the purely rotating body. This is purely rotating body. And when it comes to this, force was acting on this particular particle. Okay. This was moving angularly with respect to the center point. This is a purely rotating body. Now guys, take a look. In this particular case, you have to tell me torque about the center. Understand this. Torque about this point. We say, what is the force which is acting on this mg? Let's find torque due to mg. How do we say torque is Rf sine theta? So torque will be R. So R means the distance from the axis of rotation till that point where force is acting. That is L by 2. L by 2. F is force. Force is mg. Angle between the two is 90, sine 90. So torque will be mgl divided by 2. As simple as that. Torque will be mgl divided by 2. Okay. Okay, this is the torque. This is the torque. This is the torque about. Okay. This point is important. This is the torque about point O. Means if the body you are assuming is rotating about point O, then this is going to be the torque. If I say about center of mass, listen to me very carefully. Let's assume the body is rotating about center of mass. About COM. So torque will be again Rf sine theta. Now guys, in this particular case, this is the point about which it is rotating. Force is acting at the same point. What is the value of R here? 0. What is the value of R here? 0. So R in this particular case is 0. So torque is going to be 0. Here no torque is being created. So what does it say? If the force is passing along the axis of rotation, in that case torque will be 0. If the force acts at axis of rotation, in that case torque will be 0. If the force acts at axis of rotation, in that case torque will be 0. Okay. So if force acts at axis of rotation, then torque is 0. Let's suppose you have this question. See, this is the rod. This rod is fixed over here. Okay. This is the center of mass. This is the center of mass. And in this particular case, this is going to be mg. If I say what is torque due to mg about point O, what is torque due to mg about this point O, about this point O? Sir, 0. 0. Why? Sir, in this particular case, this is mg. This is r. But what is the... Okay, let me write it properly. It is logical, na? Do you think that this force can rotate the rod right now? No. We say here, torque is equal to Rf sine theta. Torque will be R. Okay, let's suppose this is L by 2. Force will be mg. What is the angle between this L by 2 R and mg? That is 0, sine 0. So torque in this particular case is 0. Torque in this case is 0. As simple as that. Okay, if I say torque due to mg about center of mass, even that would be also 0. Because in that case, what is the value of R? 0. There were some questions. Okay. See, guys. Let me just tell you. Question is, object is projected. Object is projected. Then find torque about the point the point of projection after time t. After time t. Okay. Let's suppose this is the mass m. You are launching this mass m with a velocity u. It will go, reach here. Okay. Let's suppose after time t, the mass is here. Okay. After time t, the mass is here. If you are launching, you see, object is projected, find the torque about the point of projection. This is the point of projection. You have to find the torque about this point of projection. Okay. If this is u, this will be u cos theta. Because if this angle is theta, this component will be u sin theta. U cos theta and u sin theta. Now, when the object is here, you have to tell me what is the torque. Okay. Now, can I say this will be the radius vector? Join the point of projection, reference point, and that mass. This will be the radius vector. And this is the force acting at this point, that is mg. Okay. Now, my dear NEET aspirants, in this particular case, what I want you guys to understand is, this is very important. If this is the mass over here, force acting on this mass is M. You always prefer to take force and perpendicular distance, or distance and perpendicular force, perpendicular component of force. Now guys, see, in this particular case, I would say this R will have two components. First is this, second is this. Which one will you prefer to take? This component, this is first, this is second. First or second? Sir, obviously first, because first component is making 90 degree with mg. Okay. Now, if you say, sir, how do we find this component? This is called a horizontal distance of a projectile. Okay. Distance covered horizontally. I'll be using S is equal to ut plus 1 by 2 at square, but horizontally. So here x, x, x in horizontal direction. Okay. So displacement covered in horizontal direction. That is, let's suppose x, this is x. X is equal, initial velocity is u. It is ux. So this is the ux component. So that is u cos of theta into t. And always remember, in case of projectile motion, acceleration in x direction is 0. So this component will be, this term will become 0. Because acceleration in x direction is 0. So x will be equals to u cos theta into t. This is what we call r perpendicular. This is the perpendicular distance. This is the perpendicular distance. Now you will be like, sir, tau is equal to r f sine theta. Now guys, tell me, in this particular case, what I can say. Sir, f sine theta means f sine theta. Or you can write it like this also, my dear NEET. Or you can say, sir, this is tau is equal to, what is the value of r in this case? What is the value of r? That is u cos theta into t. U cos theta into t. What is the value of f? That is mg. Sine theta, what is the angle between this r perpendicular and mg? That is 90. Sine of 90. So tau will be, sine 90 is 1, mgu cos of theta into t. This is the torque. This is going to be the torque in this particular case. Okay, let's move on to the next question, boys and girls. Let's move on to the next question. In this particular case, When it comes to this, I would say the question is okay, find the torque about the origin due to a force. Force is given as 3I cap, 3J cap, acts on a particle whose position vector is 2K cap. Guys, force in this case is given as 3J and position vector is given as 2K. You have to tell me torque. Torque will be R vector cross F vector. So I'll write over here I, J, and then K. So for this, what is the X component? Component 0. What is Z component? 0. So this is 0, 3, 0. For this X and, okay, first we have to write X. First we have to write R vector. So this is F. R vector, it is 0, 0, 2. Now solve it. For I cap, you hide this column and this row. So 0 into 0 is 0, 2 into 3 is 6. 0 minus 6. Minus J cap. Okay. So hide this column and hide this row. 0 into 0 is 0. 0 into 2 is 2. 0 into 2 is 0. This will be 0. Plus K cap. Now hide this column and this row. 0, 0. Okay. So this is torque. This will be minus 6 I cap. This will be minus 6 I cap. Okay. Yes. Now guys, this is the question. Find the torque due to mg about center of mass about point O. This is mg. This is mg. And this is over here L by 2. This L by 2 will have two components. This one, L by 2 sine theta, and this one, that is L by 2 cos theta. L by 2 sine theta and L by 2 cos theta. Now, my dear NEET aspirants, what I want you guys to do in this particular case, we said torque about point O. Torque about point O. Listen carefully. You'll be simply saying, sir, this torque will be RF sine theta. Torque will be RF sine theta. Torque will be RF sine theta. Now, this torque is going to be, guys, first we'll find about point O. Now, in this particular case, this L by 2 will have two components. What did I tell you? Which component will you prefer to take? Which is parallel to force or which is perpendicular to force? Perpendicular to force. So, mg and L by 2 sine theta. So, you'll be saying instead of R, here L by 2 sine theta. And F is mg and sine theta. Guys, take a look. Theta is the angle between R and F. How much is that? 90. Sine 90. So torque will be mgl sine of theta divided by 2. And when I say about center of mass, torque is going to be 0. About center of mass, torque is going to be 0. Okay. Just a second. Give me 5 minutes, guys. I'll come. Huh? Just a second. Now guys, let's move on to the rotational equilibrium. Understand this very carefully. We say when net force on a body is zero, sorry, when net torque on a body is zero, it is said to be in rotational equilibrium. Okay. Now see, this is the body. It is fixed over here. This is a rod, it is fixed over here. This rod is fixed over here. Okay. And you are pulling this rod something like this in the downward direction. Okay. You are pulling this rod from this side in the downward direction. Cool. If I say what is the net torque in this particular case, listen to me very carefully. This force is going to pull the rod with respect to this point, something like this. This will be the torque created by this. Let's suppose this is tau 1. And this force is going to pull the rod something like this. It will create the torque, that is tau 2. You can consider this tau 1 over here as anticlockwise. You can consider this tau 2 over here as clockwise. So when I say net torque, that is 0. So do you think that this body is going to rotate? Absolutely not. So if net torque on a body is 0, it is said to be in rotational equilibrium. What does that mean? That means if the body is at rest, it remains at rest forever. It will not rotate, it will remain in the rest forever. If the body is moving with a constant angular velocity, if the body is rotating with constant angular velocity, it will keep on rotating with the same angular velocity. So means net torque is equal to 0. Means what does torque mean? Net torque means tau 1 will be equals to tau 2. So tau 1 is F1 into R1. This F1 into R1. And tau 2 will be F2 into R2. F2 into R2. So net torque here in this particular case came out to be 0. Net torque came out to be 0. Okay. Absolutely, sir. One more important point I just want to add over here. What is that? That is just a second. See guys, let's suppose you have a block over here. Okay. On this block, you are applying a force. Let's suppose F. From this side also, you are applying the force F. What is the net force on the block? 0. If net force on the block is 0, body is in translational equilibrium. Body is in the translational equilibrium. Okay. So if net force on the body is 0, body is in the translational equilibrium. So force from this side is equal to force from this side. So we say net force in this case is 0. Okay. So if the body is at rest, it will stay in the rest forever. If the body is moving with some constant velocity, it will keep on moving with the constant velocity forever. Okay? Yes, sir. Absolutely, sir. This is what we call the case of translational equilibrium. For net torque is equal to 0, body is in translational. Body is in rotational. Now let's talk about this one. Could you please tell me what is the net force on the body? Sir, the amount of force from this side is equal to amount of force from this side. I can say net force on the body is 0. Absolutely. Net force on the body is 0. Even I would say net torque on the body is also how much? It's 0. Okay. So what I can say, body in... Sir, how do you say net torque on the body is 0? Obviously, guys, torque due to this. Let's suppose this is R. Let's suppose this is R by 2. What is the torque? Tau 1, let's calculate. That is F is the force. Okay. And then we say R by 2 is the vector, position vector. Then I would say sine of, what is the angle between the two? 180. Sine 180 is 0, so torque will be 0. That's what I was saying. So if torque due to this is 0, torque due to this is 0, net torque will be 0. Body in translational as well as a rotational equilibrium. As well as rotational equilibrium. Body in translational as well as rotational equilibrium. What about this one? What about this one? You have got force. You have got force. This is F and this is F. This is the center of mass. In this particular case, my dear NEET aspirants, we say net force is equal to 0. Why? Because the two forces are equal and opposite. And in this case, we say net torque is not equal to 0. Why, sir? Let me show you. See, if this is F, this is L by 2. This is L by 2. Now, if I say how much is the torque due to this, guys, F is acting and this is L by 2. So if I say in this particular case, tau 1 will be force R F sine theta. R is L by 2. F is F sine theta, and that is sine of 90. Angle between F and L by 2 is 90. So F L by 2. And if I say tau 2, that will be also F L by 2. And what is the direction of this torque? It will be anti-clockwise, because it will rotate the body in the anti-clockwise direction. Even this will be also anti-clockwise. So this is ACW. This is also ACW. So that's why we say net torque in this particular case is not 0. So here, body is in translational equilibrium. Only. Now, guys, in this particular case, we say body is in the translational equilibrium only. What does that mean, my dear NEET aspirants? That means body, if the body is at rest, it will not move forward, it will not move backward. It will stay in the state of rest. But body is not in the rotational equilibrium, but that means body can rotate in this case. That means body can rotate in this case. Because A rotational equilibrium is not there. Translational equilibrium is there. Rotational is not there. So body can rotate in this case, but body cannot move in this case. Here, neither body will move nor body will rotate. It will stay in a state of rest. It is called the complete equilibrium. Okay. Yes. 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 Next, translational motion. Let's define translational motion. Let's take a look at this translational motion. See guys, how do we define a body is doing translational motion? Let's suppose this is a body. I'm taking different points on a body. When all the particles, points of a ridged body means which does not deform, moves with the same velocity. All the particles move with the same velocity. It is called translational motion. Like this, the box. If this box is moving, how many particles? Let's suppose we are taking different number of particles from the box. So if all the particles are moving with the same velocity, then the motion is said to be translational. V1, V2, V3, V4, V, all are equal. Rotational. See, when all the particles points of a ridged body are moving in a circular path, they are moving in a circular path of different radius but about a common center, like okay, I was okay. See, when all the particles points of a ridged body are moving in a circular path of different radius, all the points like this point has radius this much, this point has radius this much, this point has radius this much. When all the particles points of a ridged body are moving in a circular path of different radius, okay, but about a common center, this with same angular speed, but different linear speed, it is called pure rotational motion. Now guys, see, in this particular case, what I want you guys to understand over here is, we say here different points are basically performing circular motion. First of all, we say theta for all the is same. Theta means how much angle this is covering. If this point will reach after some time here, this point will reach after some time here, this point will reach after some time here. So if this is 60 degrees, this will be also 60, this will be 60. So theta, they are covering the same angular displacement. Now guys, angular displacement means how much angle they have cut. Then angular velocity. Angular velocity is theta divided by time. Angular velocity is theta divided by time. See, omega is equal to theta divided by time. Angular velocity means how fast it is rotating. Velocity means how fast it is moving. Angular velocity means how fast it is rotating. So if I say theta for all the three particles is same, time is also same. This is same, this is same. So don't you think that their angular speed will be also same? Yes. But when it comes to the linear speed, guys, see. When it comes to the linear speed, listen to me very carefully. This particle is taking, let's suppose, 2 seconds to reach this point. Okay, this particle is taking 2 seconds to reach this point. This particle is taking 2 seconds to reach this point. Sir, I think this is having, this is, let's not say 2 seconds, 2 seconds, 2 seconds. So we say this particle reaches here, this particle reaches here, this particle reaches here. Okay. Or let's consider 2 seconds, 2 seconds, 2 seconds. This is covering the same distance. This is covering this distance in 2 seconds. This is covering large distance in 2 seconds, means here speed will be large. This is covering more large distance in same 2 seconds, where here speed will be more large. So speed V3 will be greater than V2, will be greater than V1. So V1, V2, V3, they will not be equal. These speeds will not be equal. So linear speed will be different, but angular speed will be same in case of a rotational motion. I believe this is crystal and clear. Let me show you some problems on rotational equilibrium because this is important. See. This is important. See, everybody out there, my dear NEET aspirants. The question here is, find tension T1 and T2 in the given figure. In the given figure. Okay. 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 Now guys, take a look. Okay. Let's suppose this is tension T1, this is tension T2. Okay. In this particular case, I am asking you to tell me what is the value of T1 and T2. What is the force acting on this body in the downward direction? That is mg. So what I can say, upward force is T1 plus T2. This will be equals to downward force, that is mg. Okay. Now my dear NEET aspirants, in this particular case, here body is in the equilibrium. Okay, here body is in the equilibrium. We say here we consider T1 will be equals to T2. T1 will be equals to T2. Because when rope is connected at the end points, we say T1 is equal to T2. So we can say this will be 2T. T1 is equal to T2. Let's suppose it is T. So this will be 2T is equal to mg. So T will be equals to mg divided by 2. As simple as that. As simple as that. Okay. Let's suppose you have this question. You have this question. Okay. This is over here T1. This is over here T2. And its mass is M and length is L. Now, what I want you guys to do in this particular case, you have to find T1 and T2 in this case. Okay. And let me take this here. Let me take this here. This is the center of mass. This is the center of mass. This is the center of mass. Now, my dear NEET aspirants, in this particular case, you guys are supposed to tell me what is going to be, find T1 and T2. Okay. Just a second, guys. Now, my dear NEET aspirants, what I want you guys to do in this particular case is listen carefully. Listen carefully. In this particular case, the body is in the translational as well as rotational equilibrium. Okay. Everybody of you, mass is M and length is L. This distance, so this is center of mass. So in the downward direction, mg is going to act. And this entire distance is actually L by 2. So what is going to be this distance? From here to here, this will be L by 4. And how much is going to be this distance? This will be also L by 4. Yes, sir. And if I say, how much is this? This is L by 2 plus L by 4. That will be 3L by 4. This is going to be 3L divided by 4. Absolutely, sir. Absolutely, sir. 100%, sir. Okay, this is center of mass. Now, my dear NEET aspirants, what I want you guys to do in this particular case is, here, body is in a rotational equilibrium. Your body is in rotational equilibrium. Okay. If body is in rotational equilibrium, then make net torque is equal to 0 about let's suppose this is 0.1 and this is 0.2. Okay. About second point. This is a very important question, my dear NEET aspirants, because this will clear all the confusions out. Okay. So net torque is equal to 0, my dear NEET aspirants, about second point. Net torque is equal to 0 about second point. So if I say net torque is equal to 0 about second point, listen carefully, guys. What is the net torque about second point? What is the net torque about second point? I want you to understand this. Guys, see, this is the first point. This is the first point. This is the second point. About second point, how many forces are acting? So leave forces. How many forces can create torque about second point? Sir, I think this mg. And due to T2 about second point is 0 because it is passing through second point, and due to T1. Let's find the torque due to, let's find net torque due to second point. So first I'll be writing due to T2. T2 will be, okay, due to T2 it is 0. Force multiplied by distance, perpendicular distance is 0. Then plus. Then I'll write due to mg. I would say mg is force, Rf sine theta. So this is mg and this distance is L by 4. So mg into L by 4, and angle is how much? 90. So mg L by 4. Then plus. Due to this T1 and this distance is 3L by 4. So that is T1 into 3L divided by 4. Okay. Now, my dear NEET aspirants, in this particular case, what I want you guys to do is, see. If I say this mg, listen carefully, this mg, it is going to rotate, if this is a fixed point, it is going to rotate the rod in this direction, ACW. This T1, about this point, it is going to rotate the rod in this direction into CW. Okay. So if you take one, this is ACW, this is CW clockwise. If you take one positive, another you have to take negative. Okay. Another you have to take negative. I'll be writing over here minus. So take it over here. T1 into 3L divided by 4 will come out to be mgl divided by 4. Now what can you cancel over here? L, 4, 4. So T1 will come out to be mg divided by 3. So with the help of rotational equilibrium, we got T1. Let's find T2. Now, make net torque is equal to 0 about 0.1. About 0.1. Make net torque is equal to 0 about 0.1. Okay. Okay. Now guys, net torque is equal to 0 about second point. So about second point, just a second, this pencil is charging. Now see guys, when you talk about this is about 0.1. Okay. About 0.1, how many forces are acting? Take a look. About 0.1, how many forces are acting? T1, due to T1, net torque will be 0 about 1. So I think here torque is going to be created by mg and T2. mg and T2. Okay. Yes. Now guys, let's follow this. Now I think it is charged. Okay. See guys, about this 0.1, we said T1 is going to create the torque. Sorry, T1 will create no torque because it is passing through 0.1. mg will create How much will be that torque? Mg into L by 2. T2 will create, how much is that torque? T2 into 3L by 4. That's it. I'll be writing the same thing over here. Okay. Okay. So where is that point 1? Okay. Here. So 0 is equal to torque due to first point T1 into 0. Then plus torque due to mg into L by 2. Then plus this you take minus over here. 1 plus another minus. If you are taking anti-clockwise plus, take clockwise minus. So minus T2 into TL by 4. TL by 4. Take it over here. T2 into 3L by 4 is equal to mg L by 2. So 2 ones are 2 twos are 4. So T2 will come out to be 2 mg upon L, and L will cancel. 2 mg by 3. 2 mg by 3. That's it. This is the value of T2, and this is the value of T1. Okay. I believe this is crystalline clear. Okay. So here, why did you consider T1 and T2 same? Because a rope is connected at the end points. A rope is connected at the end points. End points. You mention it because a rope is connected at the end points of the rod. The rope is connected at the end points of the rod. Okay. I believe this is clear, crystal to each and every single student. Okay. Yo. Okay. Now, guys, in this particular case, let me show you a question. This is a question from, this is also the question of rotational equilibrium. See, the question is something like this. The question is something like this. I'll make you understand. Okay. Okay. This is a rod, and this is center of mass. This is center of mass. Okay. Now this distance is given as This distance is given as 40 centimeters, and this distance is given as 60 centimeters. 60 centimeters. This is 2 kg. This is m, and this is given as 20 centimeters. This is given as 20 centimeters. Understand this very carefully. Okay. This is given as 20 centimeters. And one more important thing, my dear NEET aspirants. One more important thing, my dear NEET aspirants. It is 160 centimeters. Wait. 160 centimeters from here to here. What else is given? Mass of the 200 centimeters is the total length of the rod. Okay. 200 centimeter. Length of the rod 200 centimeters. Okay. Mass of the rod 500 grams. Okay. Okay. Okay, that's cool. And this is a question of NEET 2021. NEET 2021. In this particular case, this is the mass of the rod. I'll write over here mass of the rod. Now, in this particular case, what you guys are supposed to do is listen carefully. You have to tell me this M. This M. Okay. Let's make net torque is equal to 0. We know rotational equilibrium. I would say make net torque is equal to 0 about the wedge. About this wedge, make net torque is equal to 0. Absolutely, sir. Absolutely, sir. When you make net torque is equal to 0 about the wedge, I want you to understand this very carefully. I want you to understand this very carefully. My dear NEET aspirants, what are the forces acting in this particular case? First of all, I would say forces acting on this. That is M into G. M into G. So we'll say, sir, M into G. So M divided by 2, I'll write over here. Why? Because its mass is 500 grams. Okay. Okay. So I can say M into G over here. First of all, M into G in the downward direction. And what is the weight acting over here? 2G. That is 2G. That is 20 Newton. Absolutely, sir. Okay. Yes. Yes. This force. And what is the force acting in this case? M into G. Let's keep the mass of the rod as capital M. So this is capital M. So mass of the rod, capital M, is equal to 500 grams. Okay. And one more important thing. So how many forces are acting over here? 20 mg, this mg. So make the net torque is equal to 0 in this particular case. So net torque is equal to 0 about the wedge. So net torque is equal to, what is the net torque about this wedge? That is this force multiplied by this perpendicular distance. Okay. This force, guys, multiplied by perpendicular distance. If this is 20, this is how much? 20. 20. Okay. I will just write over here. In this particular case, net torque is equal to Due to this 20, and this will be how much? This distance is how much? That is 20 centimeters. 20 into 20. Then plus, my dear NEET aspirants, what is due to this? Guys, in this particular case, what I want you guys to understand over here is length of the rod is 200 centimeters. This is very important. Total length is 200 centimeters. This is 200. This length is how much? 40. So this length would be how much? This length will be how much? If this is 40, half of the rod will be, sorry, 200. This is be 100. So how much will be this? 60. So this will be 60 centimeters. This will be 60 centimeters. So this is 60 into what is the force acting over here? That is mg. Into mg. Then plus, guys, when I say this distance from here to here, it is 20. This is 60, means 80. And this is again, okay, this is total of 160. 160 minus this 20, it is 1. Okay, this is 160. Okay, wait. This is 160 from here to here. 160 minus this 40, that will be 120. So this distance will be 120. So I can say this is mg into 120. That's it. We are done with the question. Mg into 120. Okay. Okay. So this net torque is equal to 0. And one more important question, my dear NEET aspirants. If I say torque due to this, it will be something like this. This mg will rotate the rod about this point, something like this, clockwise. This will be also clockwise. Okay, but this will be anti-clockwise. About this point, it will rotate in anti-clockwise direction. So consider it negative. It depends. Some people take that positive, some people take this negative. Take it over here. If you take it over here, this will be 400 in this particular case. Or keep this like this only. This is 20 Newton means 2G. So keep it 2G only, because G will be cancelled. G will be cancelled. So take this over here. This is 20 into 2G will be equals to 60 into mg. M, how much is the mass? That is 500 grams. 500 grams means how much? 0. That means half kg. Half, I'll write 1 by 2. So I would say in this particular case, 60 divided by into 1 by 2 g. Okay. So 60 into g by 2 I can write over here. 60 into g by 2 plus m into g into 120. So g and g will be cancelled. G and g will be cancelled. So this will be 40. This will be 30. Okay, this will be 30 and this will be 120 m plus 120 m. So solve it. M will be 1 by 12. This was a good question. Very, very good question. Amazing question. And this was the question of NEET 2021. Yes, this one. Okay. So this translation motion is done, in which all the particles have same velocity. Rotational motion is done, in which angular speed of different particles will be same. Omega 1, omega 2, omega 3, because theta is same. But linear speed of different particles will be different, because this particle, when it reaches here in the same time, so this has covered more distance, third one. So its speed will be large. That's why it is mentioned over here. When all the particles of a rich body are moving in a circular path. All the particles are moving in a circular path of different radius about a common center with same angular speed but different linear speed. Then it is called pure rotational motion. Here, linear speed, linear velocity of the particles is different. Linear displacement. Guys, see, when the particle moves from here to here, it will have two speeds. How fast it is going, that is speed. How fast it is rotating, that is angular speed. Angular speed, linear speed. Particle will have both. So here linear speed will be different, but angular speed will be same. See, let's basically do the comparison of translational and rotational motion. This point I'll make you understand once again. When rod reaches from this point to this point, when rod reaches from this point to this point, this is the point, this is another point. So this point moves from this point to this point. This point moves from this point to this point. So when an object is moving, it has velocity. When an object is rotating, it has angular velocity. So in this particular case, since the rod is rotating, so these points have angular velocity omega. So these points have linear velocity also, because they are covering linear displacement na s. Linear displacement na s. Yes. Okay. Yes. Let's take a look first. Translation motion, rotational motion. After this, you'll get to understand each and every single point. Take a look. Take a look, guys. When it comes to the translational motion, displacement is S. An object moves from here to here. How much displacement it is covering? S. When it comes to the rotational motion, we said displacement is theta. If a rod is rotating, it reaches here. So from this point to this point, from this point to this point, how much angle it is cutting, that is angular displacement. Okay. Here you say velocity is ds by dt. Differentiation of displacement with respect to time gives you velocity. And in this particular case, you say velocity is, here you have angular velocity, that is d theta by dt. Okay. How fast an object is rotating? Sir, fast, angular speed is large. How fast an object is moving, speed is large. Here you have acceleration, that is dv by dt. Here you have angular acceleration, that is d omega by dt. That is d omega by dt. Okay. Absolutely, sir. Okay. Then, my dear NEET aspirants, here you have force is equal to dp divided by dt, or we say mass into acceleration. Here also you have rotational version of Newton's second law. F is equal to dl by dt. Here you have momentum p, you have angular momentum L. Or we say you have here mass into acceleration. Here in this particular case, instead of mass, you have moment of inertia I. Instead of acceleration, you have angular acceleration alpha. You see the analogy over here? You can clearly see the analogy in this case. Okay. You have momentum. This got disconnected again. So let's charge it for a minute. Let's charge it for a minute. Now see guys, take a look. You have I into alpha. So moment of inertia into angular acceleration. Okay. You say here, when it comes to the work done, or you say momentum, momentum is P is equal to mv. Here you have angular momentum, L. And instead of mass, you have moment of inertia. Instead of velocity, you have angular velocity. You have work done, F dot S, force dot displacement, or we say F dot ds. In this particular case, you have work done, that is tau dot theta. Instead of force, you have torque here. Instead of displacement, you have angular displacement over here. Or you can say tau dot d theta. You can write it like this, like you have F dot S. Absolutely, sir. Okay. Then you can say we have kinetic energy here, 1 by 2 mv square. Or we say p square divided by 2m. Okay. And you have kinetic energy in this particular case, 1 by 2 I omega square. Because 1 by 2 mv square. Instead of m, you have I. Instead of v, you have omega. And you can say in this particular case, or p square by 2m. So here you have L square by 2i. Because this also I have explained previously in work, power and energy. Okay, p square by 2m. This is L square by 2i. Okay. Okay. Okay, you have power. Power is force dot F dot V. Here in this particular case, you have power. The body is rotating. So tau dot omega. Okay, what else do you have? You have impulse. Impulse, short time force, or we say change in momentum. That is m delta V. Or we say F dt. Okay. Or you say integration F dt, or you write directly this only. That is integration F dt. I have told you this previously in Newton's laws of motion. And in this particular case, you have angular impulse. Okay. And this will be simply integration of tau dt. Integration of tau dt. So basically all of these are, this is rotational angular momentum. Okay, angular velocity. Okay, this is work done. This is over here, rotational kinetic energy, angular acceleration. And here we don't have force, we have torque, sorry. So here you have force, here you have torque. I believe this is crystalline clear. I believe this is crystalline clear. One more important thing I just want to mention over here. That is translational motion. When acceleration is constant, we use this equation, V is equal to U plus AT. Similar equation we have here when angular acceleration is constant. In that case, we say when angular acceleration is constant, V is equal to U plus AT, you say final angular velocity is equal to initial angular velocity plus alpha t. Plus alpha t. You have S is equal to ut plus 1 by 2 AT square. In this particular case, you have theta is equal to omega I into t plus 1 by 2 alpha t square. Okay. Okay. Then you have v square minus u square is equal to as. In this case, you have omega final square minus omega initial square is equal to 2 alpha theta. 2 alpha theta. Okay. 2 alpha theta. Plus 2 alpha theta. Then we say displacement in nth second, s nth, u plus a divided by 2, 2n minus 1. Here, angular displacement in nth second, you can say omega initial plus alpha divided by 2, then we say 2n minus 1. So similar formulas you have, means here body is moving straight, here body is rotating. That's it. Similar formulas you can expect over here. Similar formulas. Okay. Yes, absolutely. What else do you have? Like, see guys, in this particular case, when you write v is equal to u plus at, here you have, instead of v, what is v? Final velocity, initial velocity, acceleration into time. Final angular velocity, initial angular velocity, angular acceleration into time. Displacement s, initial velocity, angular acceleration. Angular displacement, initial angular velocity, angular acceleration. Displacement in nth second. If a body is moving, so this is the displacement in first second, second second. This is the displacement in third second. Similarly, how much is the angular displacement in nth second? If a body is rotating, so it reaches here. So how much is the angular displacement in first second? How much angle it has cut in first second? How much angle it has covered in second second? How much angle it has covered in third second? So theta is equal to omega I into t plus 1 by 2 alpha t square. Okay, so here. Angular displacement in nth second is equal to initial angular velocity plus alpha by 2. Then we say 2n minus 1. Then we say 2n minus 1. Okay. Yes. Then, my dear NEET aspirants, what else do you have? What else do you have? You have few more formulas. So here you say stopping distance, u square divided by 2a. Sir, stopping distance is that distance when the car applies brakes, after how much distance it will cover after that. Okay, you have stopping angle, theta, stopping angle. That will be ui square divided by 2 alpha. Ui square divided by 2 alpha. Okay. Okay. Yes. I hope this is crystal and clear. Okay. One more important formula I just want to mention over here. Since we studied everything, let me just tell you this also. Guys, do you remember in kinematics I told you that if an object starts from rest with constant acceleration, object starts from rest with constant acceleration. Okay. In that particular case, we used to say displacement covered in the first second is to displacement covered in the second is to displacement covered in the third second is to displacement covered in the fourth second. This was ratio was x is to 3x is to 5x is to 7x and so on. And the second ratio was displacement covered in 1 seconds is to displacement covered in 2 seconds is to displacement covered in 3 seconds is to displacement covered in 4 seconds. This will be x is to 4x is to 9x is to 16x is to 25x and so on. But right now, my dear NEET aspirants, what I want you to understand is, okay, ratio of angular displacements. See guys, a ratio, these are what we call the ratio of linear displacements. I would write over here a ratio of linear displacements, and then I would write over here a ratio of angular displacements. Okay, ratio of angular displacements. If you write the ratio of angular displacements, my dear NEET aspirants, just a second. A ratio of angular displacements, my dear NEET aspirants, we say angle covered in the first second is to angle covered in the second is to angle covered in the third second is to angle covered in the fourth second. Ratio will be same. X is to 3x is to 4x is to 7x and so on. Okay. Then we say angle covered in 1 seconds is to angle covered in 2 seconds is to angle covered in 3 seconds is to angle covered in 4 seconds. It will be x is to 4x is to 9x is to 16x and so on. Okay. Okay. Yes. Absolutely. Take a look at this, my dear NEET aspirants. Okay. Now, guys, take a look. There is a question over here. I want you guys to take a look on this. This was asked in NEET 2023. See, a constant torque of 100 Newton meter. A constant torque of 100 Newton meter. Okay. A constant torque of 100 Newton meter turns a wheel of moment of inertia 300 kg meter square about an axis through its center, starting from the rest. Its angular velocity after 3 seconds is. See, guys, in this particular case, a constant torque is acting on the wheel, which has moment of inertia given 300 about an axis passing through its center. A wheel is rotating. So how much torque is acting on the wheel? How much torque is acting on the wheel? 100 Newton meter. Okay. And my dear NEET aspirants, okay. And what is given as moment of inertia? That is given as 300. What we are supposed to find? Okay, initial angular velocity is 0. Why? Because it says the wheel starts from rest, means initial angular velocity will be 0. Its angular velocity after 3 seconds. We are saying final angular velocity in this case. Sir, I can use this equation. Final angular velocity is equal to initial angular velocity plus alpha into t. V is equal to u plus at. That equation only. Now in this particular case, final angular velocity we need to calculate. Initial angular velocity is 0. But angular acceleration is not given. And it says time is 3 seconds. So time is given as 3 seconds. So what we do is we say as. We'll use this formula. Take a look at this, guys. To find the velocity, final angular velocity, I'm using this. And to find the angular acceleration, I am using this. Tau is equal to alpha into I into alpha. So we can say as tau is equal to I into alpha. Rotational version of Newton's second law. It is F is equal to ma, like that only. So from here, alpha will be tau divided by I. What's the value of tau? 100, I is 300, this, 1 by 3. 1 by 3 radian per second square. Now, final angular velocity is equal to initial angular velocity is 0. Alpha is 1 by 3. Time is 3. 3 and 3 will cancel. It will be 1 radian per second. Okay. A string is wrapped around a rim of wheel of moment of inertia 0.40. This is the wheel which is having the moment of inertia 0.40. Okay. Yes. And radius 10 centimeter. And radius is 10 centimeter. The wheel is free to rotate. The wheel is free to rotate about an axis. The wheel is free to rotate about an axis, about its axis. Initially, the wheel is at rest. Now the string is pulled with a force of 40 Newton. The angular velocity of the wheel after 10 seconds is. Take a look, guys. This is also a good question. See, what does the question actually say? I want you to understand this. You have got a wheel over here. This is a wheel. Okay, this is a wheel. Now there is a string wrapped around the wheel. Okay. Now you are pulling the string with a 40 Newton force. So string is wrapped. Now you are pulling the string with 40 Newton force. So the wheel will rotate. And this is 10 centimeters. Its radius. Okay. Now it says that if you pull it with a force of 40 Newton, what is the angular velocity of the wheel after 10 seconds? You have to tell me final angular velocity after how much time? 10 seconds. And moment of inertia in this case is 0.40 kg meter square. 0.40. Okay. Yes. And force is acting as 40 Newton. Now you'll be simply saying, sir, once again, I'll use the same formula. Final angular velocity is initial angular velocity plus alpha into t. But the question is alpha is not given. Alpha is not given in this case. Okay. So what I want you guys to do in this particular case is, let's find torque first. How do we find the torque? Torque will be R into F. So torque will be R is 10. Okay. And it is in centimeters. Convert this to the meters. Convert this to the meters. So it will be 10 divided by 100. So when you convert centimeter into meter, you divide with 100. And force is 40. 0, 0, 0, 0. So it will be 4. So tau is 4. Moment of inertia is 0.40. So we say tau is equal to I times of alpha. So alpha will be tau divided by I. So tau is 4. This is 0.40. Okay. Now guys, this is 4 upon 40 divided by 100. And this will cancel. So this will be 40 by 4. That is 10. Alpha is 10. The final angular velocity you can write. Initial angular velocity is 0. Angular acceleration is 10. And it says after 10 seconds. So this will be 100 radian per second. I believe this is crystal clear to each and every single student. This is a question of J Mains 2024. Okay. Yes. I believe this is crystal and clear to each and every single student. A circular disc of radius r and mass m rotating about an axis perpendicular to its plane. Rotating about an axis perpendicular to its plane. Okay. An external torque is applied such that theta is equal to t, such that theta is equal theta of t is this. How much power will be delivered? Okay. J Mains 2025. Take a look, my dear NEET aspirants, what I'll do in this particular case. I want you to understand this very carefully. See, you have to find power. A circular disc has a radius r, mass m is rotated about this axis. An external torque is acting on the disc. Okay. Such that this is the angular displacement. How much angle it has cut? This much. How much power is delivered by the torque when t is equal to 2 seconds? When you are applying the torque over here, we say power will be delivered. It is like if you have a body, if you apply force on this, it will do some displacement. We say work is done, power is delivered, and if it gains some velocity, we say power is delivered, power given to the object. So power will be force into velocity. Here also, if you apply torque on this body, so power will be delivered. And if somebody says CC as power is equal to F dot V, okay, here power is equal to tau into omega. Tau into omega. Now the problem in this particular case, torque is applied, but torque we don't know. Torque we don't know. And omega also we don't know. Here both the quantities we don't know. How can we find the power? But theta we know. If theta is given, that is 5t square minus 8t. If we do the differentiation, we'll get omega. Omega is equal to d theta divided by dt. So that is 5 twos are 10t minus 8. Differentiation of this will be 10t minus 8. Differentiation of this will be 10t minus 8. Now guys, from this you can find alpha. Alpha is again differentiation of angular velocity. Differentiation of displacement is omega. Differentiation of angular velocity is alpha. D omega by dt. That is 10. For 8 it is 0. Now you can find torque. Torque is I times of alpha. So torque will be I into alpha. Okay. Now guys, what is the moment of inertia of a ring about its center? About this, that is mr square. Okay. It is a ring or disk. It's a disk. It's a disk. So moment of inertia will be mr square divided by 2. Okay. So you'll be writing over here, torque will be mr square divided by 2 and alpha is 10. So 2 ones are 2, 5s are 10. So it'll be 5 mr square. So you got the value of torque, my dear NEET aspirants. You got the value of torque. If you got the value of torque, you'll be putting power is equal to torque is 5 mr square into omega. What is the value of omega? Omega is 10t. So I would say, wait. So omega in this particular case is 10t minus 8. We have to find torque at, we have to find power at t is equal to 2 seconds. Find omega at 2 seconds. At t is equal to 2 seconds, omega will be 10 into 2 minus 8. 20 minus 8, that is 12. So multiplied by 12. Okay. Now into omega. So power will be 60 mr square. I hope you got this, what I'm trying to say here. Okay. Just a second, guys. Just a second. In pure translation, we say kinetic energy is equal to 1 by 2, 1 by. Now see, kinetic energy is pure, kinetic energy in pure rotational motion. Kinetic energy is 1 by 2 mv square. Okay. This is pure translation motion. And we have studied, sir, kinetic energy is equal to 1 by 2 mv square. Multiply with m and divide with m. So this kinetic energy will come out to be, that is m square v square divided by 2m. We know that m into v is momentum. So kinetic energy will come out to be p square divided by 2m. P square by 2m. P square divided by 2m. Now in pure translation, in pure translation, okay, so this is pure translation means when the body is rotating, this body is rotating, okay, with omega, it has moment of inertia I. So here kinetic energy is going to be 1 by 2 I omega square, because here it is 1 by 2 mv square, here it is going to be 1 by 2 I omega square. So here kinetic energy in this particular case will be 1 divided by 2 I omega square, multiply with I and divide with I. Like here you guys did. Multiply with I and divide with I. Now my dear NEET aspirants, you'll be like, sir, kinetic energy will be I square omega square upon 2 into I. Now guys, after some time, okay, after some time, I am going to teach you that as this angular momentum is I times of omega. Angular momentum is the momentum in angular motion, that is I times of omega. So you can write this kinetic energy will be, that is L square divided by 2I. You can exactly see the replica of this in rotational motion. You can see the rotational motion replica. Okay. Absolutely, sir. Absolutely, sir. Now, my dear NEET aspirants, what I want you guys to do is see. Okay. Now, my dear NEET aspirants, we got two formulas of kinetic energy. Kinetic energy is 1 by 2 I omega square. Okay. And kinetic energy is I. Where did that go? This one. Kinetic energy is L square by 2I. Okay. Now, guys, if I say, let's suppose, if, listen to me very carefully, my dear NEET aspirants. If I say, omega is constant, in some case, omega is constant. In that case, we can say kinetic energy will be proportional to moment of inertia. It will be proportional to moment of inertia. This is kinetic energy. This is moment of inertia. So this will be the straight line graph. And my dear NEET aspirants, if in some case I say angular momentum becomes constant, in that case kinetic energy will be inversely proportional to moment of inertia. So over there you will be making the graph that is kinetic energy versus I. It will be rectangular hyperbola. It will be rectangular hyperbola. Okay. I believe this is crystal and clear. I believe this is crystal and clear. Okay. So this is kinetic energy. This is kinetic energy. Okay. Kinetic energy and this is kinetic energy. So this is direct. This is inverse. Okay. Yes. Okay. Let's suppose if I say what is the kinetic energy of this body? What is the kinetic energy of this disk? You say, sir, kinetic energy will be 1 by 2 I omega square. 1 by 2. What is the moment of inertia of this disk? mr square divided by 2 into omega square. If it is rotating with omega, you'll be saying mr square by 4, mr square by 4 into omega square. Okay. And when I say kinetic energy of this body, 1 by 2 I omega square. 1 by 2, what is the moment of inertia of this? This is a solid sphere. For solid sphere, it is 2 by 5. 2 by 5 mr square into omega square. 2 divided by 10 mr square into omega square. So that is mr square by 5 into omega square. Okay. Yes. I believe this is clear. I believe this is crystal and clear. Okay. Let's take a break of 10 minutes, guys. Huh? I'll be back in 10 minutes. Okay. Now, guys, let's move on to the conservation of mechanical energy. Let's move on to the conservation of mechanical energy. What does conservation of mechanical energy say? It simply says, according to COME, conservation of mechanical energy. It says total energy initially is equal to total energy finally. Conservation of mechanical energy simply says total energy initially is equal to total energy finally. What does that mean? That means kinetic energy initially plus potential energy initially will be equals to kinetic energy finally plus potential energy finally. Okay? Yes. This is what we call conservation of mechanical energy. Total energy initially is equal to total energy finally. Now, my dear NEET aspirants, what I want you guys to do in this particular case is, see, you have a rod over here. You have another rod over here. See, there's a question. The question is, okay, this is just one rod only. These are not two rods. So this is a rod over here. It is fixed at this point. If you release this rod, so we say it will go, and it will cross this point. If the rod of mass m and length L is released, if we release it, find the angular speed when it becomes horizontal. What is its angular speed when it becomes horizontal? When it becomes horizontal, we have to find the value of omega. Now, in this particular case, I would prefer to use conservation of mechanical energy. We say use COME. Conservation of mechanical energy says total energy initially is equal to total energy finally. And that is kinetic energy initially plus potential energy initially will be equals to kinetic energy finally plus potential energy finally. Something like this. Okay. Now, my dear NEET aspirants, when it comes to the kinetic energy initially, that is zero. Because initially it is released from rest. If an object is released from rest, its omega initial is zero. So kinetic energy initial will be 1 by 2 omega initial into I square. Since this is zero, so entire term will be zero. Okay. Then plus potential energy initially. Now tell me, my dear NEET aspirants, how many times I have told you previously. Let me recall that once again. Let me recall that once again. I have told you that if this is a surface, okay, okay. If an object is placed on the surface, we assume its potential energy as zero, because on the surface we say potential energy is a reference. This is the reference line. On the reference line, we assume zero. Just a second, guys. I'll switch on the generator because this electricity is gone. Now guys, so we say on the surface, if an object is placed on the surface, we assume its potential energy as 0. And if the surf object is placed, rod is placed like this, it has mass m and length l. So we assume its mass to be at center of mass. What is its potential energy? U is equal to mgh. So m is the mass, g is acceleration due to gravity, and h is the height at which mass is present. So here it is at L by 2. So L by 2. And if an object is placed, if the rod is placed something like this, we assume its center of mass here. So here we say it is minus mgl by 2. So in this particular case, it is 0. In this particular case, it is plus mgl by 2. In this particular case, it is minus mgl by 2. As simple as that. As simple as that. Now come here. Now guys, if the rod is placed something like this, its mass is m, length is l. What is the potential energy of this rod over here? That is, I would say m g l divided by 2 is equal to finally, guys, when it reaches here, here it has angular velocity omega. So it will be 1 by 2 I omega square. Okay. Then potential energy on the surface will be 0. At this point, potential energy is going to be 0 because it is on the surface. It is on this reference line. So 2 and 2 will be cancelled. Okay. So omega square will be, take this I over here, mgl divided by I. Okay. 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 mgl 1 by 2 I omega square. Okay. Okay. Do one thing, guys. One more thing you can do over here, that is mgl is equal to I. What is the moment of inertia of the rod about this axis? It is passing through its edge, ml square by 3. Okay, so it is going to be ml square divided by 3 into omega square. Now m will cancel, l square, square and l will cancel. Okay, so this will be 3g divided by l is equal to omega square. Okay, so omega will come out to be under root of 3g divided by l. 3g divided by l. Okay, even at this particular instant, you can find its linear velocity also. Because when an object rotates, it has both linear as well as angular velocity. So at this instant, you can find its linear velocity also at this instant. Okay. Now guys, how do we find the linear velocity? One equation I would want you guys to remember. What is that? That is relation between linear velocity and angular velocity. V is equal to r omega. V is equal to r omega. Now, my dear NEET aspirants, we can say V is equal to R. R means this radius from the fixed point, R omega. And omega in this particular case is 3g divided by L. So V will come out, instead of R, I can write L under root of 3g divided by L, because this from the fixed point, its length is L. So this will be the linear velocity. Okay, and one, see more specifically, if I just write, this is the linear velocity of point A. This is which point? Sorry, point B. Because point B is at what distance from here? L. That's why I'm taking R is equal to L. So this is the linear velocity of point B. If I say linear velocity of point A, this is an interesting question. Linear velocity of point A. So now point A is at what distance? Take a look. It is at L by 2 distance. Sir, will there be different linear velocity for all the points? Yes. What about omega? Omega is same for all. That's what I was explaining. In case of rotational motion, omega is same for all. V is different for all. V is different for different points. So you guys will say in this particular case, V is equal to R under root of 3G divided by L. So V is equal to, here it is L by 2 for point A, under root of 3G divided by L. Now I hope this question is crystalline clear. This question is crystalline clear. This one. Okay. Yes. Now guys, take a look. The question says, an energy of 484 joule is spent in increasing the speed of the wheel from 60 RPM to 360 RPM. Okay. An energy of 484 joule is spent in increasing the speed of the wheel from 60 RPM to 360 RPM. Understand this very carefully. This is 60 RPM means a rotation per minute. 360 RPM, 360 rotations per minute. In every minute, how many rotations the wheel is going to do. This is what we call frequency. Okay. So here, if I say F1, F initial frequency. Frequency means number of cycles per second, number of rotations per second. So here frequency is given per minute, 60 rotations per minute. So if you have to convert this into per second, you'll be saying 60 divided by 60. To convert this in per second, 60 by 60. It is going to be 1 revolution, yeah, 1 rotation per second. Okay. 1 rotation per second. If I say final frequency is 360, if you want to convert, this is 360 per minute, 360 divided by 60. This is going to be 6 R per second. How many rotations per second? 60, sir. Sir, 1, sir. Per minute, 60 rotations. Per second, 1 rotation. Obviously. The moment of inertia of the flying wheel is. Okay. Okay. And energy is spent. How much energy is spent? Okay. So we have basically used our energy to we have used our energy to change the speed of the wheel, from 60 RPM to 360 RPM. And this is a question of NEET 2022. Now the moment of inertia of the flywheel is. Just a second. So the moment of inertia of the flywheel is, that is what we are supposed to find out in this particular case. Now guys, what I want you guys to do in this particular case is, I want you to use work energy theorem. Sir, what is work energy theorem? That I have told you recently in the work, power and energy, but I'll explain that once again. You don't have to worry about that. Guys, see. I would recommend you guys to use here work energy and theorem. Use work energy theorem. I'll be directly writing over here. What does that say? As we know, we say work done by all the forces is equal to change in kinetic energy. This is the work energy theorem. Work done by all the forces is equal to change in kinetic energy. You can directly remember it over here. Okay. No need to confuse yourself. Work done by all the force is equal to change in kinetic energy. Now, my dear NEET aspirants, what I want you guys to do in this particular case is, here we say how much energy is spent. 484 joules means this much of work you have done. You can say energy is spent, because see, the amount of energy you are spending in doing what? In doing what? Work. So this 484 you can consider as work, because you are using this energy to do work now. You are using this energy to increase its speed now from 60 RPM to 360 RPM. Okay. And kinetic change in kinetic energy means final kinetic energy minus initial kinetic energy. So this is 484 is equal to kinetic energy is 1 by 2 I omega square. So 1 by 2 I, take common, final omega square minus initial omega square. You can write it like this. Okay. Now, my dear NEET aspirants, we say as one more important relation I want you to remember. Omega is also equal to 2 pi f. This is the relation between omega and frequency. Omega is 2 pi f. So can I not write this over here? That is 484 is equal to 1 by 2 I. Then omega final, that is 2 pi, omega square, that is 2 pi f final square. And how can I write that? How can I write that? 2 pi f final square means 4 pi square f final square minus, and take this minus 4 pi square f initial square. So what you can write over here, 484 is equal to 1 by 2 I. Take this 4 pi square common. So final frequency square minus initial frequency square. Okay. So this will be 484. Okay. Is equal to 1 divided by 2. So 2 ones are 2 twos are 4. So So this will be 2 pi square into I. What is final frequency? 6. Initial is 1. So 6 square minus 1 square. Okay. Absolutely. So 6 square minus 1. So this will be 484 is equal to 2 pi square into I. 6 square, 36 minus 1, that is 35. Okay. Okay. Now solve this. I will come out to 0.7 kg meter square. Okay. Because see, 2 ones are, 2 twos are, 2 fours are, 2 twos are. So now 242 divided by 35 is 0.7. This question is also important because we have used the work energy theorem. I believe this is crystal clear to each and every single student. Okay. Let me just write you one more question over here. Let me just write you one more question over here. The question is, when a stick is released, as shown in the figure, when a stick is released as shown in the figure, what will be its free end velocity when it strikes the surface? See, this is the stick. Okay, this is a stick. And in this particular case, we say L is 0.6. Okay. If it is released, okay, so we are supposed to say what will be its free end velocity. So It is still here only. It is still here only. Okay. What will be its free end velocity? This is fixed end. This fixed. And this is free end. Free end means velocity of point A. Okay. What will be its free end velocity? Tell me one thing. When a stick is released, when a rod is released from certain height, here is the generalized case. What is its angular velocity? Under root of 3g by L. What is the velocity of the center of mass? You can understand, sir. L by 2 under root of 3L by G. What is the velocity of free end? You can say this is the velocity of free end. Free end. You can say this is the velocity of center of mass. That point only. L by 2. Okay. Now guys, in this particular case, when it comes to the omega, first angular velocity omega under root of 3g divided by L. Okay. 3L. L is given as 0.6 meters. Okay. So in this particular case, velocity will be R under root of 3g divided by L. And instead of R, what should I write? What should I write? That is L. Instead of R, what should I write? That is L. So value of L is 0.6 under root of 3g divided by L. So 3 into g is 10 divided by L is 0.6. Okay. So what will you write over here? 0.6 is 6 by 10 under root of 3 into 10 upon 6 divided by 10. 3 ones are 3 twos are 6. So this will be 6 divided by 10 under root of 10 into 10 is 100 divided by 2, that is 50. Okay. So 2 threes are 6, 2 fives are 10. So this will be 3 divided by 5, a root of 50. Okay. And now you can follow this, calculate this. It comes out to be 4.2 meter per second. Please do check it from your end also. So do check it from your end also. Now there is a question which was asked in NEET 2018. Question is there. Question was asked in NEET 2018. Three objects. A is solid sphere. B is circular disc. And C is circular ring. Okay. Each have same mass and radius. Okay. They all spin with same angular speed. omega. The amount of work required to bring them to rest. The amount of work required to bring them to rest. I'll write options over here also. Okay. WB is greater than WA is greater than WC. WA is greater than WB is greater than WC. WC is greater than WB is greater than WA. Option D. WA is greater than WC is greater than WB. These are the three options. Okay, these are the three options you have got, four options you have got. Now guys, see, listen to me very carefully. You have three objects: solid sphere, circular disc, circular ring. Okay, circular ring. Okay, each have same mass and radius. Each have same mass and radius. Each have same mass and radius. Okay, they all spin. They all spin with same angular speed. They're spinning with the same angular speed. The amount of work, now if we want to bring them to rest, we need to do the work done. Okay, so where do we have to do the more work done? See guys, this is a very good question. We say work done is equal to change in kinetic energy. Okay, so change in kinetic energy means final kinetic energy minus initial kinetic energy. Okay, so you would say this work done, it is proportional to, listen to me very carefully, it is proportional to kinetic energy simply. That is kinetic energy. Or it is proportional to 1 by 2 I omega square. I omega square. Because simple, work done is kinetic energy. Kinetic energy is 1 by 2 mv square. Now it says that all are moving with the same angular speed if omega is constant. If omega is constant, my dear NEET aspirants. So we say work done is proportional to kinetic energy is proportional to moment of inertia, obviously, because this is constant. But change in kinetic energy is also the kinetic energy, no? It will have some value, yes. Yes. Now, the one which has more moment of inertia will require more work in stopping. So we can say moment of inertia of a ring, mr square, is greater than moment of inertia of hollow sphere. Hollow sphere is greater than moment of inertia of disk. Is greater than moment of inertia of disk and is greater than moment of inertia of solid sphere. Because see, in case of a ring, see, moment of inertia concept is simple. More is the mass away from axis of rotation, more is going to be the moment of inertia, because I is equal to mr square. You can understand it like that. More is the mass away from the axis of rotation, more is going to be the moment of inertia. As simple as that. Okay. More is the mass away from axis of rotation, more is going to be the moment of inertia. Yes, absolutely, sir. Absolutely, sir. Okay. So in case of a ring, we say mass is away from the axis of rotation. It is present on the circumference only. It is present on the circumference only. So it is greater than moment of inertia of disk and it is greater than moment of inertia of solid sphere. solid sphere. Even you can check it also, guys. This is mr square. This is 2 by 3 mr square. 2 mr square divided by 3. Here, this is mr square divided by 2. This is 2 by 3 is 1.6. 0.6, sorry, 0.6. So, see. This is 1 mr square. You can write it like this. This is 2 by 3 mr square, means 0.6 mr square. This is mr square by 2, that is 0.5 mr square. Okay. Similarly, this is 2 by 5 mr square. This will be even less than this. Okay. Now the one which is having less moment of inertia will have less work done, will require less work done because that will have less kinetic energy. So, and in this particular case, my dear NEET aspirants, final kinetic energy is 0. Final kinetic energy is 0. That's why I'm saying work done is change in kinetic energy is proportional to kinetic energy is proportional to 1 by 2 I omega square. Because change in kinetic energy here is Ki. Final kinetic energy is 0 because finally it comes to rest. So I can say, so work done of C is greater than work done of B is greater than work done required in A. So which option? Option A. I hope this is crystal and clear. I hope this is crystal and clear to every single NEET aspirant out there. Now, guys, one more important concept I would like to tell you in this particular case. See, guys, let me tell you what is the concept. I'll make you understand the concept. Okay. Oh, there is some mic issue, guys. There was some mic issue. Wait. Okay. There was some mic issue. Okay. Let me repeat these two questions. Wait. Okay. Let me repeat these two questions quickly. See, not an issue. Not an issue. Let me repeat these two questions. So there is a stick over here. It says that if the stick is released, okay, with what speed, what will be the speed of its free end? This is called a free end. This is called a fixed end. What is the speed of the free end? We recently told you angular, that is what we derived, under root of 3L by G is the angular speed of the rod. And velocity of this free end will be V is equal to L under root of 3G divided by L. Okay. And L in this particular case is given at 0.6. So put 0.6 over here, 3G. G is acceleration due to gravity 10, 0.6. And then we calculated, it came out to be 4.2. Second, you have three objects, sphere, solid sphere, circular disc, circular ring. Each have same mass, same radius. They all spin with the same angular speed omega. The amount of work required to bring them to rest. Now guys see. It says that three objects are rotating: solid, sphere, circular disc, and ring, with constant angular speed omega. If we have to bring them to rest, we need to do the work. In which case we need to do more work. We said work done is equal to change in kinetic energy. So final kinetic energy minus initial kinetic energy. So finally all the three come to rest. So what is final kinetic energy? 0. Because kinetic energy is 1 by 2 I omega square. Final omega is 0. So this is kinetic energy initial. So work done is proportional to kinetic energy. That is proportional to 1 by 2 I omega square. Since omega, angular speed for all the three, is constant, omega is constant. So work done is proportional to kinetic energy, and that will be proportional to moment of inertia because this is constant. Now, which of the three has more moment of inertia? A ring has more as compared to hollow sphere, as compared to disk, as compared to solid sphere. Now, guys, when it comes to the ring has moment of inertia mr square, 1 mr square. It has moment, solid sphere, 2 by 3 mr, hollow sphere, 2 by 3 mr. 2 by 3 means 0.6 mr square. It is less than 1. And disk has mr square by 2. What does that mean? 0.5 mr square. So the one which has more moment of inertia, more work needs to be done in that case. So work done in C is greater as compared to B as compared to A. This is the logic. And then this question. In this question, you have a pulley or a circular disc. And there is this mass connected to this. Okay. Now the question is, it says if the pulley rotates with an angular acceleration alpha, if this pulley is rotating with angular acceleration alpha, so this will also gain acceleration, but which acceleration? Linear, because it is moving linearly. Block is moving linearly, so it will have linear acceleration. This is rotating angularly, it will have angular acceleration. So this acceleration of the block is m into g upon m plus I divided by r square. Okay. This is actually net pulling force upon net mass. Let me show you why. See, because in Newton's laws of motion, I told you acceleration of this pulley system is net pulling force divided by net mass. Tell me, guys, what is the pulling force of this body? Mg. So I can write, sir, pulling force is mg. And if I write net mass over here, net mass I'm writing for this, I'm writing for this. So for this, in this particular case, it is m. For this, you write first moment of inertia. What is the moment of inertia of disk? M r square divided by 2 about this center of mass. And then divided by r square. This and this will cancel. So it is m by 2. M by 2 is also mass. So this term is also mass. So mass plus mass is net mass. I hope this is crystalline clear. Next part of this question is, take a look, guys. Take a look, guys. Next part of this question is, take a look. I'll make you understand. Let's suppose, I'll copy the same diagram. I'll copy the same diagram, but in this particular case, what I'm going to do is I'll attach one more block from this side. Okay. Okay. This is M2 and this is M1. Okay. Okay. Now, my dear friends, in this particular case, what I am going to tell you over here is, if the pulley rotates with an angular acceleration alpha. If the pulley rotates with an angular acceleration alpha, then the acceleration of the blocks will be, then the angular acceleration of the acceleration of the blocks will be, here M2 is greater than M1. So the question says, if the acceleration of this pulley, of this circular disc, whatever you call it, ring, whatever you call it, if you consider this ring, then moment of inertia will be according to the ring. If you consider this disc, then moment of inertia will be according to the disc. Okay. In this particular case, you have to tell me what is the acceleration of this block. Okay. What is the acceleration of this block? Just a second. Give me a second, guys. Huh? Just a second. Okay. Now, guys, so in this particular case, what do we say? We say this is the system. You have to tell me acceleration of the block in this particular case. See, guys, acceleration of the block. Yes. So I would just write over here. When I have to mention acceleration of the block, I would simply say M2 minus M1 into G. Then we say upon M1 plus M2. Then we say plus I divided by R square. Sir, again, I think this is net pulling force upon net mass. I'll show you why. See, guys. In this particular case, M2 is greater than M1. What is the force acting on M2 in the downward direction? M2G. What is the force acting on this? M1G. Which one is greater, M2G or M1G? Sir, M2G is greater than M1G because M2 is greater than M1. So net pulling force will be M2G minus M1G. Okay, bigger force minus smaller force. Okay, this is net pulling force upon net mass. Net mass will be, sir, mass of first plus mass of second block plus mass of the circular object. So for circular object in this particular case, my dear friends, we say I square divided by R. Let's suppose I am taking this as a disk. Sir, for disk, moment of inertia is mr square divided by 2 about the center of mass and divided by r square. This and this will cancel. So instead of this, you can write m divided by 2. Now m by 2 is also mass. m1 plus m2 is also mass. And this is net pulling force that I was saying. It is net pulling force upon net mass. I believe this is clear. I believe this is clear. Okay, I believe this is clear. Now guys, let's take a look. Let's take a look at the question. Let's take a look at the question. The question is, okay, the question is something like this. The question is something like this. In this particular case, there is this rope which is connected to this. This is mass M. This is another rope which is connected to this. This is mass M. This is M. This is M. This is height h. And this will have acceleration. This will have acceleration A. And this is given over here, solid sphere. This circular object depends what is given in the question. This is solid sphere. Okay, let me then make it a bit bigger. Or let's keep it like this only. And its radius is R. Okay, and mass is M. Mass is also M. Mass is M. Now, my dear NEET aspirants, you have to tell me in this particular case, find the acceleration of mass M. Find the acceleration of mass M. Also find the velocity if it is released. I'll write over here. Find the acceleration of mass M and also find its velocity if it is released from height h. If it is released from height h. Okay. Yes. See guys. In this particular case, when it comes to, see, this is the case one, this is the case one, this case one. If you have to find the acceleration over here, you say acceleration is simply mg upon m plus I divided by r square. Okay. Now you'll be like, sir, it is mg upon m plus. If this circular object is given as solid sphere, what is the moment of inertia of solid sphere about the center of mass? 2 by 5 mr square. So 2 divided by 5 mr square divided by r square. That's what I was saying, my dear NEET aspirants. R square and r square will cancel. So this is mg upon m plus 2m divided by 5. Okay. So I think in this particular case, you can cancel m and this m. All the 3m are same. So acceleration will come out to be 5 plus 2 is 7 by 5 to g upon 7 divided by 5. That is 5g divided by 7. Acceleration is 5g divided by 7. Now it says, guys, listen carefully. Now it says, what does it say? Find its velocity if it is released from height h. When something is released, okay. It is actually this block, okay? When this block is released from height h, and this block is released from height h. Okay, guys, this is the block. This is the block. So this is the block. When it is released from height h, this is not the another block, this is the same block. And it is released from height h. And I'll change it over here. When it is released from height h, initial velocity is 0. Final velocity here we need to find. So what will you say? You'll say, sir, v square minus u square is equal to 2as. Okay. When it is released from height h, you'll say, sir, v square minus initial velocity is 0. So this is 0 is equal to 2. Acceleration is 5g divided by 7 into s. Okay. And height, instead of s, I can write h. I can write h. V square will be, so v will be, take this root over here. 2 into 5 is 10. 10g divided by 7 into h. 10g divided by 7 into h. Okay, I hope this is also clear. Okay, yes. Okay. Let's move on to the concept of angular momentum. So I hope you got this particular question, guys. So if it is having acceleration alpha, so it goes down, let's suppose, okay, this is the mass. It goes down by height of h. First, you are supposed to find acceleration of the mass, then final velocity of the mass. Okay. Let's now move on to the angular momentum. Let's now move on to the angular momentum. What angular momentum is all about. Extremely important, angular momentum also. Okay. Yes. Yes. Listen, guys, very carefully. Listen, guys, very carefully. My dear NEET aspirants, what I want you guys to do over here is, that is very important. This concept is very important. Let's suppose you have a mass m. Okay. Yes, sir. And this is over here. Let's suppose point A. You are standing at point A. Standing at point A. And this is over here. Let's suppose point B. You are standing at point B. You are standing at point B. This is point A. This is point B. This is mass A. Now from point B, I can say you draw a line over here. Okay. This is point B. From point B, you draw a line over here. From point B, you draw a line over here. This is, let's suppose, radius r. And from point A, you draw a line over here. Okay. Now, my dear NEET aspirants, what I'm trying to say is that if you are standing at point B, with respect to the point B, and the body is, let's suppose, moving something like this, velocity v. First of all, with respect to the point A, can I say body is performing translational motion? Absolutely, body is moving straight with respect to point A. If you are standing at point A, you are looking at the body, it is going straight. So what I will mention over here, I would say with respect to point A, body is performing Translational motion. Translational motion. With respect to the point A, body is performing what? Translational motion. I can say it like that. I can say it like that. Absolutely, sir. Without a shadow of doubt. Now, my dear NEET aspirants, so this body is actually performing the translational motion with respect to the point A, and okay, so it will have it will have it will have linear momentum. Linear momentum. This is very important. And linear momentum is P is equal to mass into velocity. P is equal to mv. So if a body is performing translation motion, it has linear momentum. It depends upon the frame of reference. With some point, it can perform the rotational motion. With some point, it can perform the translational motion. It depends, bro. Yes. Now, if I write the statement over here, listen carefully. If I write a statement over here, with respect to the point B, it is moving angularly. Okay, how much angle? This angle. Let's suppose when it reaches here, now see guys, this much angle it has cut. When it reaches here, this much angle it has cut. So it is moving angularly with respect to the point B. So I can write with respect to point B, it moves angularly. So it has angular momentum. Oh, so angular momentum depends upon the point with respect to what you are talking about. If you are talking with respect to point A, it will have linear. If you are talking with respect to point B, it will have angular. I believe this point is clear. I believe this point is clear. Okay. I believe this point is clear. Now, my dear NEET aspirants, so it will have angular momentum. And that angular momentum we represent with L. And it will be MVR, and I would say sine of theta. MVR sine theta. MVR sine theta. M is mass, V is velocity, R is radius, and sine theta. Okay. I hope this is crystal and clear. And you can say, sir, this is L is equal to, take this mass out, RV sine theta. AB sine theta means A cross B. RV sine theta means R vector cross. Okay. I would say V vector. Okay. You can write it like this. Or my dear NEET aspirants, you can directly mention over here. You can directly mention over here something like this. That is R cross M into V. R cross M into V. Or you can directly mention you over here. It is better to write R M into V is momentum P, and then we say sine theta. So you can write this L will come out to be. This L will come out to be. This will be, that is R cross P. R cross P. Because AB sine theta is A cross B. Or you can say M into R cross V also. That is one and the same thing. So this is angular momentum. M into L is equal to M into R cross V. Or you can say L will be M into R cross V. RV sine theta. Where theta is the angle between R and V. Where theta is the angle between R and V. Where theta is the angle between R and V. Now guys, Listen to me very carefully. Let's suppose this is a mass over here. This is point, with respect to A, it is moving linearly. With respect to B, it is moving angularly. This is R and this is theta. This component will be R cos theta. This component will be R sin theta. R cos theta and R sin theta. Now, if this velocity, this is moving with a velocity V, my dear NEET aspirants. Now, if you check this component and this velocity, they are parallel to each other. So this component is not going to contribute to the angular momentum. Why? Because this is parallel. This will help the body to move parallelly. So which component of the R is going to contribute to angular momentum? That is R sin theta. Without a shadow of doubt, it is R sin theta. It is R sin theta. It is R sin theta. Okay. It is R sin theta. Now, my dear NEET aspirants, what I want you guys to understand in this particular case is, this is R sin theta, this is V, and this is R. This is R. So we say here cos component will not contribute to angular momentum. That's what I was saying. This cos will not contribute to angular momentum because it is parallel to velocity, because this cos component is parallel to velocity. In case of torque also, we took perpendicular component. So we take that component which is perpendicular to velocity. We take that component which is perpendicular to velocity. So perpendicular to velocity is R sin theta. Okay. So that's why we say L is equal to M V R perpendicular. Even you can also write it M R into V perpendicular. Means they must be perpendicular, then only angular momentum will be created. So simply you can say, sir, L is equal to mass is M, velocity is V. Which one will you take? R sin or R cos? R sin theta. That's I was saying over there directly. So L will be M into R vector cross V vector simply. So L will be equals to MVR sin theta. You can write it like this. I hope this is, and its unit is, what is the unit of mass kg? What is the unit of this meter per second? Okay. What is the unit of this meter? So meter square per second. It's the SI unit of this momentum. So this is the angular momentum of a mass about a point, Because this is moving angularly, so it has angular momentum. I can say it like this. I believe this is crystal clear to each and every single student. I believe this is crystal clear to each and every single student out there. Okay. Yes. Okay. Okay. Now let's talk about angular momentum of a purely rotating body. Angular momentum of a purely rotating body. Now guys, previous one was angular momentum of an object about a point. Angular momentum of an object about a point. Okay. Angular momentum of an object about a point. Okay. Angular momentum of an object about a point. But this time it is angular momentum of a purely rotating body. Angular momentum of a purely rotating body. Listen to me very carefully. Listen to me very carefully. When I say angular momentum of a purely rotating body, what does that mean? If there is a body over here, it is purely rotating. There is a difference between the previous case and this case. In previous case, I said angular momentum of a body about a point which was moving angularly, but this is purely rotation. This is purely rotation, my dear NEET aspirants, in this particular case. So when I say purely rotation, you can take a look. What is the value of angular momentum? MVR. So here it is mentioned in this particular case, it is mentioned V is equal to R omega, because we know relation between linear velocity and angular velocity. It is V is equal to R omega. And you can put this V over here. So L will be equals to M into R. Instead of V, you can write R into omega. R into omega. Now, R into R becomes R square. So it becomes M R square omega. Now, what is MR square? That is I. So L is equal to I into omega. What is L? I into omega, because M into R square becomes moment of inertia, that is I into omega. This is the angular momentum of a purely rotating body, I into omega. Okay, yes. Now, let's suppose take a look at this particular point. This is a rod. It is rotating about an axis which is passing through its center. Take a look at this. Yes, sir. So what is the moment of inertia of a rod about its center? ML square by 12. Here it is mentioned ML square by 12. Yes. So what is the value of angular momentum? Sir, L is equal to I omega. So instead of I, can I put ML square by 12? Yes. Into I am writing omega. This is angular momentum. Sir, what about this one? This mass. This mass is rotating about this axis, which is at r distance. What will be its moment of inertia? I is equal to mr square. So could you please tell me what is its angular momentum? Sir, angular momentum will be I into omega. Okay. And what is I? Mr square into omega. Okay. So here L is equal to I into omega. That is M R square omega. I hope this is crystal clear to each and every single student. Okay, let me show you the questions on this. Let me show you the questions on this. Wait, guys, I'm erasing these answers over here. Angular momentum and conservation of angular momentum is extremely important. Okay, let's take a look at the first question. See, guys, what does the question say? Take a look, my dear NEET aspirants. When it comes to this first question that we have over here, an object is projected with speed u. An object is projected with speed u. An object is projected with speed u. Okay, yes, absolutely, sir. An object is projected with speed u. Okay. At an angle theta. At an angle theta. You have launched an object with speed u at an angle theta. Okay. With the horizontal. With the horizontal. Then find the angular momentum when the object is at the maximum height with respect to the point of projection. Take a look at the diagram. You have launched the object from this point with velocity u. It goes, and it reaches the top. When it is at the maximum height with respect to the projection means this point of projection from which you have launched it. What is its angular momentum? Listen, guys, very carefully. Listen carefully. If you launch an object with certain velocity, let's suppose u, at an angle theta, velocity will have two components, u cos theta, okay, and this component will be u sin theta. Always remember, in case of projectile motion, at topmost point, this vertical component uy, at topmost point, this vertical component becomes zero. Obviously, then only it will start falling down back. But when it comes to the horizontal component, it remains same at every point. It does not change. U cos theta, here also u cos theta, here also u cos theta. At this point, u cos theta, u cos theta, u cos theta, u cos theta. So if at topmost point vertical velocity is zero, there is only one velocity, that is u cos theta, horizontal. And this is what we call the maximum height. At topmost point, this is known as maximum height. And from the point of projection, this is the distance. This is the radius r from the point of projection. This is the distance. Okay? Yes. Now, my dear NEET aspirants, what I'm trying to say in this particular case is you have to find angular momentum. How do you find angular momentum? Tell me, what is the formula? Sir, angular momentum is mvr, then we say sine of theta. mvr sine theta. mvr sine theta. Absolutely, sir, without a shadow of doubt. Now, what is the mass in this particular case? M. What is the velocity at topmost point? V cos theta. 100%, sir, because Vy is 0, only one velocity, V cos theta. And what is R? Sir, this is R. Okay. And this will be horizontal component, this will be vertical. Now, this is the perpendicular component. And in this particular case, guys, we can say velocity is u cos theta. There is no doubt and denial in that. Okay. And when it comes to R perpendicular will be H maximum. H maximum is R perpendicular. H maximum is R perpendicular. Okay. Yes, sir. H maximum is R perpendicular. Then, my dear NEET aspirants, I want you to understand this. H maximum is R perpendicular and H maximum is u square sine square of theta divided by 2g. U square sine square of theta divided by 2g. And sine theta, this theta is the angle between, it is not this theta, my dear NEET aspirant. This theta is the angle between velocity and R perpendicular, that is 90. Call it theta dash. So L will be equals to mass is m, velocity is u cos theta, r perpendicular is u square sine square of theta divided by 2g. And this sine theta dash, it is sine of 90. Because you are taking here perpendicular component, then obviously angle will be 90. L will be m, u into u becomes u cube. Then we say sine square of theta cos of theta divided by 2g. This is the angular momentum. This is the angular momentum in this case. This is the angular momentum. Now guys, take a look at this. An object is projected with speed u at an angle theta. An object is projected with speed u at an angle theta with the horizontal. Find the angular momentum when the object hits the ground. When the object hits the ground. The object hits the ground. With respect to the point of projection. See. Take a look, my dear NEET aspirant. Now guys, take a look in this particular case. Take a look. An object is launched with velocity u at an angle theta. It performs projectile motion, it reaches here. And this is the velocity v. This is called velocity of hit. With what velocity it will hit the surface once again. Now this is v. This component will be over here and this is theta. Okay. If it is making theta with the horizontal here, here also with the horizontal will be making theta. Now guys, this component will be v cos theta. This will be v sin theta. Finally, in this particular case, we have to say what is the angular momentum of this projectile at this instant. You'll be saying, sir, listen to me very carefully, my dear NEET aspirants. This is the point of projection. So this is going to be R in this particular case. If you say what is R, this is R. Join the point of projection to that point, that is the R. That's the value of R. Absolutely, sir. This is the value of R, sir. Yes, sir. Now, which component of velocity you will prefer to take? Sir, since this is parallel to R, this V cos, and V sin is perpendicular to R. So V sin is perpendicular to R. So my dear NEET aspirants, V sin theta is perpendicular to R. So I can say in this particular case, I want you to understand this very carefully. I can say in this particular case, when I write angular momentum, it is M. Okay. It is V R sine of theta. So L is equal to M. Mass is M. Velocity, which component you will take? V sine theta or V cos theta? V sine theta or V cos theta? Sir, Vx will remain same. Okay. 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 Yes. And one more important thing, my dear NEET aspirants. In case of projectile motion, if you are launching it with velocity 10 meter per second, it will smash the surface with 10 meter per second. Velocity of projection is equal to velocity of hit. Okay. And one more important thing, my dear NEET aspirants. We say, sir, if this horizontal component is u cos theta, this will remain the same u cos theta. Vertical component is u sin theta, it will be u sin theta. So it is m u sin theta, perpendicular component. And that is r. R is this, R is this. What is R? What is this R called? This R is what we call range. A range of a projectile, how far it can go. So instead of R, I'll write over here range. And then sine of 90. This angle is 90. Sir, which angle is this? I'm confused. This is the angle between R and V. What is V over here that you are considering? This, and this is R, that is 90. Consider theta dash. And sir, what is this theta? This is the theta angle of projection. So L is equal to M u sine theta. We say R u sine of theta. And what is the range of this projectile? R is equal to u cos theta into t. You can write it like this. Okay, and when it comes to the range, what is the range of a projectile? U square 2 sine of theta divided by g. U square 2 sine theta by g. So L is equal to M u sine theta, and then instead of range, u square 2 sine theta divided by g. So L will come out to be, take u square into u is u cube, 2 m u cube sine of square of theta divided by g. I think this must be the answer. This must be the answer. Okay, there is another question which was asked in JEE Mains 2025 from the same pattern. Let's move on to this question, guys. Let's move on to this question. This question. An object of mass m is projected from the origin, in a vertical xy plane at an angle theta, at an angle of 45. Take a look. Okay. An object is launched of mass m with velocity v naught at an angle of 45. At an angle of 45. So it goes till here and smashes this. It says, the question says, an object of mass m is projected from the origin in xy plane at an angle of 45 degrees. Okay, angle of projection is 45 with the x-axis. Initial value velocity is v naught. Initial. The angular momentum with respect to the origin as it reaches the maximum height. Okay. When it reaches the maximum height, what is the angular momentum? Guys, see, at maximum height, I recently told you this is going to be the value of r. This you will be considering the value of r. This is r. This is r. Now, guys, if this is r, and one more important thing, if this is velocity v naught, this component will be v naught cos 45. This component will be V naught sine 45. At topmost point, my dear NEET aspirants, this velocity is V naught cos 45 and it is constant. It does not change, it remains the same. And vertical velocity is 0. Vertical velocity is 0. Now, my dear NEET aspirants, this is V naught cos 45. This is R perpendicular. This is H max. This is H max. Okay. Okay, this is H max. What I want you guys to do in this particular cases, everybody out there, see guys, if this is R, this is R perpendicular and that is H max. I have recently told you, my dear NEET aspirants, when it comes to the angular momentum here, that is MVR sine of theta dash. Theta dash is the angle between R and V. So L is equal to M is mass. What is the velocity at topmost point? V naught cos 45. Because at topmost point, vertical component is 0. There is only horizontal component. So we'll be mentioning V naught cos 45. And R. And R. What is the value of R? R is, if you are considering this velocity, then you have to consider this horizontal component of R. Vertical. That is H max. R perpendicular. What is H max? U square sine square 45 divided by 2g. You will be writing it like this. Okay. And U square will be V naught square. And then sine of 90. Because angle between R perpendicular and V and velocity is 90. So L is equal to M V naught cos 45 is root 2, 1 divided by root 2. Then this is V naught divided by 2g. Sine square of 45, that is 1 divided by 2. Sine 45 is 1 by root 2. Sine 45 is 1 by root 2. Okay. Sine 45 is 1 by root 2. So if you do the square, it will become 1 divided by 2. 1 divided by 2. And sine 90 is 1. This is 1. So 2 into 2 is 4. L is equal to M V naught square divided by 2 into 2 is 4. So 4 under root 2 and this is G. I think this has to be the answer. This is the angular momentum in this case. Let's take a look at this question. Just a second, pencil is charging. Now, guys, let's take a look in this particular case. There's a question from J Mains 2024. See what does the question say. A particle of mass 5 kg is moving with a uniform speed v is equal to 3 root 2 meter per second in XOY plane. Okay, in XY plane it says. Along the line y is equal to x plus 4. Let me make the plane over here first. See, this is y axis and this is x axis. This is y axis and this x axis. Now guys, take a look. If I say equation is given as y is equal to x plus 4, first analyze this equation. You compare it with y is equal to mx plus c. mx plus c. This is the equation of straight line. This is the equation of straight line. In this case, we can say c is 4, y is y, c is 4, m is 1. Here it is 1. And m is 1. What does C mean? C means intercept, where it is cutting the y-axis, where the graph is cutting the y-axis. And C intercept in this case is positive, means graph, it is cutting the y-axis from the upper side. And the slope in this particular case is constant because 1 is constant and positive. Now you have to plot this. You have to plot this in this particular case. Guys, see. I would say it has to be something like this. It has to be something like this. Okay. So where it is cutting the y-axis, so C is equal to 4. And this angle over here must be 45 degrees. Why? M means slope. This is slope. We can say, when is the value of slope as 1? Guys, when is the value of slope as 1? When theta is 45. So we say it is tan 45. Slope is tan theta. When the value of theta is 45, slope will be 1. So angle will be 45. And here it is cutting the y-axis. And you can clearly say theta is less than 90. When theta is less than 90, slope is positive. You cannot say the graph would be something like this. Why? Because here slope of this would be negative. Absolutely, sir. So in this particular case, what we got to see, value of r in this case is 4. Okay, this is origin. With respect to the origin, this is distance is how much? That is 4. Now in this particular case, at this point it says a particle is moving with a 5 kg mass is moving with uniform speed. Means what is the speed of this object at this point? That is 3 root 2. V is 3 root 2. And this angle would be also 45. This would be also 45. So this component will be V cos 45. And along this will be V sin 45. V sin 45. V cos 45 and V sin 45. Okay. Now guys, if you have to find the angle, then it says the magnitude of the angular momentum of the particle about origin is. What is the angular momentum of the particle? See guys, angular momentum is mvr sine theta. Take a look. In this particular case, my dear NEET aspirants, if the particle is here, with respect to the origin, it is saying, this is origin, this is r. Which component of velocity you will prefer? V sine or V cos? Obviously V cos, because that is perpendicular to r. So we'll prefer this. So L is equal to M. This will be V cos 45. And this is R and angle is sine 90. Why, sir? Why, sir? Because this angle is 90. So L will be M. V cos 45. Cos 45 is 1 divided by root 2. And then R. Sin 90 is 1. L is equal to MVR. I hope this is crystal and clear, boys and girls. This question is already done. Okay. What about this? Solid sphere is rotating with an angular speed omega. Find now, guys, take a look. Take a look. Solid sphere is rotating with an angular velocity omega. Find the angular momentum about the given axis. Okay. This is a solid sphere. What is the moment of inertia of the solid sphere about the axis which is passing through the center? 2 by 5 mr square. So what is the angular momentum? Angular momentum is I into omega. It is a purely rotating body. So 2 divided by 5 mr square into omega. What about this axis? Angular momentum about this axis is 7 by 5 mr square. So L is equal to I omega. L is equal to 7 by 5 mr square into omega. I hope this is crystal clear to each and every single student. This is what we have. This is what we are done with already. No, 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 no. This is conservation of angular momentum. We have to study conservation of angular momentum. This is conservation of angular momentum. Okay. Yes. conservation of angular momentum. Let's dive into this. Now take a look, my dear NEET aspirants. Conservation of angular momentum. Conservation of angular momentum. See guys, when it comes to the conservation of angular momentum, before conservation of angular momentum, let's understand the conservation of momentum. We say, as we know, I have told you previously, if net force on a body is zero, if net force on a body is zero, then we say F net is equal to dp divided by dt. Newton's second law, that is dp divided by dt. Sir, example in which case net force is zero? When a bomb explodes into two different fragments. Over there, net external force is zero. Sir, bomb explodes because of the internal forces. Or when collision takes place, when one ball collides with another ball, here the two balls apply force on each other. That is internal force. So external force here also is zero. So when net external force on the system is zero, on a body is zero, we say this is zero. So dp divided by dt. Take this over here. So dp will be zero. What is dp? dp means change in momentum is zero. So means momentum is not changing. When net external force on the system is zero, so we say momentum will not change. Momentum remains same. So we say P is conserved. Okay. That means initial momentum is equal to final momentum. Initial momentum is equal to final momentum. Now guys, so whatever is the initial momentum of the body initially, finally will be the same. Okay, like this is a bomb. Okay, this bomb breaks into two small fragments. So whatever is the initial momentum of the bomb, okay, that is zero. Finally also, these two fragments have net momentum zero. This will have in the backward direction, this will have in the forward direction. So net cancel, it will be zero. This is what we have studied previously. Now let's come on to the angular momentum. We say here in rotation, what do we actually say? We say if net torque on the system is zero. We say net torque on the system is zero. We say now net is equal to dl divided by dt. If net torque on the system is zero, put it zero over here. So it is going to be dl divided by dt. Now take it over here. dl will be zero. Okay. dl will be zero means angular momentum is conserved. Angular momentum is conserved. Angular momentum is conserved means final angular momentum is equal to initial angular momentum. Okay. So whatever is the angular momentum finally, that will be the initial momentum, initial angular momentum initially. So if net external torque acting on the system is 0, then angular momentum of the system, angular momentum of the system is conserved. This is called conservation of angular momentum. This is called conservation of angular momentum. Okay. Okay. Let's suppose I'll give you an example over here. See guys, I have got a sphere over here. I have got a sphere over here. Okay. And this sphere is rotating about this axis. It is rotating about this axis. It is rotating about this axis. The sphere, it is rotating about this axis. Okay. If it is rotating about the axis with angular momentum, what? Omega. If it is rotating about the axis with angular momentum omega. Okay. Now this is this is Earth, you can consider. Let's suppose this is Earth. And this is pole. This is what we call pole. It's if you keep the snow on the poles, just a second guys. How do I keep snow here? Okay, let me make the snow with this only. This is the snow on the poles. Okay, this is the snow. This is the snow. Okay. Okay. Now, my dear NEET aspirants, what I'm trying to say is that if on the pole snow is there, let's suppose if I say if snow melts, if snow melts at the pole, if snow melts at the pole, it starts, we say, falling down, or snow gets decreased. Okay. It starts falling down from the axis. It starts falling down away from the axis. It starts falling down away from the axis of rotation. Axis of rotation. Okay. Now, my dear NEET aspirants, what I can say in this particular case, in this case, When when snow melts, understand this is a very good question. When snow melts, it starts falling away from the axis of rotation. We say when the mass goes away from axis of rotation, moment of inertia will increase. So moment of inertia increases. More mass is away from the axis of rotation, more is the moment of inertia. And here, my dear friends, here we say net external torque is zero. No torque is acting on the snow or something. So we say angular momentum over here is constant, conserved. So we say L is equal to I omega. Angular momentum has to remain conserved. Listen to me very carefully. This is very important. Okay. Angular momentum has to remain conserved. Okay. And moment of inertia is increasing. If moment of inertia is increasing, what should happen to the angular velocity? We say, sir, angular velocity in this particular case, omega should decrease. Because let's suppose previously its value was 10, its value was 5. 10 into 5 is 15. So angular momentum must remain 15. So now, my dear NEET aspirants, if I say this is increasing, it is becoming 15. Okay. So how much should this become so that it remains 15 only? Sir, 1. 15 into 1 is 15. So we say angular velocity must decrease. Okay. So omega must decrease. So omega must decrease. Okay, so I'll just write over here omega must decrease. Then only L remains conserved. Okay, this is conservation of angular momentum. Now we have certain questions in this particular case. Okay, guys, let's do one thing. Let's take a break for 5 more minutes. Okay, 5-10 minutes. Then we'll get back. Now, guys, let's move on to this question. Okay. See, a thin, this is a J Mains 2024 question. A thin circular disk of mass m, okay, a radius r, is there is a thin circular disk of mass m and radius r, is rotating about an axis. It is rotating about this axis. Okay, it is rotating about an axis. Passing through its center. This axis is passing through its center. It is passing through its center. With omega. With what angular velocity? Omega. If another disk of mass m by 2, if another disk of mass m by 2, that is this disk, its mass is m by 2, is placed gently onto this disk, is placed gently on the first disk, is placed gently on the first disk. Okay, I have made it over here. It should have been here. Okay. Then the new angular velocity of the system is, okay. What if we place the, now guys see, listen to me very carefully. If mass of this disk is m, okay, and mass of this disk is m by 2. So you say, sir, if its moment of inertia is I, its moment of inertia will be I by 2. If its moment of inertia is I and its moment of inertia will be I by 2. Okay. Now, can you tell me in this particular case, it says when you place the second disk on the first disk, what will happen to the angular velocity? What is the new angular velocity? We say here, here, here. We say net torque is 0. Here net torque is 0. Net torque is 0 means angular momentum is conserved. Net external torque is 0. No external torque is acting on this. Okay. That means initial angular momentum is equal to final angular momentum. What is initial angular momentum? That is moment of inertia initially, okay, into omega, I into omega. Initially there was only one disk. Initially there was only one disk. And then, my dear friends, if I say finally there are two disks. So can I say final angular momentum will be, initial angular momentum is I, and first disk has a moment of inertia I, and second disk had moment of inertia I by 2. So 2I plus, so this is going to be 3I by 2. So this will be 3I divided by 2 into omega dash, into omega dash. Now here I and I will be cancelled. So this will be 2 omega divided by 3 will come out to be omega dash. You can write it like this. Simple. Or you can mention over here, sir, I want to mention the angular momentum. I want to mention the moment of inertia of this. So it is mr square divided by 2. Right, mr square by 2. What is the moment of inertia finally? That will be mr square divided by 2, because this disk, plus mr square divided by 2 into this 2, that is mr square by 4, because its mass is m by. So solve this, it will again come out to be the same. Let's suppose you have this question. let's suppose you have this question. Let me show you this question properly. This is from 2010. Take a look, guys. In this particular case, a circular ring of mass m and radius r is rotating about its axis with constant angular velocity omega. There is a ring, my dear NEET aspirants. Let me show you that ring. There is a ring. There is a ring. This is a ring. Okay. And this ring is rotating this ring is rotating, okay, and it is rotating about with angular velocity omega, okay, and its mass is m and radius is r. Two particles of mass m are attached gently. Two particles of mass m are attached gently to the opposite ends of the diameter. To the opposite ends of the diameter. See, what do we do afterwards? This is what we are doing over here. I am attaching one more mass over here. The two masses. This is m and this is m. Gently on the opposite ends. Gently on the opposite ends of the ring. The angular velocity of the ring now will be, we have to find finally what will be the angular velocity if you do, because angular velocity will change. Okay. Now, my dear NEET aspirants, I want you to understand this. See, in this particular case, we say angular momentum is conserved, constant, because net external torque is zero. Net external torque is zero. Sir, I don't think in this particular question net external torque is zero, because when you are attaching the mass, sir, okay, so due to this mass we say mg will be downwards. Due to this mass mg will be downwards, sir, about, and this is r, this is r, this is r. So due to this mg there will be torque created. Obviously there will be torque created. Okay, tell me what is the torque in this particular case. So that will be torque. Let's talk about this tau 1. Here it is tau 2. So tau 1 will be rf sine theta. So r is mg. Sorry, r is r. Force is mg, and this is mgr. Then we say sine of 90, because angle between r and mg is 90. So it is mgr. Now, could you please tell me what is the direction of this torque about this axis? It will basically create torque in the anti-clockwise direction. This is ACW. Similarly, tau 2 will be mg into r. It will be also clockwise. 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 Okay. Now, my dear NEET aspirants, so net torque will be zero. One is anti-clockwise, another is clockwise. Net torque in this particular case will be zero. So I can say, if net torque is zero, angular momentum is constant, initial angular momentum will be equals to final angular momentum. Okay. And tau due to mg will cancel out with each other. Okay. Write this. Torque due to mg will cancel out with each other. Okay. Now, initial angular momentum is I into omega. Final angular momentum is I dash into omega dash. What is initially angular? What is initially moment of inertia? That is just the ring, mr square. M into r square. Initially angular velocity is omega. Finally, you have got a ring plus mass plus mass. So you have two masses. For two masses, what is the moment of inertia? 2 mr square. Because for this mass about axis of rotation, mr square. For this mass about axis of rotation, mr square. Okay. Then plus, we say mr square. Into, I would say omega dash. So what I can say, omega dash will be m. Do one thing, my dear NEET aspirants. What I can say, this is r square, r square, r square. So this is m. Okay. This is m into omega upon, I can say 2m plus this m. This will be the final angular velocity. This will be the final angular velocity. This is the question which we already did. Already done. See, what does it say? A round disk of moment of inertia I2 about an axis perpendicular to its plane. Okay. And passing through its center is placed on another disk. Okay. This I2 is placed on another disk of moment of inertia I1. Okay. Rotating with omega. So basically this was I1 initially. There is this disk. This disk. It is rotating with omega. Its moment of inertia is I1. Finally, what we do, we place another disk I2 onto this I1. Okay, onto this I1. It says that the final angular velocity of the combination is, what is the velocity of this combination? So velocity of this combination is omega dash. Velocity of this combination is omega dash. Okay. So my dear NEET aspirants, initial is equal to final. Initially, angular moment of inertia is I1. This is omega. Finally, it is I1 plus, I would say, I2 into omega dash. If I say omega dash will be I1 into omega upon I1 plus I2. This one. Let's talk about this, guys. This is an important question. I would want you guys to understand this very carefully. Everybody out there. See, I'll make you this understand. Let's take a look at this question. See, guys, And this is from NEET 2017. Lot of questions have been asked from this topic. Two disks of same moment of inertia. You have got two disks, their moment of inertia is exactly same. Okay. Two disks of same moment of inertia. Rotating about their regular axes, passing through the center of mass perpendicular to the plane of disk with angular velocity omega 1 and omega 2. Listen to me very carefully. You are given a disk over here. There's a disk and there is one more disk. Okay. They are rotating about this axis. They are rotating about this axis. Now guys, this is rotating with omega 1. This is rotating with omega 2. This is rotating with omega 2. Now, my dear NEET aspirants, in this particular case, they are rotating. Okay. Then it says that they are brought in contact. They are brought in contact. See this? Face to face, coinciding the axis of rotation. The expression for loss in energy during the process is now guys, what does the question say? The question says that these two disks are brought in contact. Okay, means they are colliding with each other. You can understand it like that. These two disks are colliding with each other. These two disks are colliding with each other. Let me just show you how. This, it is colliding with this disk, something like this. They are colliding with each other. Okay, that's what we say brought in contact. We say in this particular case, how much will be the loss in the energy? Guys. In collisions, we have studied in case of elastic collision, in case of perfectly inelastic collision. Okay. In case of perfectly inelastic collision, in that particular case, what was the loss in kinetic energy? In case of perfectly inelastic collision, loss in kinetic energy, that was delta Ke is equal to 1 by 2 m1 m2 upon m1 plus m2 v relative square. So this was the loss in kinetic energy in case of perfectly inelastic collision. Now guys, see, the two disks, they are moving with rotating with angular velocity omega 1 and omega 2. Okay, they are brought in contact face to face. When they are brought in contact face to face, coinciding the axis of rotation. Now it does not say that they are again brought back to the original position. So means that they will stick to each other. So in this particular case, we have to find loss in kinetic energy. So this is called, it is that collision when one object is colliding with another object and they stick together afterwards and they move together. This is perfectly inelastic collision. In elastic, they again regain their shape, size, everything. But in case of perfectly inelastic, this is what we call the loss in kinetic energy. Now guys, this is over there when the two objects were doing translation motion, but here the case is rotation. So we say here the same formula we are going to make. In case of rotation, we say loss in kinetic energy is going to be 1 divided by 2. Guys. Here it is m1, m2. Instead of mass, what do we write in rotational motion? Moment of inertia. I1, I2, I1, I2. And instead of velocity, we write omega relative angular velocity square. So what I'll be mentioning over here, I1, I2 upon I1 plus I2. And then we say omega relative square. Then we say omega relative square. Okay, absolutely, sir. Now, omega relative, you can say omega 1 minus omega 2. So delta Ke is equal to 1 by 2. Guys, these are the similar disks. So if the moment of inertia of this is I, for this is I, so you can say I into I becomes I square. I plus I is 2I. So omega relative is omega 1 minus omega 2. It's square. So now this and this will cancel. So this will become I divided by 4. Then we say omega 1 minus omega 2, its whole square. This is change in kinetic energy. This is and this is loss. Loss in kinetic energy. We'll be directly remembering in this particular case, this particular formula, which I have told you over here. Like, there is a question on the similar concept. On the similar concept. Let me show you this. See guys, what does the question say? Two disks of moment of inertia, I1 is 4 kg meter square and second disk have 2 kg meter square. About their central axes, rotating with angular speeds 10 and 4. You have two disks, this one and this one. They are rotating with angular speed 4 and 10. Okay. They are brought in contact face to face. Okay. The loss in the kinetic energy of the system is J mains 2024. See guys. In this particular case, it says what is the moment of inertia of first one? 4. What is the moment of inertia of second one? 2. What is the angular velocity of first one? 10. What is the angular velocity of second one? That is 4. That is 4. Now you have to, when they are brought in contact, you have to tell me loss in kinetic energy. Okay. Because we know it is a perfectly inelastic collision. So we say as loss in kinetic energy. Loss in kinetic energy. How will you write loss in kinetic energy? You say, sir, loss in kinetic energy will be 1 by 2. Recently, I told you I1, I2 upon I1 plus I2 into omega relative square. So loss in kinetic energy will be 1 divided by 2. I1, I2. I1 is 4, I2 is 2. See, moment of inertia of first one is 4, second one is 2. Okay, divided by 4 plus 2. Then omega 1 minus omega 2. This is omega 1 minus omega 2. Omega 1 is how much? 10 minus 4 its square. So 1 divided by 2, because omega relative is omega 1 minus omega 2. 1 by 2, 4 into is 8 divided by 6. 10 minus 4 is 6 square is 36. 6 ones are 6 are 36. 2 ones are 2 threes are 6. 8 into 3 is 24 joules. This will be delta Ke loss. I hope everybody is I hope everything is crystalline clear. I hope everything is crystalline clear. Okay. Now guys, there is a question over here. see the question. Now, guys, let's take a look. The question is, this is the question from JEE Mains 2024. If the radius of Earth is reduced to 3/4 of its initial present value without change in its mass, then the value of duration of the day of Earth will be. Then the value of duration of, if the radius of Earth is reduced to 3/4 of its initial present value without change in its mass, then the value of duration of the day of the Earth will be. Okay, so it is saying that if we reduce the radius of Earth to 3/4 of its initial value, okay, of its initial present value without change in its mass must remain the same, then the value of duration of the day will be, okay, duration of the day will be, okay, that's cool. Now, my dear NEET aspirants, what does it say? It says finally the radius r dash must be 3/4r, 3/4 of its present value. Okay. Now, my dear NEET aspirants, if we are talking about the Earth is a solid sphere. Okay, Earth means solid sphere. So for solid sphere, moment of inertia we say 2/5 mr square. Absolutely, yes. So what I want you guys to do in this particular case is, I can say as, when it comes to final moment of inertia, understand this very carefully. When it comes to final moment of inertia, you say, sir, final moment of inertia in this particular case is going to be 2/5 m. It says mass of the Earth must remain the same. Radius must become 3/4r. So it is 3/4r its whole square. So this will be 2 divided by 5. Okay. M, and this will be r square, and 3 square is 9 divided by 16. This is final value. So I final in this particular case will be 9 divided by 16 of I initial. This will happen to the moment of inertia. If it says you decrease the radius of the earth to 3-4 times, 3 by 4 r, 3 by 4 of its present value, mass must remain the same. Then what will happen to the moment of inertia? We calculated that. Okay. And my dear NEET aspirants, listen to me very carefully. What is the initial angular speed? Angular speed is theta divided by time. Okay. Theta divided by time. Theta is the angular displacement upon time. Now guys, if Earth completes one revolution, let's suppose, how much angle it is going to cover? 360. 360 means 2 pi divided by, and how much time currently it is taking in completing one cycle? That is 24 hours. 24 hours. Okay. Okay. And finally, I would say omega final. Just a second, guys. Just a second, guys. It is charging this pencil. Now, guys, take a look. So we say omega final I can write over here. That will be 2 pi divided by t. Finally, let's see how much time. This time we are supposed to calculate now. So initially, right now, how much time it is taking? 24 hours in one cycle. Duration of the day. This is 2 pi divided by t. Now tell me, in this particular scenario, everybody of you, tell me one thing. Tell me, my dear NEET aspirants, is there any net external torque acting? No, sir. Nothing. It is not mentioning anything. So net external torque is 0. So can I say angular momentum initial will be angular momentum final because it remains conserved? So it is I initial into omega initial is equal to I final into omega final. I can write it like this. Okay. Now initial moment of inertia. Initially moment of inertia, that is 2 divided by 5 mr square. Okay. Initial angular velocity. Okay. 2 pi divided by 24. Okay. What I can write over here? 2 pi divided by 24. Okay. Okay. Or instead of this, guys, I initial, you kept I initial only. I final, you write this much. So better is to do this only. So initial moment of inertia is I. Okay, this is initial angular velocity. Final angular moment of inertia mentioned over here. Oh, this one. So this is 9 by 16 I. And final time is t. That's what we are supposed to find out. Okay. Oh, sorry. Final angular velocity is 2 pi divided by t. Yes, this one. Now tell me, what can we cancel in this particular case? 2 pi, 2 pi. I. Okay. So this will be 16 divided by 24 into 9. 16 divided by, wait, this will be 1 divided by 24, and this will be 9 divided by 16 into t. Take this t over here. This will be 9 into 24 divided by 16. This will be the answer. So this will be 54. Okay, if I cancel this, 2 8s are, 2 12s are, 2 4s are, 2 6s are, 2 2s are, 2 3s are. 3 into 9 is 54, divided by, I would say, 2. 2 4s are 50. Wait. 9 into 24 divided by 16. Directly right over here. This will be 13.5 hours. Okay, do the cancellation. 4 4s are 16, 4 6s are. 9 into 6 is 54, divided by 4, 13.5. Yes. I believe this is crystal clear. This question was also a good question. It was having a very... The question is, this is the question from JEE Mains 2024. If the radius of Earth is reduced to 3/4 of its initial present value, without change in its mass, then the value of duration of the day of Earth will be. Then the value of duration of, if the radius of Earth is reduced to 3/4 of its initial present value without change in its mass, then the value of duration of the day of the Earth will be. Okay, so it is saying that if we reduce the radius of Earth to 3/4 of its initial value, okay, of its initial present value, without change in its mass must remain the same, then the value of duration of the day will be, okay, duration of the day will be, okay, that's cool. Now, my dear NEET aspirants, what does it say? It says, finally, the radius r dash must be 3/4 r, 3/4 of its present value. Okay. Now, my dear NEET aspirants, if we are talking about the Earth is a solid sphere. Okay, Earth means solid sphere. So for solid sphere, moment of inertia, we say 2/5 mr square. Absolutely, yes. So what I want you guys to do in this particular case is, I can say as, when it comes to final moment of inertia, understand this very carefully. When it comes to final moment of inertia, you say, sir, final moment of inertia in this particular case is going to be 2 divided by 5 m. It says mass of the Earth must remain the same. Radius must become 3/4 r. So it is 3 divided by 4 r its whole square. So this will be 2 divided by 5, okay, m, and this will be r square, and 3 square is 9 divided by 16. This is final value. So I final in this particular case will be 9 divided by 16 of I initial. This will happen to the moment of inertia. If it says you decrease the radius of the earth to 3-4 times, 3 by 4 r, 3 by 4 of its present value, mass must remain the same. Then what will happen to the moment of inertia? We calculated that. Okay. And my dear NEET aspirants, listen to me very carefully. What is the initial angular speed? Angular speed is theta divided by time. Okay. Theta divided by time. Theta is the angular displacement upon time. Now guys, if Earth completes one revolution, let's suppose, how much angle it is going to cover? 360. 360 means 2 pi divided by. And how much time currently it is taking in completing one cycle? That is 24 hours. 24 hours. Okay. Okay. And finally, I would say omega final. Just a second, guys. Just a second, guys. It is charging this pencil. Now, guys, take a look. So we say omega final I can write over here. That will be 2 pi divided by t. Finally, let's see how much time. This time we are supposed to calculate now. So initially, right now, how much time it is taking? 24 hours in one cycle. Duration of the day. This is 2 pi divided by t. Now tell me, in this particular scenario, everybody of you, tell me one thing. Tell me one thing. Tell me, my dear NEET aspirants, is there any net external torque acting? No, sir. Nothing. It is not mentioning anything. So net external torque is 0. So can I say angular momentum initial will be angular momentum final because it remains conserved? So it is I initial into omega initial is equal to I final into omega final. I can write it like this. Okay. Now initial moment of inertia. Initially moment of inertia. That is 2 divided by 5 mr square. Okay. Initial angular velocity. Okay. 2 pi divided by 24. Okay. What I can write over here? 2 pi divided by 24. Okay. Okay. Or instead of this, guys, I initial, you kept I initial only. I final, you write this much. So better is to do this only. So initial moment of inertia is I. Okay, this is initial angular velocity. Final angular moment of inertia mentioned over here. Oh, this one. So this is 9 by 16 I. And final time is t. That's what we are supposed to find out. Okay. Oh, sorry. Final angular velocity is 2 pi divided by t. Yes, this one. Now tell me, what can we cancel in this particular case? 2 pi, 2 pi. I. Okay. So this will be 16 divided by 24 into 9. 16 divided by, wait. This will be 1 divided by 24 and this will be 9 divided by 16 into t. Take this t over here. This will be 9 into 24 divided by 16. This will be the answer. So this will be 54. Okay. If I cancel this, 2 8s are 2 12s are, 2 4s are, 2 6 are, 2 2s are, 2 3s are. 3 into 9 is 54, divided by, I would say, 2. 2 4s are 50. Wait. 9 into 24 divided by 16. Directly right over here. This will be 13.5 hours. Okay, do the cancellation. Huh? 4 4s are 16, 4 6s are. 9 into 6 is 54, divided by 4, 13.5. Yes. I believe this is crystal clear. This question was also a good question. It was having a very good level, I must say. Okay, let's move on to this question, guys. Let's take a look at this question. See, the question over here is, see, the question over here is, a mass m moves in a circle. A mass m moves in a circle on a smooth horizontal plane. On a smooth horizontal plane. On a smooth horizontal plane. With velocity v naught. With velocity v naught. At a radius r r naught is given. Okay, the mass is attached to a string which passes through a smooth hole. The mass is attached to a string which passes through a smooth hole. Okay, which passes through a smooth hole, as shown. As shown. Okay, the tension in the string is increased. This is a very good question, actually, guys. The tension in the string, the tension in the string is increased. The tension in the string is increased. And mass m is moved to r naught divided by 2. radius. Radius. The final value of the final value of kinetic energy is the final value of kinetic energy is the final value of kinetic energy is okay. Let me make the diagram. Okay, let me just make the diagram. You will get the proper feel. Okay. Okay. This is the mass M. This is the mass M. Let's suppose this is the velocity and this is at r naught radius and this is the string. Now guys see, and this is placed on the table, let's suppose. I made a beautiful diagram, huh? Yo. Now guys take a look. A mass M moves in a circle. A mass M moves in a circle. Okay. A mass M moves in a circle on a smooth horizontal plane. Mass M moves in a circle on a smooth horizontal plane in this circle with a velocity v naught. Okay, velocity is also given. V naught. At radius r naught. At radius r naught. The mass is attached to a string. This mass is attached to a string. Okay, rope. Okay. Okay, which passes through a smooth hole, as shown. It passes through a smooth hole as shown. The tension in the string is increased, so you are pulling. Okay, the tension in the string is increased. You are pulling the string. Let's suppose tension is increasing by any means, and mass M is moved to r naught by 2. This mass M, see, if you pull the string, see guys, if you pull the string down, this mass M will be moved till here at what? R naught divided by 2. That's what it is saying. So mass M will reach here at R naught by 2. Okay, the radius. The final value of kinetic energy will be, finally its kinetic energy will be, final value of kinetic energy. This is the question. Now guys, what do we do in this particular case is that when it comes to the net external force over here, I want you guys to understand. We say net external force in this particular case is 0. We say here not net external force. We say net external torque. In this particular case, we will be considering 0. Okay. So net external torque in this particular case is 0. Or directly you say angular momentum will be in this particular case conserved. So means initial angular momentum is equal to final angular. Now you tell me one thing. My dear NEET aspirants, initial angular momentum. See, here I will not use I into omega. Why, sir? Because this is a point. This is not a purely rotate. This is a body which is moving in a circle. Angular motion. Motion of a point mass. Sir, here I'll use L is equal to mvr. In case of a purely rotating body, we prefer to use L is equal to I omega. Now, this mass over here, what is the angular momentum of this mass initially? You say, sir, that is m is the mass, v is the velocity, sorry, v naught, and r naught is the radius. With respect to center, it is rotating now. So mv, v naught, r naught. Sir, finally mass is m. Finally velocity is, let's suppose, v naught. Okay. 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 Finally velocity is v naught dash. Let's suppose it. And finally, radius, I can say in this particular cases, r naught divided by 2. Now tell me, this m and m will cancel, r naught will cancel. So v naught dash will be 2 times of v naught. So this will be the final velocity. This will be the final velocity. This will be the final velocity. Now, my dear NEET aspirants, what I want you to understand in this particular case, once you get the final velocity, can you tell me final kinetic energy? That is what you are supposed to find out. 1 by 2 m v final square. 1 by 2 m. What is the value of final velocity? 2 v naught square. Okay. So this is 1 divided by 2 m. 2 square is 4 v naught square. 2 ones are 2 twos are 4. 2 m v naught square. That is kinetic energy final. Okay. I hope this is clear. I hope this question is also clear. Okay, so this was the conservation of angular momentum. This was the conservation of angular momentum. Okay, yes, sir, absolutely, sir. This was the conservation of angular momentum. I want you to understand this very carefully. Now, guys, okay, one more thing I just want to tell you over here. Okay, just one small concept, that is what we call toppling. That is what we call toppling. Okay, now see. Now see, let me make you understand this toppling over here. See, guys, since rolling is deleted, that's why I did not touch rolling at all. Rolling is not in your syllabus. So this is, my dear NEET aspirants. Let's suppose this is a block. There is a block placed over here. This is a block. This is a block placed over here. Okay, yes. Now in this particular case, let's suppose if F force is applied on the object placed at the surface. Let's suppose I am applying F force. This force F. Understand this very carefully. Okay. Okay. Yes. What is the force applied on this block due to the surface? That is a normal reaction. Absolutely, sir. If F force is applied on the object placed on the surface with sufficient friction, friction here is sufficient. Okay. Absolutely, sir. Friction here is sufficient. Okay. it will topple. It will topple. Why? Listen to me very carefully. I'm making the same diagram over here. I'm making the same diagram over here. This is the diagram. Okay. Now, in this particular case, this is what we call topple. It will not slide, it will topple. This is what we call topple. So in this particular case, normal reaction will act over here where there is contact, and this is the force. This is the force. Sir, why does a body actually topple? Why does a body actually topple? Because of the friction. Because of the friction, you have got a sufficient friction in this particular case. That's why I am saying we said toppling is taking place. And on this body, I would say in the downward direction, there is a force that is what we call mg. That is what we call mg. Okay. So if F force is acting on the body placed on the surface with, I would say, sufficient friction, it will topple. It will topple. As we keep on moving, as we keep on increasing the force, as we keep on increasing this force, okay, the body makes the contact with the surface only at the toppling point. Only at the toppling point. Okay. We say when force F is applied on the block, just a second, again this got disconnected. Apple Pencil. Okay. Let's take a look, guys. When force F is applied on the block with sufficient friction, When force F is applied on the block with sufficient friction, then it will topple. Topple means this is CCC. Topple means this is what we call topple. This is what we call topple. Okay. Now, my dear NEET aspirants, before toppling, okay, before toppling, when the body was about to topple, so before toppling, we say normal force was acting somewhere around over here. When you keep on increasing the force, body started toppling, we say normal force has shifted from this point to toppling point. Because why? Because now the body is in contact with the surface only at one point, so normal reaction will act only at that point. Without a shadow of doubt, sir. 100%, 100%. Okay. So basically, in this particular case, why does normal reaction shift? We say normal reaction shifts so that it saves the body from toppling. I would say normal reaction shifts so that it saves the body from toppling. Normal reaction shifts so that it saves the body from toppling. Okay. Okay. And normal will be exactly at the end point when the body is about to topple. The body is about to topple. Okay. Now, my dear NEET aspirants, what I want you guys to do in this particular case, that is the concept of toppling. That is the concept of toppling. What I want you guys to do, so basically, when you keep on increasing the force, when the body was about to topple, so normal reaction keeps on shifting. And when it is about to topple, now it will 100% topple. So at that point of time, it will be at the end point. It will be at the end point. That is what we call the toppling point. This is what we call toppling point. Toppling point. Now, my dear NEET aspirants, one more important thing. One more important thing. What is that? We say, when the body is about to topple, we say when the body is about to topple. Topple. Body has not started toppling yet. See. I'm applying the force, maximum force. If I increase little bit, just 0.1, the body will topple. Means till the toppling, till the body, basically, till it starts toppling, we say net torque on the body is zero. But that is why it is not toppling yet. When it starts toppling, torque will be there. But right now, net torque is zero. When the body is about to topple, we say in that particular case, net torque on the body will be zero. Net torque on the body will be zero. When the body is about to topple, in that particular case, net torque on the body is zero. Okay. Net torque on the body is zero. Okay, about this point P, about toppling point. Toppling point. Now, if I say in this particular case, my dear NEET aspirants, what are the forces which can create the torque over here? Friction, normal mg, normal reaction, this F. These are the four forces which can create the torque. So I can say in this particular case, my dear NEET aspirant, so torque due to normal reaction plus torque due to friction plus tau due to mg plus tau due to external force. Net of all of these will be zero. When the body is about to topple, it has not started toppling yet. Okay. Now, my dear NEET aspirants, in this particular case, since this is normal reaction is passing through the toppling point, so torque due to this will be zero when the force acts at the we say on the axis. When the force acts on the axis, we say normal reaction will be zero. Even torque will be zero. Even torque due to this will be also zero. It is also acting at the toppling point. Okay, so I would say in this particular case, torque due to normal reaction is equal to torque due to friction, and it will be 0. Because reason is both passes through axis of rotation or toppling point. Passes through toppling point. Both passes through toppling point. Okay. So my dear NEET aspirants, what you can do further is, listen carefully. What you can do further is, you'll say, sir, in this particular case, guys, listen to me very carefully. In this particular case, what remains? Torque due to mg plus torque due to external force. It will be equals to 0. Now see, what is torque due to mg? Guys. Length of this is L. So this is mg acting at the center. What is the distance from mg till the end point? That is L by 2. Yes. And this force is acting over here. This force is acting on this. And what is this length? This is also L, because this is a square. So I'll say mg into L by 2, because from mg to toppling point it is L by 2, plus in this particular case F into L, it will be equals to 0. Okay, now let's find the direction of the torque. So this will be anti-clockwise. Due to this, it will be clockwise. So one must be positive and another must be negative. One must be positive, another must be negative. One must be positive, another must be negative. Now take it over there. mg L divided by 2 will be equals to F into L. Now L and L will be cancelled. So this external force will be equals to mg divided by 2. Now this is the minimum value of force due to which body topples. This is the minimum value of force due to which body topples. This is the minimum value of force due to which body topples. Okay. Yes. I hope you got the concept of toppling completely, huh? Okay. Now, guys, I'll show you 2 3 more questions. Let's take a break. Let's take a break of 5 minutes. Okay, then I'll be back. Now, guys, let's take a look at this particular question. Let's take a look at this question. The question is something like this. We say, the question is, a uniform disk, a uniform disk a uniform cube of mass m and side A rest on a rough horizontal horizontal table at a point directly below the center. Okay, directly below the center of the face at a height a by 4 above the base. Above the base, a horizontal force, a horizontal force F is applied. A horizontal force F is applied normally. Normally, calculate the least value of force. Least value of force F for which cube topples. For which cube topples. See, guys, a uniform cube of mass m and side A rests on a rough horizontal table. See, guys, you have got, let's suppose there's a table. Okay. On this table, you are placing a cube. You are placing a cube. This is the cube you are placing. Okay. This is the cube. Check. Okay, now guys, take a look. Certain questions we need to do. We are done with the toppling. Okay, I hope this question I was audible when I was explaining this question. Okay, you are having this block. In this particular case, it says what should be the value of this acceleration so that the body topples. In this particular case, when the block is about to topple, net torque is equal to 0. So this is the toppling point. So whenever the observer is in the non-inertial frame, means if this is the acceleration of the platform, consider pseudo force will act on this in the backward direction. That is m into a naught. A naught that is the acceleration of the truck. Downward mg, this is normal reaction, this is friction. Now when the body is about to topple, net torque in that case is 0. And so torque will be due to F, mg, normal reaction, pseudo. So here I would say torque due to this friction is 0 because it is passing through toppling point. Torque due to normal reaction is also 0 because it is also passing through this. So torque will be due to this pseudo and mg. That's what I did. Net torque is due to pseudo force and mg is equal to 0. Due to this, F into c by 2, mg a by 2. From here we got acceleration. Now there is a question which I want to show you over here. There is the angular speed of the wheel of a vehicle is increased. Okay, from 360 rpm to 1200 rpm, rotation per minute, in 14 seconds. In 14 seconds, its angular acceleration is see guys. So this rotation per minute. So in this particular case, what is frequency initially? 360 rpm. Can you convert this to the seconds? Rotation per second, revolution per second. So this is 360 divided by 60. This and this will cancel. 6 ones are 6 6s are 6 rev per second. You can write it like this. And finally, my dear NEET aspirants, can I say finally it says 1200 rpm. So if you want to convert this, this will be 1200 divided by 60. This 6 ones are 6 2s are 12, 6 zeros are. So this will be 20 rpm. 20 rev per second. Okay. Okay. Yes. Now, my dear NEET aspirants, you got frequency. Can you find, and then it says its angular acceleration is, we'll tell you angular acceleration. First, you tell me, what is the initial angular velocity? Omega I. This is frequency initially. That is 2 pi f. So 2 pi, what is the value of f? That is 6. So 2 into 6 is 12 pi. Okay. What is final omega? 2 pi into f. So basically from this, whenever you are given rotation per minute, revolution per second, in that particular case, my dear NEET aspirants, just now guys see omega final is equal to 2 pi f. Okay. So this will be 2 pi. What is the value of f over here? That is 20. Okay, that is 40 pi. So whenever you are given this frequency, you can find omega 2 pi f, 2 pi f. Now what does it say angular acceleration? Now it is simple. Why? Because final angular velocity is equal to initial angular velocity plus alpha into t. Okay, time is also given 14 seconds. So Final angular velocity minus initial angular velocity is equal to alpha t. So alpha will come out to be omega final minus omega initial divided by t. Alpha will come out to be final angular velocity. What is final angular velocity? 1200 rpm. What is initial? 360. What is time? That is 40. Ha 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 ha. Wait. Sorry. I calculated this now. 40 pi minus 12 pi. 40 pi minus 12 pi. Alpha will come out to what is 40 minus 12. Okay. So this will come out to be 2 pi radian per second square. This came out to be the acceleration in this particular case. And similar type of question I will give you, but this is your homework. This is NEET 2022. The angular speed of the wheel of a vehicle is increased from 1200 rpm. Okay, similar question, to 3120 rpm in 16 seconds. Okay, its angular acceleration is don't you think it is exactly the similar question, similar pattern we are supposed to use over here, and we'll get the answer of this question also. Exactly similar. Okay, it is exactly similar. And in this particular case, I would mention the answer directly. Alpha is 4 pi rad per second square. It will be 4 pi rad per second square. There is a question which was asked in NEET 2023. See guys, the angular acceleration of a body moving along the circumference of a circle. The angular acceleration of a body, okay, moving along the circumference of a circle, moving along the circumference of a circle is I'll give you the options also. Option was along the radius away from the center. Option B, along the axis of rotation. Option C, along the tangent. Option D, none of these. Okay, I want you guys to think about it and let me know the answer. Okay, this is a question from NEET 2022. It's a question from NEET 2022. See, guys, listen to me very carefully. Whenever, let's suppose I say there's a circular motion. Okay, there's a circular motion. Whenever an object, this is the object, let's suppose its mass is m, it's moving with the velocity v. It is moving in a circle. It is moving in a circle about this axis. So guys, it is moving in a circle. It will have angular velocity, angular speed, angular velocity. How fast it is rotating, that is omega. Okay, it will have angular velocity, how fast it is rotating. It will have angular acceleration alpha. Okay, it will have angular displacement, how much angle it has covered. Angular displacement, angular acceleration, angular velocity. Okay, it will have torque, how much torque is acting on this particle. All of these are axial vectors. Axial vector means this is the axis around which this particle is revolving. So this is called axis of rotation. So my dear NEET aspirants, in this particular case, the direction of all these, omega, alpha, theta, tau, it is along the axis of rotation. It will be along this. Sir, but you said previously torque is clockwise, anti-clockwise. That is just, see, let's suppose you have to find the direction of the torque. This is R and this is F. Let me just tell you how to find the exact direction of torque. Place your thumb along the direction of it is what is the value of R cross? What is the value of torque? That is R vector cross F vector. Place your thumb along the direction of radius. Okay, it is R cross F. Okay, and fingers along force. Place your thumb along direction of this radius, fingers along force. This is called palm. This is the right hand. This is my right hand. This is called palm. Palm gives you the direction of torque. So torque in this particular case will be outwards. Outwards means dot. Outwards. Okay, this is the torque. This is how do we exactly find the torque. Like in this particular case, guys. If I say on this object, force is acting in this direction. This is the radius R. This is the radius R. Now, how do you find the direction of R cross F? Place your thumb along the direction of R. Place your thumb along the direction of R. And fingers along force. Fingers along force. This palm is facing upwards. So that's what I was saying. Sir, torque in this case is upwards. Now, when the object reaches here, let's